Greetings, everybody. My name is Tech G, and I want to welcome you all to my CompTIA Tech Plus FC0-U71 course. And the information that I will be presenting in this course is going to give you everything you need to know to successfully pass the CompTIA Tech Plus exam, assuming you study properly. Now, according to CompTIA, the Tech Plus exam is the cornerstone certification for those venturing into tech-related careers. It provides a wide spectrum of foundational tech knowledge and hands-on skills, helping those interested in getting certified become confident and tech-savvy. CompTIA Tech Plus lays the foundation for tech-related careers by helping certification candidates do the following. First one is empowering careers with tech know-how. So CompTIA Tech Plus is the certification that equips individuals with the basic tech understanding needed to succeed in technology-based roles. Then it can broaden your career horizons, and it provides the tech literacy essential for today's digital economy, making it the perfect starting point for anyone looking to enhance their career with technology skills. And then it helps you master fundamental tech skills. It covers all the bases from basic concepts and security to software development, ensuring a well-rounded tech education that's easy to use in any learning setting. So let's talk about who is going to benefit from the CompTIA Tech Plus. And this will be students and aspiring professionals that want to kickstart their careers with a solid foundation in tech fundamentals. Tech adjacent workers, they can gain the tech literacy needed to enhance job performance and efficiency in tasks that intersect with technology. And also lifelong learners, they can stay ahead of their industry's digital transformation by future-proofing their skills with practical tech knowledge. Now, why would you benefit from the CompTIA Tech Plus? So you can gain a solid foundation in tech fundamentals with hands-on simulations, doing tasks such as setting up a computer and securing a small wireless network. Plus, this course introduces emerging technologies such as artificial intelligence, robotics, quantum computing, and more. Also, did you know that IT jobs are expected to grow at nearly double the national estimated growth rate? According to the U.S. Bureau of Labor Statistics, tech jobs are projected to be among the fastest growing occupations from 2023 to 2033. And also, according to Lightcast, U.S. active job postings from January 2023 to December 2023, employers listed 8.95 million job postings in the U.S. seeking candidates with digital and tech fundamental skills during 2023. All right, so let's talk about the types of skills that you're going to learn. So the CompTIA Tech Plus exam will focus on 6 primary areas of study, which are also known as domains. You have domain 1. This is IT concepts and terminology. This is going to make up 13% of the exam. And this domain mainly focuses on the comprehension of notational systems, illustrating the basics of computing, and explaining the value of data and troubleshooting. Domain 2 is infrastructure, and this is going to take up about 24% of the exam. And this domain will teach you how to set up and install common peripheral devices to a laptop or PC, or secure a basic wireless network. You have domain 3. This is applications and software, and it's going to take up 18% of the exam. And this domain will teach you how to manage application software, understand the various components of an operating system, and explain the purpose of methods of application architecture. Then we have domain 4, and this is software development concepts, and this is going to take up 13% of the exam. And this domain will help you with comprehending programming language categories, interpreting logic, and understanding the purpose of programming concepts. Then we go on to domain 5. This is database fundamentals, and this will take up 13% of the exam. And this domain will help you to be able to explain database concepts, structures, and purposes, as well as understanding methods used to interface with databases. And then we have domain 6, and this is security, and this is going to take up 19% of the exam. And this domain will help you to understand a concept known as the CIA triad, which stands for confidentiality, integrity, and availability, as it relates to securing devices along with best practice methods. All right, so let's go ahead and talk about the exam details. So the CompTIA Tech Plus FC0-U71 exam, it was launched on August 13th, 2024. Now, at the time of this recording, CompTIA has not scheduled a retirement date for this exam, but normally 3 years after the launch of an exam is when you can expect CompTIA to officially retire a version of an exam. And the Tech Plus exam has a maximum of 60 questions that will be presented in multiple choice format. You will have 60 minutes to complete the exam. Now, in order to pass the exam, you must score 650 points out of 900 points, which translates into you scoring roughly a 72% to pass. And the candidate taking this exam does not need any prior IT experience, and this exam is mostly designed for high school students and other non-IT professionals. Now, at the time of this recording, English is the only language this exam is administered in, and the company responsible for administering the test is Pearson VUE Testing Centers. And finally, the cost of the CompTIA Tech Plus exam has not been posted, but it will more than likely be around the price of the CompTIA IT Fundamentals exam, which at the time of this recording is $138 for an exam voucher. Now, for those of you interested in getting discounted CompTIA exam vouchers, you can visit my website, technologyg.com, or check the links in the description so that you can save a few bucks instead of paying full price for these exam vouchers. Now, with that being said, let's go ahead and get into these lessons to help you successfully pass the CompTIA Tech Plus FC0-U71 certification exam. In this video, we're going to cover the basics of computing, focusing on 4 key components: input, processing, output, and storage. And these components form the foundation of how computers work and are essential for understanding computing at a fundamental level. All right, first up, let's talk about input. So input is how data enters the computer system. In simple terms, input devices allow users to communicate with the computer by sending it data and instructions. And common input devices include the following, such as keyboards. This is one of the most familiar input devices. So every time you type a command, search a term, or type on a document, you're using a keyboard to input that data into the computer. Then we have mice. A mouse, this allows you to move a pointer and select or manipulate objects on the screen. So every click and movement translates into input. Then we have what are called touch screens. So think about how smartphones and tablets work. The touch screen allows for direct interaction by tapping, swiping, or pinching, all of which are forms of input. Then we have scanners. These are devices that convert physical documents or images into digital form, and they are also input devices. And we have microphones. So voice input has become more common with the rise of virtual assistants like Siri and Alexa, where your spoken words are converted into data that the system can understand. So input can be anything from pressing keys, clicking a mouse, or speaking into a microphone. And once the data is entered, the next step in the computing process is processing. All right, so processing is the heart of computing, where the system takes the input data and performs operations on it to generate meaningful output. At the center of this processing is the central processing unit, or the CPU. And the CPU is often called the brain of the computer because it handles all of the processing tasks. And the CPU performs 2 critical roles. The first one is arithmetic operations. These include basic mathematical functions like addition, subtraction, multiplication, and division. And then you have logical operations. The CPU makes decisions based on conditions such as determining one value is greater than another. It executes instructions that are part of the software, breaking them down into basic commands the computer can understand. So here's how it works in practice. Suppose you're working on a spreadsheet. When you enter numbers and ask the software to calculate a sum, the inputted numbers go through the CPU, where the arithmetic operations are processed and the result is calculated. The CPU also handles more complex tasks like running an operating system, multitasking between different programs, and executing code behind web pages or software applications. And a crucial part of this process involves the memory, specifically the RAM, or the random access memory. And RAM, it temporarily holds data that the CPU is currently processing. So think of it as a short-term memory space for the computer, allowing the CPU to access and process data quickly. And then after processing is complete, the results are sent to the next stage, which is called output. So output is the result of the data that has been processed by the computer. It's how the computer communicates the results back to the user. Output devices make this possible by taking the processed data and presenting it in a usable form. And examples of common output devices include the following. You have monitors. These are also called display screens. And monitors, they provide visual output. Everything you see on the screen, from your desktop to a video or a spreadsheet, is output generated by the computer's processing of data. Then we have printers, and printers take digital data and produce physical output like a printed document or image. Then we have speakers. For audio output, speakers convert data into sound, whether it's music, a podcast, or an alert. The processed data is transformed into something that you can hear. Then we have projectors. These devices take the visual output from the computer and project it onto a larger screen, often used for presentations or media viewing. So for example, let's say that you're editing a photo on your computer. The monitor displays the changes you make in real time. The CPU processes each adjustment like brightness or contrast, and the output is instantly reflected on the screen. Just as input can be in different forms, such as text, images, voice, output can also vary. The important thing to remember is that output always represents the process result of the data initially entered into the system. And finally, we come to storage. So storage in computing refers to saving data for future use. And there are two main types of storage you should be aware of. The first one is your primary storage, or RAM. So as mentioned earlier, RAM, or random access memory, is where data is stored temporarily while it is being used or processed by the CPU. It's fast but volatile, meaning all data stored in RAM is lost when the computer is powered off. Then we have what is called secondary storage. And this is long-term storage where data is kept even when the system is turned off. And some examples include the following. You have what are called hard disk drives, and these are traditional storage devices that store data magnetically on spinning disks. Then we have what are called solid state drives, and these are a faster and more reliable alternative to hard disk drives. And SSDs, they store data on what are called flash memory chips. Then we have what is called optical storage. So CDs, DVDs, and Blu-ray discs are examples of optical storage where data is read and written using laser technology. And then we have what is called cloud storage. So data is stored on remote servers and accessed over the internet. And examples of this include Google Drive, Dropbox, and iCloud. So storage devices are used to save data, files, and applications that we might need later. And here's an example. So when you save a document on your computer, it's written to the storage device, such as the SSD or the HDD. So the next time you open the document, the system retrieves it from storage so you can continue working. In modern computers, they rely on a combination of fast, temporary memory such as RAM and larger long-term storage such as a hard disk drive or an SSD. As technology advances, storage devices have become faster, more compact, and more efficient. So now that we've covered input, processing, output, and storage, let's bring everything together with an example. So imagine you're writing a document on your computer. Here's how each of these elements work together. First one is input. So you use the keyboard to type, which sends data into the computer. Then we have processing. The CPU processes that data, understanding what you're typing, formatting it, and preparing it for output, which leads us to output. The words you've typed appear on the monitor as a visual output. And then we have storage. When you click the save button, the document is stored on the computer's hard drive or SSD, allowing you to retrieve it later. So this cycle of input, processing, output, and storage happens constantly and seamlessly as we interact with computers. Whether you're sending an email, editing a photo, or browsing the web, these four basic components are at the heart of everything a computer does. All right, now with that being said, let's go into our check on learning to see if you all are comprehending this information. So first question is, which of the following is an example of an input device? Would it be a monitor, a keyboard, a printer, or a speaker? And of course, the correct answer to this is a keyboard. So input devices, they allow users to provide data to a computer. A keyboard is an input device because it enables the user to enter data and commands. Monitors, printers, and speakers are examples of output devices which display or output data from the computer. Next question. What is the primary function of the CPU, or the central processing unit, in a computer system? Is it A, to store data, B, to execute instructions, C, to display graphics, or D, to provide power to the computer? The correct answer is it executes instructions. So the CPU is often referred to as the brain of the computer. Its main function is to execute instructions from programs and manage the processing of data. While other components handle storage, power, and display, the CPU processes and executes the computational tasks. And then our final question is, which of the following best describes the function of RAM or random access memory in a computer? Is it A, long-term data storage, B, the processing of data, C, temporary data storage for active processes, or D, providing power to the CPU? The correct answer is it is temporary data storage for active processes. So RAM is a type of volatile memory used for temporarily storing data that is being actively used by the CPU. Unlike long-term storage, such as hard drives or SSDs, RAM holds data only while the system is running and is cleared when the computer is turned off. In this video on notational systems, we'll be exploring the four major number systems, such as binary, hexadecimal, decimal, and octal. Each of these systems plays a crucial role in computing, and understanding how they work is essential for anyone preparing for the CompTIA Tech Plus certification exam. All right, so let's begin with the decimal system, which is the one most of us are familiar with. So the decimal system is also known as base 10. It uses 10 digits ranging from numbers 0 to 9, and each digit in a number has a place value that is a power of 10. And this is the system we use in everyday life for counting and performing arithmetic. So for example, in the number 453, the 4 represents 400s, or 4 times 10 to the second power, which equals 400. The 5 represents 5 tens, or 5 times 10 to the first power, which equals 50. And the 3 represents 3 ones, or 3 times 10 to the 0 power, which equals 3. So 453 in decimal equals 400 plus 50 plus 3. So while the system is great for human use, computers find it less efficient because they operate electronically in a way that's better suited to a binary system. And this brings us to our next topic, which is the binary system. So the binary system, this is the fundamental language of computers. It is also known as base 2 and uses only 2 digits, 0 and 1. In binary, each place value represents a power of 2, starting with 2 to the 0, 2 to the first, and 2 squared, and so on. Binary is used by computers because at the hardware level, everything is represented as electrical states, typically on and off, which can be efficiently represented by ones and zeros. So let's take the example right here. The binary number 1011 is represented like this. The leftmost 1 is in the 2 to the third position, which equals 1 times 2 to the third, which equals the number 8. The 0 is in the 2 squared position, so you take 0 times 2 squared, and obviously that equals 0. Then we have the next one, which is in the 2 to the first position, so that'll be 1 times 2 to the first, and that equals 2. And then the last one is in the 2 to the 0 position, and that equals 1 times 2 to the 0, which equals 1. So when you add up all those numbers, 8 plus 0 plus 2 plus 1, that equals 11. So the binary number 1011, this equals 11 in decimal. Now, why is binary important? Well, computers use binary because digital circuits, such as processors and memory, only understand 2 states, on and off. And these states can be represented perfectly by ones and zeros in binary notation. All right, next up is the hexadecimal system, or base 16. So the hexadecimal system uses 16 symbols, the digits 0 through 9, followed by the letters A through F. And the letters represent the decimal values 10 through 15. So A equals 10, B equals 11, C equals 12, D equals 13, E equals 14, and F equals 15. Hexadecimal is often used in computing because it can represent large binary numbers more compactly. So for example, 1 hexadecimal digit represents 4 binary digits, or bits. And this is why hex is frequently used in memory addresses and color codes in computing. So let's break down an example. So we have the value 2F in hexadecimal. The 2 is in the 16 to the first place, and that represents 2 times 16, which equals 32. And the F represents 15, and it's in the 16 to the 0 place. So 15 times 1 equals 15. So add these together, gives you 32 plus 15 equals 47. So 2F in hexadecimal notation is equal to the number 47 in decimal notation. Now, converting between binary and hexadecimal is also straightforward. So let's take the binary number 1010, 1 1111. If we group the binary digits into sets of fours, we get 1010 and 1111. And these groups are as follows. So 1010 is A in hexadecimal notation, and 1111 is F in hexadecimal notation. So basically the binary number 10101111, that essentially becomes AF in hexadecimal notation. Now, I know a lot of y'all are probably listening to this and you are extremely lost and confused right now, but do not worry. TechG is here to save the day. I have created a video showing you how to convert from decimal to binary to hexadecimal and vice versa so that you can go out there and become a notational systems conversion superstar. So that video will be included in this playlist so that you can go out there and make it do what it do. All right, next let's talk about what is called the octal system. So the octal system, or it is also known as base 8, and this uses the digits 0 through 7. So like binary and hexadecimal, octal was also used in computing, although it is less common today than hexadecimal. In the octal system, each place value represents a power of 8. And octal was historically used because it's easier to convert binary numbers into octal. So for example, groups of 3 binary digits can be directly converted into one octal digit. So for example, let's look at the octal number 745. So the 7 is in the 8 to the second place. So that means you have 7 times 64, and that gets you 448. The 4 is in the 8 to the first place, and that means you have 8 times 4, which equals 32. And then you have 5, which is in the 8 to the 0 place, and that means 5 times 1 equals 5. So you add up all those numbers together, 448 plus 32 plus 5, that equals 485. So the number 745 in octal notation equals 485 in decimal notation. Now, why was octal used? So in early computing systems, octal made it easier to read and process binary numbers because computers often work with 12-bit, 24-bit, or 36-bit systems. Since 3-digit binary digits perfectly convert to one octal digit, it was more efficient to use in certain environments. All right, so to wrap all of this up, here is a quick recap. So decimal, also known as base 10, is the system we use every day for counting and arithmetic. Binary, which is known as base 2, is the language of computers representing data in zeros and ones. Then we have hexadecimal notation, also known as base 16. This is used to represent binary data more compactly with digits ranging from 0 through 9 and A through F. And then we have octal, or base 8, and this was historically important in computing, especially with older systems, and it uses digits 0 through 7. Now, understanding these systems and knowing how to convert between them is crucial for working with computers and is a key part of the CompTIA Tech Plus certification exam. All right, now with all of that being said, let's get to the check on learning. So the first question is, what is the main difference between the binary and hexadecimal numbering systems? Is it A, binary uses 0 through 1, while hexadecimal uses 0 through 9 and letters A through F? Is it B, binary uses 0 through 9, while hexadecimal uses 0 through 9 and letters A through Z? Is it C, binary uses 0 through 2, while hexadecimal uses 0 through 7? Or is it D, binary uses 0 through 9, while hexadecimal uses 0 through 15? And the correct answer would be A. So the binary system is base 2 using only digits 0 and 1. The hexadecimal system is base 16 using digits 0 through 9 and the letters A through F to represent values 10 through 15. Next question. Which notational system is commonly used for representing memory addresses in computer systems? Would it be A, binary, B, decimal, C, hexadecimal, or D, octal? And the correct answer would be hexadecimal. This is commonly used to represent memory addresses because it is more compact than binary and provides a straightforward mapping to binary values, making it easier for humans to read and understand. And our final question, which number system uses a base of 10? Would it be A, binary, B, decimal, C, hexadecimal, or D, octal? And the correct answer would be decimal. So the decimal system, which is also known as base 10, is the most commonly used numbering system in everyday life and uses the digits 0 through 9. In this video, I'm going to show you guys how to convert decimal numbers into binary, binary into hexadecimal, hex into binary, and binary back into decimal so that you can look like a superstar out on these streets with these conversions. So let's get into it. First thing we need to understand, ladies and gentlemen, is what is decimal, what is hexadecimal, and what is binary. So all of you out there, you all know what decimal is. This is the base 10 numbering system that you guys learn how to count your fingers and toes when you were in preschool. And that is numbers 0 through 9, 0 through 9 or 1 through 10, but we refer to it as 0 through 9 over here in the IT world. Next, we have hexadecimal. Hexadecimal represents base 16 values, base 16 numbers, right? And how this works is you have the same numbers 0 through 9 over here, but then when you get to the number 10, instead of it becoming the number 10, it is represented by the letter A all the way through the letter F, which stands for 15. So A through F, A, B, C, D, E, F, all of those letters represents numbers 10, 11, 12, 13, 14, and 15, okay? And then we have binary. This is powers of 2 or base 2 mathematics. And this represents zeros and ones, which stand for off and on. So in binary, what happens is we're going to take what is called an IP version 4 address. You guys have seen these before. It'll be some number here, dot some number here, dot some number there, dot some number there. That represents an IP address. And if you guys aren't familiar with IP addresses, go check out my IT Fundamentals course where I explain all of this to you. But a lot of you guys are familiar with IP addresses. You're just familiar with the names that are associated with them. Like if you type in youtube.com, or youtube.com is associated with an actual IP address. So think of the IP address as the house number to the house that you currently live in. Okay. Now, how binary relates to the IP version 4 that we're looking at here, we're only going to be focusing on what is called the 4th octet. This is octet 1, octet 2, octet 3, and octet 4. We're going to be focusing on the 4th octet so that we can try to figure out which bits to turn on and off, zeros and ones. And so first things first, we have to lay out the binary numbering system. So it goes like this. It goes from number 1, 2, 4, 8, 16, 32, 64, 128. This red decimal point represents the break in the 4th octet. Then we're going on to the 3rd octet. But as you can see, all of these values double themselves by a power of 2, and it just keeps going on and on and on. So we got to get this down packed first, because this is what is going to help us go through our conversion process, right? And how the actual conversion process works is if you want to go from decimal to hexadecimal, you're going to have to use binary as the middleman. If you want to go from hex back to decimal, you're going to have to use binary as the middleman. So I'm going to show you guys how to do this. It's really simple. Don't sweat it. You'll be doing this like a boss by the time I'm done with this video. All right, so let's do our first example of how to convert decimal to binary. So in this example, we're going to convert the decimal number 175 into its binary equivalent. So the first thing that you're going to want to do is you're going to want to lay out all of your powers of 2s like I just showed you, from the 4th octet, numbers 1, 2, 4, 8, 16, 32, 64, and 128. And now we're going to turn on the values that actually add up to the number 175. Because if you recall, I just stated in binary, we work off of ones and zeros. Ones represents a value or a bit is turned on, and 0 represents a value or a bit is turned off. So in order for us to get 175, we have to turn on the number 128, the number 32, the number 8, 4, 2, and 1. You add all those numbers up together, you get 175. Real simple stuff, right? I know. All right, let's take this problem one step further. So we're going to go ahead and convert the decimal number 175 into its hexadecimal equivalent. Now, if you recall, I stated that in order to go from decimal to hexadecimal or from hex back to decimal, you have to go through binary as the middle guy. All right, so now let me go ahead and explain what all this madness on your screen means, okay? So we have the decimal number 175, and we've already figured out how to solve for its binary equivalent, and that will come out to be 1010111. Now, remember, I stated that this was basically the fourth octet, right? The last octet of an IP address. I have this blue line right here going down the middle because when we go through the process of converting it into hexadecimal, we're only going to be focusing on what is called a nibble, an N-I-B-B-L-E. This is basically half an octet that we're going to use for our conversions, okay? So we got our binary 1010111. We're going to move it down here. Now we're going to break this down into two groups of fours or two groups of nibbles, right? We're just going to draw a line straight down the middle just like I did. Being that we're only operating off of half of an octet, we're only going to basically apply half of the powers of 2 conversion. So we have 1111. So basically the values 1, 2, 4, and 8 have all been turned on. And then we're going to apply the same 1, 2, 4, and 8 over here. So as you can see, the value 8 and the value 2 have been turned on. And now we're going to go ahead and just start adding numbers up. 8 plus 2 is what? 10. 8 plus 4 plus 2 plus 1 equals what? 15. So now we have 10 and we have 15. That is what these nibbles break down into. So now we have to go ahead and figure out what do these values mean as it relates to hexadecimal. So if you look over here, remember I told you hexadecimal numbers, they represent numbers 0 through 9 and letters A through F, where A through F represent numbers 10 through 15. So now that we have the number 10 over here, well, A equals 10. F equals 15. So the decimal number 175 equals the hexadecimal value AF. Now, if you want to go ahead and check your work real quick to verify that you know what you're doing, you can just go to Google and type in decimal to hexadecimal converter, and you just type in the number 175 and it will show you the conversions right here. Here's your hexadecimal value and here is your binary value that I was showing you earlier on this screen. All right, so now let me give you an example of how to go from hexadecimal all the way back to decimal. So in this example, we have the hexadecimal value of B2. We're trying to figure out what its decimal equivalent is. So what we're going to do with the B2, we're going to go ahead and convert it to binary, because remember, to go from hex to decimal, you got to go through binary. From decimal to hex, you got to go through binary. So we're going to go ahead and apply our middleman. So what we're going to do, we're going to take our B2 and we're going to divide it into its own little sections here of B and 2. And then we're going to come back over here and figure out what its equivalent is in its nibble notation. So remember, we're working with the number 2. So we got to come down here and do our 1, 2, 4s, and 8s that represent our nibbles so that we can figure out which value is actually turned on. So out of 8, 4, 2, and 1, the only value that is turned on is the value number 2. So that'll be 0, 0, 1, 0. Then we come over here to the letter B. If you look back up here, remember in hexadecimal notation is expressed in numbers 0 through 9 and A through F, where the letter A equals 10 and the letter F equals 15. So B would be the number 11. So 11 equals B. We go here and look at our nibble, 1, 2, 4, and 8. We add the values that are turned on. So it'll be 8, 2, and 1. 8 plus 2 plus 1 equals 11. And then we just put them all together. And this is what our binary equivalent for B2 is going to look like. It's going to be 1, 0, 1, 1, 0, 0, 1, 0. Now we're going to take this and we're going to figure out what our decimal equivalent is. So now we're going to come back to the fourth octet, the entire thing. 1, 2, 4, 8, 16, 32, 64, 128. We're going to take our binary equivalent and figure out which of these values are turned on. As you can see, values 128, 32, 64, and 2 are turned on. We're going to come up here and just add those numbers together. 128 plus 32 plus 16 plus 2, and that will get you 178. So the decimal equivalent of the hexadecimal value B2 is the number 178. And like always, if you're unsure, you can just run over to Google and do a check to verify that you added your numbers up correctly. So as you can see, I put B2 up into the converter. We got our decimal equivalent of 178, and then we have our binary equivalent of 10110010. And for my last trick, ladies and gentlemen, I'm going to show you how to convert a hexadecimal number that has 3 values back into its decimal equivalent. So if we look at our screen here, we have the hexadecimal values A, B, and C. Okay, so first thing we got to do, we got to convert A, B, and C back into its binary equivalent, because binary is the middleman. Also remember, hexadecimal values are the numbers 0 through 9 and the letters A through F, where A equals 10 and F equals 15. 15. So we go through, we take ABC and we break it down into its individual groups. And then we figure out, what do these values represent? Well, A equals 10, B equals 11, and 12 equals C. We go ahead and apply our little nibbles that I was talking about here with 8421, 8421, 8421. We figure out which values are turned on that add up to this number right here. So 8 plus 4 equals 12, 8 plus 2 plus 1 equals 11, 8 plus 2 equals 10. So this is our binary equivalent of ABC, 101010111100. Now we're going to move on down to converting this into its decimal equivalent. So now we're going to apply the entire octet again. So remember, 1, 2, 4, 8, 16, 32, 64, 128. Now if you look right here, I have a little red dot right here that indicates the separation between the fourth octet and the third octet. So this value ABC is going to drag us out into the third octet. So what we're going to do, we're still going to apply the powers of 2. So 128 plus 128 is going to get us 256. 256 plus 256 is going to get us 512, then 1024, 2048, and so on and so forth. So now we're going to take our binary value and just figure out which of these numbers are turned on. As you can see, 2048's on, 512, 128, 32, 16, 8, and 4. Come up here, add up all these numbers together. 2048 plus 512 plus 128 plus 32 plus 16 plus 8 plus 4. That's going to get you the decimal equivalent of 2,748. So the hexadecimal value ABC equals 2748. And like always, you could just run over to Google and check your work if you want. So as you can see, hexadecimal number ABC, decimal value 2748, binary value down below. In this video, we're going to be talking about units of measure in computing. So for those studying for the CompTIA Tech Plus exam, understanding these common units is crucial. And in this video, we're going to break down the most widely used units of measure in computing, explain what they represent, and then compare them to one another. All right, so let's start with the most fundamental units in computing, which are the bit and the byte. So a bit is short for binary digit, and it's the smallest unit of data in computing. It can have a value of either 0 or 1. So think of it as the basic building block for all digital data. A byte, this is a collection of 8 bits. So 1 byte is typically enough to represent a single character, like the letter A or a punctuation mark. In fact, most of the data we interact with on computers is measured in bytes rather than bits. So for example, a text file containing a short message might be around 100 bytes in size. And it is important to remember that in some contexts, data transfer speeds are measured in bits per second, while data storage is generally measured in bytes. All right, now let's move on to the next levels of units. And we have the kilobyte, megabyte, gigabyte, terabyte, and the petabyte. So these units build upon each other and are used to measure larger quantities of data. So the first one is the kilobyte, and this is 1,024 bytes. Although in many cases, it is rounded down to just 1,000 bytes for simplicity. So to put this into context, a small text document might be around 10 kilobytes in size. Then we have what is called the megabyte. And this is 1,024 kilobytes, or roughly 1 million bytes. And a standard MP3 song file might range from 3 to 5 millibytes. Then we have the gigabyte, and this is 1,024 megabytes, or around 1 billion bytes. Most smartphones today have storage capacities ranging from 64 gigabytes to 512 gigabytes. And a standard hour-long HD video could be approximately 1 to 2 gigabytes in size. Next, we have what is called the terabyte. And a terabyte is 1,024 gigabytes, or roughly 1 trillion bytes. And modern hard drives often have capacities starting at 1 terabyte or higher. And to give you a sense of size, a 1 terabyte drive can hold around 250,000 high quality photos, or 250 full length HD movies. And then we have what is called the petabyte. And this is 1,024 terabytes, or around 1 quadrillion bytes. And to put this in perspective, 1 petabyte is enough to store around 500 billion pages of standard printed text. Large organizations like data centers and cloud storage providers often deal with data at the petabyte level. So for example, social media platforms, search engines, or video streaming services can have data storage requirements in petabytes, given the immense amount of user-generated content that they store. Now, as you move up these units, units from kilobyte to petabyte, the scale of data being measured increases significantly, and understanding these units is crucial when discussing data storage capacity and requirements. All right, now let's discuss data transfer units, which are essential for measuring the speed at which data is moved or transmitted. And the first one we have is bits per second. So as mentioned earlier, bits are the smallest unit of data. And when we talk about transfer speeds, we often use bits per second. So for example, an internet connection might be described as transferring data at 10 bits per second, which is extremely slow by today's standards. Then we have kilobits per second. A kilobit per second is 1,000 bits per second. And historically, dial-up internet connections were measured in kilobits per second, like 56 kilobits per second. Then we have megabits per second. A megabit per second is 1,000 kilobits per second, or 1 million bits per second. And most broadband internet speeds are measured in megabits per second today, like 100 megabits or 200 megabits per second. Now, a common misconception is to confuse megabits per second with megabytes per second. So remember, 1 byte equals 8 bits. So if your internet is 100 megabits per second, your download speed is roughly 12.5 megabytes per second. Next, we have what is called gigabits per second. So a gigabit per second is 1,000 megabits per second, or 1 billion bits per second. And gigabit per second speeds are often associated with fiber optic internet connections and are standard for high-speed networks such as data center connections or enterprise level networking. So for example, a network speed of 1 gigabit per second is capable of transferring around 125 megabytes per second. And then we have terabytes per second. So a terabyte per second is equivalent to 8 terabits per second, or 1,000 gigabytes per second. Terabytes per second speeds are extremely high and typically found in supercomputing environments, data center interconnects, or specialized network backbones. And this speed is used for transferring extremely large volumes of data almost instantaneously, often used in scenarios involving big data processing, scientific research, or high frequency trading systems. Now, understanding these units of data transfer is crucial, especially when comparing the speed and efficiency of internet connections, network transfers, or data communication across different platforms. And remember that higher units like gigabits per second and terabytes per second signify extremely fast data transfer, critical for high performance computing and large scale data movement. All right, the next unit to cover is the hertz, and hertz is used to measure frequency, which in computing often relates to clock speed or the speed of a processor. So we have the standard hertz, so 1 hertz equals 1 cycle per second. In computing, this often refers to the number of cycles a CPU can execute per second. So for example, a CPU running at 1 hertz will be performing 1 operation per second, which is extremely slow. Then we have what is called a kilohertz, megahertz, and the gigahertz. So kilohertz, this is 1,000 hertz. Megahertz is 1 million hertz. Gigahertz is 1 billion hertz. And modern processors are typically measured in gigahertz, such as 2.5 gigahertz or 3.6 gigahertz, indicating that they can perform billions of operations per second. Now, the faster the clock speed measured in hertz, the more operations a processor can perform per second, which generally leads to faster performance. So for traditional hard disk drives, an important unit of measure is RPM, which stands for revolutions per minute. In revolutions per minute, this unit measures how fast the platters inside a hard drive spin. And common RPM values for hard disk drives are 5,400 RPMs and 7,200 RPMs, with higher speeds offering faster read-write performance. Now note that solid state drives do not have RPMs because they have no moving parts. Plus, they're much faster than traditional hard disk drives. Now, understanding RPM is important when comparing the performance of hard drives, as it can significantly impact data read and write speeds. All right, finally, let's cover watts, which measures power consumption in computing devices. Watts measures the rate of energy transfer and are used to describe how much power a device consumes. Devices like laptops might use 30 to 90 watts, while gaming desktops could use over 500 watts, especially if they have powerful CPUs and GPUs. Knowing the wattage is critical for power supply selection in computer systems and for understanding energy efficiency. And understanding watts helps in making informed choices about power requirements, especially when building or upgrading a computer. So in conclusion, understanding units of measure is foundational for anyone studying for the CompTIA Tech Plus certification exam. So here's a quick recap. Bit and byte are the building blocks of data. Larger units like kilobytes, megabytes, gigabytes, and terabytes help measure data storage. Data transfer rates are measured in bits per second, kilobits per second, and megabits per second, which is crucial for understanding communication speeds. Hertz is used to measure frequency and processor speed, such as gigahertz for CPUs. RPM measures the speed of traditional hard drives, which impacts their performance. And watts indicates the power consumption of computing devices. By mastering these units, you'll have a better understanding of how data is stored, transferred, processed, and powered. All right, now it's time for our favorite part of the video, the check on learning. So the first question is, which of the following units is most commonly used to measure the speed of a computer processor? Would it be A, megabytes, B, hertz, C, gigabytes, or D, watts? And the correct answer would be hertz. So the speed of a computer processor is measured in hertz, typically in gigahertz. This indicates the number of cycles a processor can complete per second. Megabytes and gigabytes are units of data storage, while watts measures power consumption. Next question. If a storage device has a capacity of 1 terabyte, how many gigabytes is it equivalent to? Would it be 100 gigabytes, 512 gigabytes, 1024 gigabytes, or 2048 gigabytes? The correct answer is 1024 gigabytes. So 1 terabyte is equivalent to 1024 gigabytes. The relationship between these units is based on the binary system used in computing, where 1 terabyte equals 1024 gigabytes and 1 gigabyte equals 1024 megabytes, and so on. All right, final question. Which unit of measurement is used to describe the speed of data transfer in a network? Would it be revolutions per minute, megabits per second, gigahertz, or megabytes per second? All right, and the correct answer is megabits per second. So network speeds are often measured in megabits per second or gigabits per second, representing the rate of data transfer. Megabytes per second is also a data transfer rate, but less commonly used for network speeds. RPM is related to rotational speeds of devices like hard drives, and gigahertz measures processor speed. So in this video, we're going to be talking about the troubleshooting methodology, which is a systematic approach to resolving technical problems in computing. So whether you're fixing a broken application, a malfunctioning device, or a network connectivity issue, following a structured troubleshooting process is key to identifying the root cause and finding the right solution. Also, the CompTIA Tech Plus exam outlines a 6-step methodology that will be our focus for this lesson. So let's break down each step, providing examples and tips to ensure you are fully prepared. All right, so the first step in the troubleshooting methodology is to identify the problem. So before diving into solutions, you need to understand what is going wrong. So here's how you can do that. First thing you can do is ask the user questions. If you're troubleshooting for someone else, you want to gather as much information as possible. Ask questions like, when did the problem start? Or what were you doing when the issue occurred? Next, you want to observe the symptoms. So you want to look at the error messages, behaviors, or notifications being displayed. So for example, if a user's computer won't start, does it show any lights, sounds, or error codes? Then you want to replicate the issue. So if possible, try to reproduce the issue to better understand it. Now, during this step, you should also establish a theory of probable cause. This means developing ideas about what might be wrong. You want to start with the simplest possibilities before considering more complex issues. So for instance, if a computer won't power on, first check the power cable before assuming a hardware failure. All right, so once you've identified the problem, it's time to establish a theory of probable cause. In other words, based on the information you've gathered, develop a logical explanation for what might be causing the issue. And here are some tips to help you do that. You want to start with the simple stuff. So think about common causes like loose cables, faulty software updates, or recent changes to the system. Do you want to narrow down the possibilities? If you have multiple theories, you want to test the simplest or most likely one first. So for example, if a printer isn't working, check whether it's turned on and connected before diving into more technical problems like driver issues. Now, it's important to stay systematic in your thinking. The idea here is to develop a clear path to potential causes without jumping to conclusions too quickly. Now that you have a theory, the next step is to test the theory to determine the cause. And this is where hands-on testing begins to confirm or refute your hypothesis. So for example, if you suspect the faulty network cable is causing connectivity issues, try replacing it to see if the problem is resolved. If you believe a software issue is to blame, try running an update or reinstalling the application to test whether that resolves the problem. If your theory is confirmed, then move on to the next step. However, if the theory is not confirmed, go back to step 2 to establish a new theory and test it again. This iterative process is crucial to zeroing in on the correct solution. After you've determined the cause, it's time to establish a plan of action to resolve the problem and implement the solution. And here's how you do it. You need to plan the fix. Once you know what's wrong, you need to decide how to fix it. Make sure your plan is clear, specific, and considers any potential impacts on the system or users. Then you want to communicate with the users. If the troubleshooting affects others, let them know what you plan to do. This is especially important in a business environment where downtime can impact productivity. Then you want to back up any critical data. So before implementing a solution, ensure that any critical data is backed up. And this is particularly important if the fix involves reinstalling software or making changes that could risk data loss. So for instance, if you identify that a computer's hard drive is failing, your plan might involve backing up the data and replacing the hard drive with the new one. Implement the solution carefully and ensure that the problem is resolved before moving to the next step. So once you've implemented the solution, it's essential to verify full system functionality. You want to make sure everything is working as expected and not just the part that you fixed. Additionally, implement any preventative measures to ensure that the problem does not reoccur. So here's how to verify functionality. You want to test thoroughly. So make sure that the issue is fully resolved by testing it in multiple scenarios. So for example, if you fixed a printer issue, try printing from different devices and applications to confirm everything is working. Then you want to implement preventative measures. If the problem was caused by a specific action, take steps to prevent it from happening again. So for instance, if a software issue was due to a lack of updates, ensure automatic updates are enabled moving forward. Now, the goal is to ensure not only that the immediate problem is solved, but also that the user can continue to use the system without running into similar issues. All right, so the final step is to document your findings, actions, and outcomes. Documentation is a critical part of the troubleshooting process as it helps others understand what was done and why. It also provides a valuable reference in case the issue arises again. So here's what you can include in your documentation. The first thing you want to include is a description of the problem. So you want to state what the symptoms that you observed and how was the problem identified. Then you want to list the theory and the cause. So what theories were tested and what was determined to be the cause of the issue. You also want to list any solutions that were implemented. So detail the plan of action that you took to resolve the problem. You also want to state any verification and preventative measures. So confirm that the solution worked and note any preventative measures implemented. And you want to list the outcomes. Explain the final outcome, including any lessons learned or further recommendations. Ultimately, effective documentation can save time and effort in future troubleshooting scenarios and improve communication within teams. All right, so let's summarize the 6 steps of the troubleshooting methodology. Step 1, you want to identify the problem. So gather information, observe symptoms, and then establish a theory. Step 2, you want to establish a theory of probable cause. Develop and refine your theory based on what might be wrong. Step 3, you want to test the theory to determine the cause. So test your theory to confirm or rule out potential causes. Step 4, you want to establish a plan of action and implement the solution. So plan and carry out the fix, ensuring data safety and user communication. Step 5, you want to verify system functionality and implement preventative measures. So test thoroughly to confirm resolution and take steps to prevent reoccurrence. And then step 6, you want to document findings, actions, and outcomes. So you want to record everything to provide a clear record of the issue and resolution. By following this methodical approach, you'll be able to tackle a wide range of technical issues effectively, whether they involve hardware, software, or network problems. All right, so now it's time for our favorite part of the video. This is the check on learning section. So question 1, which of the following is the first step in a structured troubleshooting methodology? Is it establishing a theory of probable cause, identifying the problem, establishing a plan of action to resolve the problem, or documenting findings, actions, and outcomes? The correct answer is identifying the problem. So the first step in troubleshooting is always to identify the problem. This includes gathering information, questioning users, and understanding the symptoms to form a clear problem statement before proceeding to other steps like establishing a theory or testing solutions. Next question. After identifying the problem, what is the next step in the troubleshooting methodology? Is it test the theory to determine the cause, establish a plan of action to resolve the problem, implement a solution, or establish a theory of probable cause? All right, so the correct answer would be establish a theory of probable cause. So once the problem has been identified, the next step is to establish a theory about what could be causing the issue. This helps in narrowing down possible causes before testing and resolving the problem. And our final question is, what should you do after you have successfully implemented a solution to the problem? Should you close the ticket immediately? Should you verify full system functionality and implement preventative measures? Should you document findings and outcomes, then walk away? Or should you move on to the next problem without verifying? And of course, the answer is you want to verify full system functionality and implement preventative measures. So after implementing a solution, it is important to ensure that the issue is fully resolved and that the system is functioning as expected. Additionally, implementing preventative measures can help ensure the issue does not reoccur in the future. And this is crucial to confirm the effectiveness of your solution before documenting the process. In this video, we're going to cover the purposes of various computing devices. Specifically, we'll discuss smartphones, tablets, e-readers, laptops, workstations, servers, gaming consoles, virtual reality systems, and augmented reality systems. Now, each of these devices serves a unique role in modern computing, and understanding them is fundamental to your success on the exam. All right, so let's talk about smartphones. So a smartphone is a handheld portable computing device that integrates the functionality of a mobile phone with the power of a mini computer. And the purposes of a smartphone is as follows. It provides communication. So it is primarily used for voice calls, text messages, video calling, and instant messaging. It also provides internet access and web browsing. So users can access the internet for information, social media, or entertainment. It has an app ecosystem. So smartphones use app stores to download applications ranging from productivity tools like email, calendars, or document editors to entertainment like games, music, and videos. It also does multimedia, so it is equipped with cameras, speakers, and microphones. Smartphones support media capture and consumption, such as taking photos, recording videos, and listening to music. And it can provide navigation. It has built-in GPS that allows for mapping, real-time navigation, and location-based services. So essentially, smartphones serve as a multifunctional tool for communication, entertainment, productivity, and a whole lot more. Next up are tablets. So a tablet is a larger portable touchscreen device bridging the gap between smartphones and laptops. And the purposes of a tablet are as follows. You have media consumption. So tablets are great for streaming video, reading digital books, playing games, and browsing the internet. It also serves mobile productivity. So they can run productivity apps such as word processors, spreadsheets, and presentation tools, making them suitable for on-the-go work. And it also has creative applications. So many tablets support stylus input, making them popular for digital artists, designers, and note takers. And also, it provides a platform for education and learning. So tablets are increasingly used in education for interactive learning and reading and accessing online courses. Now, due to their larger screen sizes compared to smartphones, tablets are ideal for activities that benefit from a more immersive visual experience. Now let's discuss e-readers. So an e-reader is a specialized handheld device specifically designed for reading digital books and periodicals. And the purposes of an e-reader are as follows. It allows for you to read digital content. So the main function of an e-reader is to allow users to read ebooks, digital magazines, or newspapers in a comfortable format. It has e-ink displays. So most e-readers use e-ink technology to mimic the look of printed paper, reducing eye strain and providing excellent visibility in bright light while also being energy efficient. And they are portable and they offer storage. So e-readers are lightweight and compact, and they're able to store thousands of books for convenient access anywhere. Now, while limited in versatility compared to tablets or smartphones, e-readers are perfect for avid readers who want a paper-like reading experience without the bulk of carrying physical books. Moving on to laptops. So a laptop is a portable personal computer that includes an integrated screen, keyboard, and trackpad. And the purpose of a laptop are as follows. It provides portable computing power. Laptops are used for a wide range of tasks, from general purpose activities like browsing and streaming to complex activities like software development, video editing, or graphic design. They offer work and productivity. So laptops are popular tools for business, education, and productivity due to their portability and ability to run full-featured operating systems and applications. And they also offer entertainment. So with built-in screens and speakers, laptops are great for watching movies, playing games, and streaming music. So laptops are essentially mobile desktops, providing significant power and functionality with the added benefit of portability. Now let's discuss workstations. So a workstation is a high-performance computer designed for specialized professional tasks. And the purposes of workstations are as follows. They offer professional applications. So workstations are often used for tasks like video editing, computer-aided design, 3D rendering, and scientific simulations. They offer enhanced performance. They are equipped with more powerful CPUs, GPUs, and large amounts of RAM to handle demanding computational tasks, and they are reliable and stable. So workstations are built for stability, often running applications that require long processing times without interruption. So workstations are perfect for professionals who need advanced capabilities beyond what a typical desktop or laptop can provide. Next up is servers. So a server is a specialized computer that provides data, services, or resources to other computers over a network. And the purpose of a server is as follows. So they host websites. So servers store and deliver the content for websites to users across the internet. They offer file sharing. They provide centralized file storage and access for users within an organization. They offer database hosting and management. Servers can host large databases, allowing multiple users to access, modify, and manage data efficiently. And they offer network services. So servers can also handle tasks like email hosting, authentication, and software deployment. So servers are designed for reliability and performance to provide continuous service to users and devices within a network. Now let's talk about gaming consoles. So a gaming console is a specialized computing device specifically built for video gaming. And the purposes of gaming consoles are as follows. They offer optimized gaming performance. So consoles like PlayStation, Xbox, and Nintendo Switch are engineered for running video games at high quality with powerful GPUs and fast processors. They are entertainment systems. So besides gaming, modern consoles support apps for streaming video, music, and internet browsing, and they offer social and multiplayer experiences. So consoles enable both local and online multiplayer gaming, fostering social gaming communities. So gaming consoles are designed for entertainment, providing high quality gaming experience and other multimedia services. Next, let's talk about virtual reality systems. So a VR system immerses users in a simulated 3D environment through the use of a head-mounted display, motion sensors, and controllers. And the purposes of VR systems are as follows. It offers immersive gaming and entertainment. So VR systems create fully immersive gaming experiences, allowing users to interact directly with the virtual environment. They offer training and simulation. VR is used for realistic training simulations in fields like healthcare, aviation, and the military. industry, allowing users to practice in a risk-free controlled virtual space. And they offer virtual exploration. So VR enables virtual tourism, education, and exploration of environments that would be otherwise inaccessible. So VR systems, they provide an interactive and immersive way to engage with digital content, offering experiences far beyond traditional screens. And finally, let's talk about augmented reality systems. So an AR system overlays digital information onto the real world, enhancing the user's perception of their surroundings. And the purpose of AR systems are as follows. It offers enhanced reality experiences. So AR blends digital elements like images, sounds, and graphics with the real world, as seen in applications like Pokemon Go or Snapchat filters. They offer productivity and navigation. AR can be used for practical applications like providing turn-by-turn navigation instructions, identifying landmarks, or offering real-time translations. And they offer industry and training applications. So AR is used in industries for real-time data overlay during complex tasks such as medical procedures, manufacturing, and repair. So AR systems, they enhance the user experience with the physical world, offering information and visualizations that are contextually relevant to the environment. So in summary, each computing device discussed has specific purposes. Smartphones and tablets provide mobile computing for communication, productivity, and entertainment. E-readers are dedicated to reading digital content. Laptops offer portable computing power for a wide variety of tasks. Workstations cater to professional, high-performance applications. Servers deliver data, services, and resources over a network. Gaming consoles are designed for high-quality gaming experiences. VR systems are immersive, simulated environments, and AR systems, they enhance real-world environments with digital overlays. Now, each device has unique features and capabilities that cater to different needs and use cases, and making them essential tools in modern computing. All right, so now it's time for our check on learning. So, which of the following computing devices is best suited for portability and ease of use on the go, but may have limited processing power compared to a desktop computer? Would it be a desktop PC, a server, a tablet, or a supercomputer? And the correct answer will be a tablet. So a tablet is designed for portability, offering easy access to applications and the internet on the go. However, it typically has lower processing power compared to desktop PCs or servers. Next question, which computing device is most commonly used in data centers to manage network resources and handle large-scale processing tasks? Would it be a laptop, a server, a smartphone, or a smartwatch? And the correct answer is that of a server. So a server, this is a powerful computing device used in data centers to handle large-scale processing, managing network resources, and provide services to multiple users simultaneously. Laptops, smartphones, and smartwatches are primarily for individual use and have limited capabilities compared to servers. And our final question, which computing device is designed primarily for gaming and entertainment purposes, often featuring specialized hardware for high-performance graphics? Would it be a workstation, a gaming console, a smartphone, or a thin client? And the correct answer is a gaming console. So a gaming console is specifically designed for gaming and multimedia entertainment with hardware optimized for high quality graphics and smooth gameplay. Workstations are designed for professional tasks like video editing and 3D modeling. Smartphones have limited gaming capabilities, and thin clients are lightweight devices used primarily for connecting to a server for basic tasks. In this video, you're going to learn about some more common computing devices and their purposes, such as vehicles, IP, security cameras, streaming media devices, medical devices, exercise equipment, wearables, and various Internet of Things devices. All right, so let's start with vehicles. So modern vehicles are highly sophisticated computing devices. Advanced technology has transformed cars, trucks, and other transportation systems into smart vehicles with multiple computing purposes, such as offering navigation and GPS. So most vehicles today come equipped with GPS systems for navigation, offering route planning, traffic updates, and points of interest. They also offer entertainment systems. So infotainment systems provide music, podcasts, and video entertainment through touchscreens that often support voice control and app integration. They also offer safety and monitoring. So computing devices in vehicles handle everything from airbag deployment to anti-lock braking systems and lane departure warnings. Advanced driver assistance systems, they provide collision warnings, automatic braking, and adaptive cruise control. Then there's vehicle diagnostics. So onboard computers, they monitor the engine performance, oil levels, and tire pressure. These computers help diagnose issues early and often connect to external devices for more detailed analysis. So essentially, vehicles are becoming increasingly autonomous, leveraging artificial intelligence and sensor data to provide better user experience and to improve safety. Now let's move on to IP and security cameras. So an IP camera, or an Internet Protocol camera, is a type of digital video camera that transmits data over an IP network. And the key purposes of an IP security camera include the following. It offers surveillance and security. So IP cameras are widely used in security systems to monitor properties, provide live footage, and enable remote viewing through the internet. Then it offers motion detection and alerts. These cameras often include motion detection, sending alerts to users or security systems when unexpected activity is detected. And then it offers remote monitoring, so users can view live or recorded footage from anywhere using a smartphone or a computer, making IP cameras an integral part of modern surveillance solutions. So unlike traditional closed-circuit television cameras, IP cameras offer higher resolution, easier installation, and remote capabilities, enhancing overall security and monitoring options. Next, let's discuss streaming media devices. So a streaming media device is used to access online media content such as video, music, and other digital entertainment. The common devices include things like Roku, Amazon Fire Stick, and Apple TV. These devices allow users to stream movies, TV shows, and music from platforms like Netflix, Hulu, and Spotify. They also include smart TVs and streaming boxes. So many televisions today come with built-in streaming capabilities, enabling users to install apps, play games, and access content without needing a separate device. And some common devices include what is called Chromecast, and this device allows users to cast or mirror content from a mobile device or computer to a television. So streaming devices are designed to simplify access to digital content, providing easy-to-use interfaces and enabling on-demand media consumption. Next up are medical devices. So computing devices in healthcare have transformed patient care and monitoring, and common examples and purposes include the following. You have patient monitoring systems. So devices like heart rate monitors, glucose meters, and blood pressure machines are equipped with sensors and microprocessors to track vital signs continuously. They have imaging devices. Equipment such as MRI scanners, CT machines, and X-ray systems use computing technology to analyze and display detailed medical images for diagnosis. Then there's wearable health devices. So devices like insulin pumps and pacemakers are embedded with microcontrollers to monitor and manage health conditions in real time. And then we have telemedicine devices. With advances in technology, remote diagnostics and consultations are now possible. And devices like digital stethoscopes and portable ECGs connect to computers and transmit data to healthcare professionals. So medical devices have evolved to not only assist in diagnostics, but also provide real-time health monitoring and intervention, improving patient outcomes and accessibility to care. All right, next let's talk about exercise equipment. So exercise equipment is becoming increasingly smart, incorporating computing to improve fitness and training. And examples and purposes include the following. You have smart treadmills and bikes. So devices like Peloton and Nordic Track offer interactive workouts, performance tracking, and access to live or recorded classes. And these machines collect user data to track progress and provide feedback. You have fitness trackers and sensors. So equipment like smart weights and connected row machines track metrics such as reps, heart rate, and calories burned, often syncing with mobile apps and analysis. And then we have what are called smart home gyms. So devices like Tonal and Mirror, they provide guided workouts, strength training, and personalized coaching through built-in screens and connected sensors. So smart exercise equipment enhances the fitness experience by providing tailored workouts, real-time feedback, and progress tracking to help users achieve their health goals. Next, let's look at wearable devices. So wearables are computing devices designed to be worn on the body, often for health, fitness or convenience purposes. So we have devices like smartwatches. So devices like the Apple Watch and Fitbit, they track fitness data, display notifications, and can even run small applications. They monitor steps, heart rate, sleep patterns, and a whole bunch of other stuff. Then we have fitness bands, and these are simpler than smartwatches. Fitness bands focus on activity tracking, offering insights into exercise habits and health metrics. Then we have smart glasses and augmented reality. So wearables like Google Glass, they provide hands-free access to information, camera functionality, and augmented reality overlays for enhanced real-world interactions. So wearable devices provide quick access to data, notifications, and health tracking, making them valuable tools for fitness enthusiasts and tech-savvy users alike. Finally, let's dive into the Internet of Things devices. So IoT, this refers to a network of interconnected devices that collect, exchange, and act on data. In the context of common home devices, these IoT devices make homes smarter and more efficient. And some examples include the following. You have home appliances like smart refrigerators. They monitor food inventory, suggest recipes, and even let users see inside without opening the door. We also have smart washers and dryers. They allow remote start and stop of cycles, and they provide maintenance alerts. Then we have home automation devices like smart lights. They enable users to control brightness, color, and scheduling remotely. Also, you have smart plugs and outlets. They allow users to control non-smart devices by connecting them to a smart plug for automation. Then we have smart thermostats like Nest, where they learn user schedules, optimize temperature settings for comfort and energy efficiency, and they can be controlled remotely. We have security systems with smart alarms and sensors that can monitor doors, windows, and motion, sending alerts to homeowners' smartphones when unusual activity is detected. We also have cameras and door sensors where they provide live video feeds, two-way audio, and they record footage for security. We also have home assistant devices like Amazon Echo, Google Home, and Apple HomePod, where they respond to voice commands, control other smart devices, provide information, and serve as a hub for home automation. Also, we have smart locks that allow for keyless entry through smartphones, codes, or biometrics, and they can be remotely locked or unlocked. And then we also have video doorbells like Ring and Nest Hello, and they provide live video feeds of who's at the door. They send motion alerts, and they allow two-way communication with visitors. So IoT devices, they aim to make everyday tasks more convenient, improving home security, energy efficiency, and providing ease of use to information and controls. All right, to sum all this up, we've covered a range of computing devices where we got vehicles are becoming smarter with features like navigation and safety. We have IP security cameras that provide surveillance and remote monitoring. We have streaming media devices that enable access to digital content and integrate with smart homes. We have medical devices that improve patient care through monitoring and diagnostics. We have exercise equipment that uses computing to track workouts and offer interactive fitness experiences. We have wearables that enhance connectivity and health tracking on the go. And then we have the Internet of Things that connects our homes, offering automation, convenience, and security. So understanding these devices is fundamental for those of you who are preparing for the CompTIA Tech Plus certification exam. All right, so let's go ahead and get into this wonderful check on learning. So which of the following devices is primarily used to monitor and control energy consumption in homes by adjusting temperature settings? Would this be a smartwatch, an IP camera, a smart thermostat, or streaming media devices? Of course, the answer would be a smart thermostat. They are designed to control the heating and cooling systems in the home, where they often allow remote control via a smartphone application to adjust settings for energy efficiency and comfort. Next question, which type of computing device is typically used to stream content such as movies, music, and TV shows over the internet? Would it be a medical device, a streaming media device, a wearable device, or an internet protocol camera or an IP camera? And of course, the answer would be a streaming media device. So devices like Roku, Amazon Fire Stick, and Apple TV are used to connect to the internet and stream various types of multimedia content to a display or speakers, offering entertainment and access to online services. And then our final question is, which of the following is a primary characteristic of wearable devices? Would it be they are stationary and usually integrated into a building? They are designed to be worn on the body and often track health and fitness. They require complex installation and are mainly used for home automation, or they serve as a main security system to monitor the premises using video feeds. And of course, the answer is they are designed to be worn on the body and often track health and fitness. So wearable devices such as smartwatches and fitness trackers are meant to be worn on the body. They often track physical activity, monitor health metrics, and provide notifications, making them highly portable and useful for fitness and health monitoring. In this video, we're going to break down the roles and functions of internal computing components such as the motherboard, firmware, RAM, CPU, GPU storage, and network interface cards. All right, so let's begin with the motherboard, which is also known as the system board. So think of the motherboard as the computer's central nervous system. It's a large printed circuit board that connects and communicates with all other components. And the key purposes of the motherboard are as follows. It provides connections and interfaces. The motherboard has slots and connectors for all internal components like the CPU, RAM, storage drives, and expansion cards. It also provides connections for external peripherals like USB devices, monitors, and keyboards. The motherboard also provides power distribution. It distributes electrical power from the power supply to all connected components, ensuring that each part of the computer gets the power it needs. And it's also a communication hub. The motherboard enables communication between the CPU, the RAM, storage, and other components via data buses and chipsets. Now, the chipsets on the motherboard, they play a vital role in controlling data flow between these components, and common chipsets are divided into what is called the North Bridge, which handles faster communications like between the CPU and the RAM, and then we have what is called the South Bridge, which handles slower connections like USB ports and hard drives. So essentially, the motherboard serves as the foundation of the computer, holding all other components together and enabling them to work in harmony. All right, next let's talk about firmware, specifically the BIOS, or the basic input-output system. So the BIOS is firmware that's built into the motherboard, and it's responsible for booting up the computer and managing the essential hardware settings. And the key purposes of the BIOS are as follows. It does system initialization. So when you power on your computer, the BIOS performs a series of checks called the power on self-test, and this ensures all essential hardware components are functioning correctly. Then it also does boot sequence control. So the BIOS tells the computer where to find the operating system by setting the boot order, such as booting from the hard drive, the USB, or over the network. Then it also does hardware configuration and management. So the BIOS manages low-level settings for hardware, including system time, CPU settings, and memory configuration. Modern computers, they often use what is called a UEFI, or Unified Extensible Firmware Interface, instead of a traditional BIOS. And UEFI is more advanced with a graphical interface and support for larger storage drives. So all in all, the BIOS, or the UEFI, is a crucial element in starting up the computer and providing the low-level interface between the hardware and the operating system. All right, now let's discuss RAM, or random access memory. So RAM is a type of volatile memory, meaning it temporarily stores data that the CPU needs quick access to while performing tasks. Unlike permanent storage, data in RAM is erased when the computer is turned off. And the key purposes of RAM are as follows. Once again, it provides temporary data storage. So RAM stores data that is actively being used or processed by the CPU, such as program instructions and open files. And this allows the CPU to quickly retrieve the necessary data without accessing slower storage drives. And then RAM also has a faster performance. So the more RAM a system has, the better it can handle multiple tasks simultaneously, which improves overall system performance. When you open a program or a file, it is loaded from the storage drive into the RAM so the CPU can access it quickly. So for example, if you have 8 gigabytes of RAM, your computer can load more data simultaneously, improving multitasking and speed. All right, next let's talk about the CPU, or the central processing unit. So the CPU is often referred to as the brain of the computer. It performs calculations, executes instructions, and processes data, allowing software to function. And the key purposes of the CPU are as follows. So once again, it processes instructions. So the CPU executes instructions from software programs and performs calculations from simple math to complex computations. It is also the control unit and ALU. So the CPU has two main components. First one is the control unit, which directs operations. And then you have what is called the arithmetic logic unit, and this performs arithmetic and logical operations. Also, another purpose of the CPU is clock speeds and cores. So the performance of a CPU is often determined by its clock speed, which is measured in gigahertz, which indicates how many cycles per second it can perform, and its number of cores, which allows for what is called parallel processing. So for example, a quad-core CPU can handle multiple tasks simultaneously, improving performance in multitasking and demanding applications like video gaming and editing. All right, let's move on to the GPU, or the graphics processing unit. So the GPU, this is a specialized processor designed to handle graphics rendering, image processing, and other complex visual tasks. And the purpose of the GPU are as follows. So it renders graphics and video. The GPU offloads graphical tasks from the CPU, allowing for smoother rendering of visuals and applications like video games, 3D modeling, and video playback. And then it also serves as a parallel processing power. So unlike the CPU, which is optimized for sequential processing, the GPU is designed for parallel processing, making it highly efficient at performing multiple calculations at the same time. And there are two types of GPUs. The first one is called an integrated GPU. This is built into the CPU and shares memory with the system. And this is suitable for general use like web browsing, streaming, and basic office tasks. And then we have what is called a dedicated or a discrete GPU, which is what you see on your screen right here. And this is a separate component with its own memory, which is known as VRAM, and processing power, and it's designed for more demanding tasks like gaming, video editing, and machine learning. So for users who need better graphical performance, such as gamers and video editors, having a discrete GPU is essential. All right, now let's talk about storage. So storage is where all data, including the operating system, applications, and user files, are permanently saved. Unlike RAM, storage is non-volatile, meaning data remains even when the computer is turned off. And the key purposes of storage devices are as follows. So you have what is called the hard disk drive, or the HDD. And this is a traditional storage device that uses spinning magnetic disks to read and write data. And hard disk drives are cost effective for large storage needs, but they are slower compared to newer technologies. And then we have what is called an SSD, or a solid state drive. And SSDs, they use flash memory instead of spinning disks, allowing for faster data access and improved performance. They are more reliable, they consume less power, and they have quicker boot times compared to hard disk drives. So for example, if you save the document on your computer, it is stored on either an HDD or an SSD. Now, while hard disk drives offer more storage space for the price, SSDs provide much faster performance, making them popular for operating systems and frequently accessed data. All right, finally, let's cover what is called the network interface card, or the NIC. So a NIC, this is a hardware component that allows a computer to connect to a network, such as a local area network or the internet. And the key purposes of the NIC are as follows. So it offers network connectivity. So the NIC facilitates communication between the computer and other devices over a network, enabling tasks like internet browsing, file sharing, and network printing. And there are two types of NICs. You have what is called a wired NIC, and this connects via an Ethernet cable and typically offers a stable and fast network connection. And then we have what is called a wireless NIC, and this uses Wi-Fi to connect to a network without the need for cables, offering mobility but potentially lower speeds compared to wired connections. And then another purpose of the NIC is you have onboard versus expansion cards. So many motherboards come with an onboard NIC that is built directly into the motherboard. However, expansion cards can be added to provide additional network capabilities or enhance performance. Whether wired or wireless, the NIC plays a crucial role in enabling network communication for computers, allowing them to access resources both locally and online. So, in conclusion, the key internal components of a computer each play a specific role. The motherboard serves as the central hub connecting all components. The BIOS initiates system boot and manages hardware settings. RAM temporarily stores data for quick access. The CPU processes instructions and handles tasks. The GPU manages graphics and parallel processing. Storage devices like hard disk drives and solid state drives store data for long term. And the NIC enables network communication. Now, understanding these components and their functions is foundational for building, troubleshooting, and optimizing computers, and it is a key part of the CompTIA Tech Plus certification exam. Now, with all that being said, let's go ahead and do some of this check on learning. So the first question is, which internal computing component is primarily responsible for managing all the instructions a computer needs to perform tasks? Would it be the motherboard? Would it be the central processing unit? Would it be the random access memory? Or would it be the network interface card? And the answer is, it is the CPU, or the central processing unit. So remember, the CPU is often referred to as the brain of the computer because it handles the execution of instructions and processes all tasks given to the computer. While other components like the motherboard, RAM, and NIC play important roles in the system, the CPU is primarily responsible for the core processing and computing tasks. Next question. What is the main function of the motherboard in a computer system? Is it to store data temporarily for quick access? Is it to display graphics and images on a monitor? Is it to connect and allow communication between different internal components? Or is it to provide network connectivity? And the answer is, it connects and allows communication between different internal components. So the motherboard, which is also known as the system board, or if you're dealing with an Apple machine, they call it a logic board. But either way, it acts as the main circuit board that interconnects all other components, such as the CPU, RAM, GPU, storage drives, and the network cards. It enables communication and power distribution to each component, allowing them to work together as a functional computer system. And our final question is, which type of network interface card is most likely to provide faster and more stable internet connectivity? Would it be an onboard wireless NIC, an expansion wireless NIC, an onboard wired NIC, or an expansion wired NIC? And the correct answer would be an onboard wired network interface card. Wired network connections are generally faster and more stable than wireless connections due to the direct physical connection to the network. An onboard wired NIC integrated into the motherboard is more efficient than wireless options in terms of speed and stability, particularly for high bandwidth tasks. Expansion wired NICs can also be fast and stable, but the key factor is the wired nature of the connection itself. In this video, we're going to focus on understanding and comparing different storage types, such as volatile and non-volatile storage, local storage types, and local network storage options. All right, so let's start by comparing volatile and non-volatile storage. So volatile storage, this is a type of memory that requires power to maintain the stored information. Once the power is cut off, the data is lost. An example of this is what is called RAM, or random access memory, and this is the most common form of volatile storage. When you turn on your computer, the RAM is used to store data temporarily that the CPU needs for running applications or performing calculations. However, once you shut down your computer, any data in the RAM is erased. In volatile storage, this is also very fast and it is temporary. Then we have what is called non-volatile storage, and this retains data even when the power is turned off, making it suitable for long-term data storage. And ROM, or read-only memory, is a type of non-volatile memory that contains critical boot information for the computer, such as the BIOS firmware. Another example is any type of permanent data storage like hard drives or SSDs. And remember, non-volatile storage is persistent and typically used for long-term storage. So in summary, volatile memory like RAM is used for short-term data access and performance, whereas non-volatile storage is used for long-term data retention. All right, so now that we understand volatile versus non-volatile storage, let's move on to local storage types. And local storage refers to any storage device physically attached to a computer. And we'll look at various forms, including RAM, ROM, HDDs, SSDs, non-volatile memory, optical drives, and external flash drives. All right, so let's talk about RAM, or random access memory. So as mentioned before, RAM is volatile memory. It is used for temporary data storage the CPU can access quickly. And a use case for this is running active applications, storing temporary data needed for processing, and managing active sessions. And then we have ROM, which stands for read-only memory. And ROM is non-volatile and contains data that does not change frequently. The contents of ROM are written once and typically only modified by the manufacturer. And the use case for this is storing firmware such as the BIOS or UEFI, which initializes hardware during the boot process. So RAM and ROM are internal to the system and are critical to basic system functionality. Now let's move on to storage devices. And the first one we're going to talk about is the magnetic disk or the hard disk drive. So hard disk drives, they use magnetic storage to store and retrieve data on spinning disks, which are called platters. And they are relatively affordable and offer high storage capacity, but they are slower compared to other storage options, and they are prone to mechanical failure due to moving parts. And the use case for this is large data storage needs where speed is not a primary concern, such as backup drives or for storing media files. Next, we have what is called the solid state drive, or the SSD, and these are non-volatile storage devices that use flash memory to store data. Unlike HDDs, SSDs have no moving parts, making them faster and more reliable. And the advantages are they offer higher speeds, lower latency, and they're more durable. And a use case example for this is operating system storage, application storage, and any situation where performance is a priority. An SSD significantly improves system boot times and application loading times. And then we have what is called non-volatile memory express. So non-volatile memory express, this is a storage protocol designed specifically for SSDs to utilize the high-speed data transfer capabilities of PCIe's, or peripheral component interconnect express. Non-volatile memory express drives are significantly faster than traditional SSDs with lower latency and greater throughput. And the use case for this is high-performance tasks such as gaming, video editing, and running virtual machines where speed is critical. All right, so now let's talk about some other local storage types. And the first one is the optical storage drive. So optical drives, they use lasers to read and write data to disks. You got CDs, DVDs, and Blu-ray discs. These are all forms of optical storage. And the pros are they are portable and useful for data distribution, such as movies, music, and software. The cons are they are slower compared to HDDs and SSDs and have relatively limited capacity. And the use cases for these are things such as archiving data, distributing media, or installing software. Next, we have what are called external flash drives. So flash drives are small portable devices that use flash memory for data storage. They connect to computers via USB ports, and SD cards are often used in cameras and other devices. And the pros are they are highly portable, easy to use, and generally affordable. The cons are they have limited storage capacity compared to hard disk drives and SSDs, and they are not as durable for long-term storage. And a typical use case for an external flash drive is they transfer files between devices, backing up critical files temporarily, or they could be used as some type of portable media storage. Ultimately, these local storage devices, they offer a variety of options based on capacity, speed, and portability needs. All right, now let's move on to local network storage. So unlike local storage, which is directly attached to a device, network storage allows multiple users or devices to access shared storage over a network. And the first one we're going to talk about is the network attached storage, or the NAS. So NAS is a storage device connected to a local network, providing shared access to files from multiple devices or users. Its pros are it centralizes data storage, making it easy for multiple users to access, backup, and share files. Its cons are, depending on the network speed, access can be slower than direct attached storage, and it requires network configuration. And a typical use case is small businesses or home users who need a shared space for documents, multimedia, or backup. So network attached storage devices, they are often used for storing media libraries, document archives, or as a backup solution for all devices on a network. Next, we have what is called a file server. So a file server, this is a computer specifically dedicated to storing and managing files for network access. The pros are it provides centralized storage and file management, user account control, and shared resources for multiple users. The cons, it's more complex to set up than the NAS devices and requires server hardware and proper software configurations. In a typical use case, organizations needing centralized file management, secure user permissions, and shared access to resources like database or application files. So file servers, they offer more advanced features for managing data access and security, making them suitable for business environments. And then we have cloud storage devices. So cloud storage, this refers to storing data on remote servers managed by cloud service providers and accessible via the internet. And the pros, they offer scalability, remote access, and data redundancy across multiple geographical locations. The cons, they are reliant on internet connectivity, and there may be concerns over data security and privacy. In a typical use case, there are backup solutions, file sharing, and storing data that needs to be accessed from multiple devices or locations. And popular cloud storage providers include Google Drive, Dropbox, and OneDrive. So cloud storage allows for convenient access to data from anywhere with internet connectivity and is becoming a common solution for both personal and business data storage needs. So to recap, we've covered a lot of ground in understanding different types of storage. We talked about volatile versus non-volatile. So volatile storage like RAM is fast and temporary, while non-volatile storage like SSDs and HDDs retain data even without power. We also talked about local storage, and this includes RAM, ROM, hard disk drives, solid state drives, and non-volatile memory express drives, optical drives, and external flash drives, each serving unique roles based on capacity, speed, and cost. And we talked about local network storage, and this comprises network attached storage devices, file servers, and cloud storage, offering shared access to data over a network. Now, understanding these storage types is crucial for choosing the right solution for any given task, and this is a key part of the CompTIA Tech Plus certification exam. All right, so with all of that being said, let's get into this check on learning. So which of the following storage types is considered non-volatile? Would it be random access memory, read-only memory, cache memory, or the central processing unit? And the correct answer would be read-only memory or ROM. So non-volatile storage retains its data even when the power is turned off. ROM is non-volatile as its contents remain intact without power. In contrast, RAM is volatile and its data is lost when power is removed. Cache memory and CPU do not serve as storage and do not retain data without power. Next question. A user wants a storage solution that offers fast access speeds for local data storage on their computer. Which of the following will be the best option? Would it be a magnetic disk / hard disk drive, a solid state drive, an optical disk, or an external flash drive? And the correct answer would be a solid state drive. So SSDs, they provide faster data access speeds compared to hard disk drives, which rely on spinning magnetic disks, and optical disks, which have slower read-write times. While external flash drives can also provide fast access, internal SSDs generally offer superior performance and integration for local data storage. And the final question, which type of storage is primarily used for accessing and sharing files over a local network? Would it be a solid state drive, a network attached storage, random access memory, or an optical disk? And the correct answer would be network attached storage. So network attached storage is a storage device connected to a local network that allows multiple users to access, store, and share files. It is specifically designed for network-based storage needs. SSDs, RAM, and optical disks are typically used for local or direct storage rather than network-wide sharing. In this video, You will be learning about common peripheral devices such as printers, scanners, keyboards, and more. And you're going to learn how to install them, whether it's a straightforward plug and play setup or a more complex driver installation. So before we get into the installation and configuration process, let's define what peripheral devices are. So peripherals are external devices that connect to your computer to add capabilities or perform specific tasks. And they can be input devices like keyboards and mice, output devices like printers and speakers, or devices that handle both input and output. And here are some common peripheral devices and their functions. So we got printers. These are output devices that produce hard copies of digital documents, photos, or other content. You have scanners. These are input devices used to convert physical documents into digital format. You have keyboards and mice. These are essential input devices for interacting with your computer. You have webcams. These are input devices for capturing video or photos, often used for video calls. We have external drives. Storage devices like external hard drives or USB drives are used for backup or additional storage. You have speakers and headsets. These are output devices for audio, including music, calls, and notifications. You have various displays, and these are output devices that allow visual display of information from your computer. And then we have what is called an UPS or an uninterruptible power supply. And this provides backup power to keep your devices running in the event of a power outage. All right, so when installing and configuring these devices, there are two primary installation types to consider. The first one is the plug and play installation, and then we have what is called driver installation. So let's talk about plug and play installation. So modern operating systems like Windows, Mac, and Linux, they often support plug and play devices. This means that when you connect a device to the computer, the operating system will automatically detect it, locate the appropriate drivers, and set it up for use without any further user intervention. And examples of this include most keyboards, mice, basic printers, and USB storage devices. And then we have what is called driver installation. So some devices require additional drivers to work correctly, especially those with advanced functionality. And a driver, this is software that allows the operating system to communicate with the hardware device. These drivers are usually provided by the device manufacturer and can be downloaded from their website or installed from a disk. And installing drivers can involve running a setup program which configures the device and adds management software for additional settings. All right, now, so let's walk through the installation and configuration of some common peripherals, and we'll start with printers. So the first type is the plug and play printer. So many printers today are plug and play. So when connected via USB, the operating system will detect and install them automatically. And for basic use, this installation is usually sufficient. Then we have advanced printer setup. So network printers, they require connecting to a wireless or Ethernet network. So what you want to do, you want to go to the control panel on Windows or the system preferences on your Mac and navigate to printers and scanners and select add a printer. For IP-based printers, you may need to manually enter the printer's IP address during setup, and the printer should come with a manual detailing how to find this information. If the printer supports web-based configuration, you would access it by typing the printer's IP address into a web browser to change settings like network preferences or firmware updates. And then we have driver installations for printers. So you want to download the latest drivers from the manufacturer's website. You want to run the installation program, which may include additional software for print management and customization of settings like print quality or paper type. Next peripheral device is scanners. So the first one is a USB scanner. So most modern scanners are plug and play. And once connected, you can use scanning software provided by the operating system like Windows Fax and Scan or third-party software for more advanced options. And we have what is called an all-in-one printer/scanner. So if using an all-in-one device, you want to ensure that both printing and scanning drivers are installed. And often the software package will install both components. Then we have driver installation for scanners. So advanced scanners, especially those with features like OCR, which stands for optical character recognition, they may require specific drivers. And also you want to visit the manufacturer's website, download the appropriate drivers, and follow the setup instructions. All right, the next peripheral devices are keyboards and mice. So standard keyboards and mice, they are often plug and play, requiring no additional configuration. For USB or wireless options, you would simply connect the device and the operating system will detect it automatically. Then we have advanced or customizable devices. Some gaming keyboards or mice, which offer programmable keys, RGB lighting, or other features. They require a driver installation, and you want to install the software provided by the manufacturer to customize the settings. Next up, we have webcams. So most modern webcams are plug and play, especially if connecting via USB, and the operating system will automatically detect the webcam and make it available for use in applications like Zoom, Skype, or other built-in camera software. And then for webcams with advanced features like adjustable resolutions or filters, it's best to install the driver and additional software provided by the manufacturer for full functionality. Next, we have external drives. So we have USB drives and external hard drives, and these devices are typically plug and play as well. So once connected, they will show up as external storage in your File Explorer. Now, external drives, they can be formatted as needed depending on the operating system. Then we have driver installation. So some specialized drives like external SSDs or RAID configurations, they may require driver installation for optimal performance. Next, we have speakers and headsets. So basic speakers and headsets that connect via a 3.5 millimeter jack or USB are usually plug and play. And to configure the audio output, just simply go to the sound settings on your operating system, where you can select the device, adjust the volume, and configure the input-output settings. Then we have Bluetooth speakers and headsets that need to be paired with the computer. You will go to the Bluetooth settings on your operating system, ensure the device is in pairing mode, and connected. For advanced headsets with surround sound or gaming features, installing the manufacturer's software is recommended for full access to customization settings. Next, we have displays. So monitors usually connect via HDMI, DisplayPort, VGA, or USB-C, and most displays are plug and play and will be recognized automatically by the operating system. For multi-monitor setups, you want to go to the display settings to configure resolution, orientation, and position. Smart TVs and projectors, they often require a wired connection such as an HDMI cable or wireless casting such as Miracast or Chromecast. And once connected, you can adjust the display settings on both the computer and the display device to ensure proper screen resolution and aspect ratio. Now, while most monitors don't need additional drivers, specialty displays such as touchscreen monitors or VR displays, they might require them. So always refer to the manufacturer's guidelines. And finally, we have the UPS, or the uninterruptible power supply. So in UPS, this provides backup power during a power outage, allowing you to safely shut down your computer. And it often includes surge protection to safeguard against power surges. So when it comes to the installation and configuration, you want to connect the UPS to the computer and the wall outlet. You want to install any monitoring software provided by the manufacturer, which allows you to check battery status, set alerts, and configure power saving options. So to sum all of this up, installing and configuring peripherals depends on the device type and complexity. While plug and play makes setup simple for many devices, others require driver installations or network configurations. And understanding the setup process for each type of device is crucial for troubleshooting and ensuring that peripherals work correctly with your system. All right, now let's get into this wonderful check on learning. So the first question is, you have connected a new printer to your computer via USB. After connecting it, the computer displays a message stating that the device is ready to use. Which type of installation is this an example of? Would this be a manual driver installation? Would this be an IP-based installation? Would this be a plug and play installation? Or would this be a web-based configuration? And the correct answer is this is a plug and play installation. So plug and play, this allows devices to be automatically recognized and configured by the operating system without requiring additional user intervention or manual driver installation. Next question. A user needs to connect a scanner to their computer. but they cannot get it to function properly. You find that the scanner is not being detected automatically. What is the most likely next step to resolve this issue? Would it be to restart the computer? Would it be to install the manufacturer's drivers manually? Would it be to connect the scanner to a different USB port? Or would it be to run a virus scan? And the correct answer would be you want to install the manufacturer's drivers manually. So if a peripheral device like a scanner is not detected automatically, the issue may be due to the absence of the correct drivers. Manually installing the drivers from the manufacturer's website is often necessary to ensure proper functionality. And the final question is, a user wants to connect a wireless printer to their home network so all devices can access it. Which of the following steps should they most likely perform to achieve this? Would they install drivers for each device? Would they configure the printer's IP address settings via the web interface? Would they connect the printer to a computer via USB? Or would they enable the printer's built-in display mode? And the correct answer is they would configure the printer's IP address settings via the web interface. So to connect the wireless printer to a network, the user typically needs to configure the printer's network settings. This often involves using the printer's web-based interface to set up the IP address and wireless settings so all devices on the network can communicate with it. In this video, we will be talking about common types of input-output device interfaces. Understanding these interfaces is crucial, and they are essential for connecting, configuring, and troubleshooting computing devices. So we're going to break it down into 4 sections. We're going to talk about networking interfaces, both wired and wireless, networking devices and tools, peripheral device interfaces, and display ports and display technologies. All right, first, let's talk about networking interfaces, which are crucial for connecting devices to a network, either through a wired or wireless connection. And we'll look at both categories, starting with wired interfaces. So let's talk about the Ethernet connector RJ45. So one of the most common networking connectors is the RJ45 connector. And RJ45 connectors are used with Ethernet cables to connect devices like computers, routers, and switches to wired networks. And the connectors are typically used with Cat5e, Cat6, and Cat6a cables, which provide varying levels of data transfer speed from 100 megabits per second up to 10 gigabits per second. And it is a standard and reliable method for achieving high speed, low latency connections over short to medium distances. Another wired interface is the small form factor pluggable, or the SFP connector, commonly found in fiber optic networking. SFPs are hot swappable interfaces that allow network devices like switches to connect to fiber optic or copper cables, providing faster speeds and greater distances than traditional Ethernet. And fiber optic cables use light to transmit data, making them ideal for long distance communications or environments where electromagnetic interference is an issue. And SFP modules come in various types, such as the SFP Plus for 10 gigabit per second connections, offering versatility in how you configure and connect your network infrastructure. Now let's look at the wireless networking interfaces, which provide flexibility and mobility compared to wired options. And the first one is Bluetooth. So this is a short range wireless technology used for connecting devices like smartphones, wireless keyboards, mice, and speakers. It has a range of approximately 30 feet and is ideal for low power, low bandwidth connections. And Bluetooth is widely used for peripherals and IoT devices, offering quick pairing and data exchange. Next, we have what is called near field communication. So NFC is another short range wireless technology that operates at distances of a few centimeters. And it's used for applications like contactless payments, access control, and data transfer between devices by simply tapping them together. NFC is secure and efficient, making it great for scenarios where close proximity communication is required. All right, next we have what is called 802.11x, also known as Wi-Fi. So 802.11x, this is a family of Wi-Fi standards that provides high-speed wireless networking. And the most common versions are 802.11n, 802.11ac, and 802.11ax, which is also known as Wi-Fi 6. And these versions support speeds ranging from a few hundred megabits per second to over 9 gigabits per second, and have a varying range from indoors, such as around 100 to 500 feet, to outdoors, which can extend it up to 300 feet. And Wi-Fi, this is the most prevalent wireless networking technology for home and business use, supporting a wide range of devices and high data transfer speeds. All right, so networking interfaces are just one part of the puzzle. So let's discuss the networking devices and tools used to work with these connections. So the first one we have is a crimper. So a crimper is a tool used to attach connectors such as RJ45 plugs to the ends of network cables. And proper crimping ensures a solid electrical connection between the cable and connector, which is essential for reliable data transfer. Then we have what is called a cable tester. So a cable tester is used to verify the integrity and continuity of network cables. It helps identify issues like short circuits, cable breaks, or miswiring. By using a cable tester, you can quickly troubleshoot and ensure that cables are correctly terminated and functioning properly. So these tools are important for setting up and maintaining network connections and ensuring that they work as intended. All right, now let's move on to the peripheral device interfaces. So these interfaces connect external devices to computers, allowing data transfer and additional functionalities. And the first one we have is the USB, which stands for Universal Serial Bus. So USB, this is a standard for connecting a wide variety of peripherals to a computer. We have what is called USB-A. This is the most recognizable rectangular USB connector, and it is widely used for connecting devices like flash drives, keyboards, and mice. Then you have the USB-B, and this is often found on printers and external hard drives, and it has a more square shape. And then we have the USB-C, and this is a newer standard that is reversible and supports faster data transfer speeds, higher power delivery. It can also be used for video output. And USB-C is quickly becoming the go-to connector for modern devices due to its versatility. Next, we have what is called the Thunderbolt. So Thunderbolt interfaces are high-speed connections that combine data transfer, display output, and power delivery through a single cable. And Thunderbolt 3 and 4, they use the USB-C connector, supporting speeds up to 40 gigabits per second and allowing users to connect multiple devices like displays, external drives, and docking stations. Next, we have Bluetooth and radio frequency. So as previously mentioned, Bluetooth is also used as a peripheral interface for wireless devices like keyboards, mice, and headphones. Then we have radio frequency interfaces that are often used for wireless peripherals, particularly older wireless keyboards and mice that use a USB dongle to communicate. Next, we have the Lightning connector. So the Lightning connector, this is a proprietary standard used by Apple devices like iPhones and iPads. And the Lightning connector, it provides data transfer, charging, and connectivity to other devices and peripherals. So these interfaces, they enable the connection and use of a wide range of external devices, offering flexibility and expanding a computer's capabilities. All right, now let's discuss display ports and interfaces that are specifically designed for connecting video output devices like monitors, projectors, and TVs. So the first one we have is the Video Graphics Array, or VGA, and that is the blue connector on your screen right here. So VGA, this is an analog video connector that has been around for a long time. And once again, it is recognizable by its blue color and 15-pin connector. Although it's becoming outdated, VGA is still found on many older monitors and projectors. And then we have what is called DVI, or Digital Visual Interface. So DVI is a step up from VGA, offering a digital video signal for higher quality. And DVI comes in several types, including DVI-D, which produces a digital signal only. DVI-A produces an analog signal only. And DVI-I, this is integrated for both analog and digital. Now, DVI supports HD video, but newer interfaces have largely replaced it. All right, next we have high definition multimedia interface, or most commonly known as HDMI. So HDMI is one of the most common video connectors found on modern devices. It supports high definition video and audio over a single cable, and it is the standard for TVs, monitors, and gaming consoles. HDMI versions range from 1.4 to 2.1, offering resolutions up to 4K and beyond. Then we have DisplayPort, and this is similar to to HDMI, but it is designed to be more versatile and is commonly used in computer monitors. It supports high resolutions, high refresh rates, and multiple monitor setups. And display ports also support audio and USB data transfer, making it a powerful connector for modern displays. Then we have USB-C. And this is becoming a standard connector for video output as well, especially with technologies like Thunderbolt and DisplayPort alternate mode. And it provides high resolution video, data transfer, and power delivery all through a single cable. So these display interfaces are crucial for connecting computers to monitors and other displays, providing options for both digital and analog connections. All right, finally, let's cover display technology methods, specifically mirroring and casting. Mirroring is when the content of a device's screen, like a laptop or smartphone, is duplicated on an external display. And this is common for presentations or scenarios where you might want multiple viewers to see the same content. And connections for mirroring include HDMI cables, DisplayPort, or wireless methods like Apple AirPlay or Google Cast. And then we have what is called casting. So casting differs from mirroring in that it allows you to stream content directly to an external device without duplicating the screen exactly. So for example, when you cast the video to a smart TV, the video plays on the TV, but you can continue using your phone for other tasks. So casting is often done wirelessly using protocols like Google Cast, Mirrorcast, or DLNA. So mirroring and casting, they provide flexibility in how content is shared and displayed, supporting both wired and wireless scenarios. All right, and to summarize, we've covered a variety of input-output interfaces. We've talked about networking interfaces like RJ45, SFP, Bluetooth, NFC, and Wi-Fi. We talked about networking tools like crimpers and cable testers. We talked about peripheral connections, including USB, Thunderbolt, Bluetooth, RF, and Lightning. We talked about display ports like VGA, DVI, HDMI, DisplayPort, and USB-C. And we talked about display technologies for mirroring and casting content. Now, each of these plays a vital role in how devices connect, communicate, and function, making it important to understand them for the CompTIA Tech Plus exam and for practical applications in IT. All right, now with all of that being said, let's get into this check on learning. So, which of the following connectors is most likely used for wired Ethernet networking? Would it be a USB-C, an HDMI, an RJ45, or SFP? And the correct answer would be RJ45. RJ stands for registered jack, but it'll be RJ45. And this is the standard connector used for wired Ethernet networking. It is commonly found in LAN environments for connecting computers and other devices to a network. USB-C and HDMI are used for data transfer and display connections, respectively, while SFP is used for connecting fiber optic networks. All right, next question. Which wireless networking standard is commonly used for short-range communication between devices, such as connecting a wireless headset to a smartphone? Would it be NFC? Would it be 802.11x? Would it be Bluetooth? Or would it be SFP? All right, and the correct answer would be Bluetooth. So Bluetooth, this is a wireless standard used for short-range communication, typically within 10 meters. It is ideal for connecting peripherals like headsets, mice, and keyboards to other devices. NFC, or near-field communication, this is used for very short-range data transfers. And 802.11x, this refers to Wi-Fi networking standards. SFP, this is related to fiber optic connections and not wireless communication. All right, and finally, which of the following is the best tool to test functionality of an Ethernet cable to ensure it is wired correctly? Would it be a crimper, a cable tester, a multimeter, or a Bluetooth scanner? And the correct answer will be a cable tester. So a cable tester is used to check the integrity and proper wiring of Ethernet cables. It identifies any issues like miswirings or breaks in the cable. A crimper is used for attaching connectors to a cable, while a multimeter is a general purpose electrical tool and not specifically for networking cables. And a Bluetooth scanner is unrelated to Ethernet cables at all. In this video, you're going to learn about virtualization and cloud technologies. We're going to break down the concepts of virtualization, cloud services, and deployment methods, providing a clear understanding of how these technologies work and their differences. First, let's talk about virtualization. So Virtualization is a technology that allows you to create a virtual version of something, like an operating system, server, or storage device, rather than an actual physical version. Essentially, you're using software to emulate hardware resources. Now, why is virtualization important? It allows organizations to maximize hardware usage, reducing costs, improve scalability, and enhance disaster recovery. With virtualization, you can run multiple operating systems or applications on a single physical machine, enabling efficient use of resources. And there are two key components to virtualization. You have what is called the hypervisor, and then you have what is called the guest operating system. So let's look at these in detail. The hypervisor, this is the software layer that enables virtualization. It sits between the physical hardware and the virtual machines, allowing multiple VMs to share the physical resources of a single machine, such as the CPU, memory, and storage. And hypervisors, they come in two main types. The first one is called a Type 1 or a bare metal hypervisor. And this runs directly on the hardware without a host operating system. And some examples include VMware, ESXi, Microsoft Hyper-V, and Zen Server. Because they run directly on hardware, Type 1 hypervisors are typically used in enterprise environments where performance and efficiency are critical. Then we have what is called a Type 2 hypervisor or a hosted hypervisor, and this runs on top of a hosted operating system. And examples of this include Oracle VirtualBox and VMware Workstation. Type 2 hypervisors are often used for testing and development environments since they are easier to set up but may have slightly lower performance compared to Type 1. So the hypervisor is responsible for managing the VMs and allocating resources as needed, ensuring that each VM operates independently and securely from one another. All right, so let's talk about the guest operating system. So the guest operating system is the operating system installed within a virtual machine. It behaves just like it would on a physical computer. You can install, configure, and run applications on the guest operating system, and each VM can have its own unique operating system. So for example, one VM might run Windows while another runs Linux, all on the same physical hardware. And each VM is isolated from the others, meaning if one guest operating system experiences an issue or failure, it doesn't affect the others running on the same host. And the benefits of virtual machines are as follows. You have resource optimization. So multiple VMs can share the same hardware resources. It provides scalability. So new VMs can be created quickly, and it provides isolation. So each VM is isolated from the others, providing security and stability. Now that we have the foundational understanding of virtualization, let's move on to cloud technologies. All right, so the cloud, this refers to a network of remote servers hosted on the internet that store, manage, and process data. Cloud computing allows users to access and utilize these remote resources on demand without needing to invest in their own hardware. And there are three main cloud service models to become familiar with. The first one is called software as a service. Then we have platform as a service. And then we have what is called infrastructure as a service. And each of these models provides a different level of control and flexibility. And we're going to go ahead and break down each of the models. But before we break them down, on your screen right here is a graphic displaying the differences between infrastructure as a service, platform as a service, and software as a service. So essentially, everything that's highlighted in blue are things that you and or your company are responsible for. And everything that is highlighted in gray is everything that your cloud service provider is responsible for. Now, if you were lost and confused on that last graphic, here is a graphic displaying pizza as a service. So once again, everything in blue is everything that you are responsible for when it comes to providing yourself some pizza. And everything that is in green is everything that the vendor is responsible for in the event that you want to eat some pizza. All right, so let's talk about software as a service. So this is a cloud model where applications are hosted by third-party providers and made available to users over the internet. And the key features of software as a service are as follows. The provider manages the entire infrastructure, including hardware, storage, and the application itself. Users simply access the software through a web browser or a client. And popular examples include things like Google Workspace, Microsoft 365, and Salesforce. And the advantages of software as a service are as follows. It provides accessibility. So you can access your product from any device with an internet connection. It's cost effective, so there is no need for hardware or software installations, and users, they pay a subscription fee, and it provides automatic updates. So the provider manages updates and the maintenance. Software as a service is ideal for organizations that want to use applications without the hassle of managing the underlying infrastructure. Next, we have what is called platform as a service. And this provides a platform allowing developers to build, deploy, and manage applications without worrying about the underlying infrastructure. And the key features are the provider manages servers, storage, networking, and runtime environments. Developers, they focus solely on writing and deploying their code. And examples of platform as a service include Google App Engine, Microsoft Azure App Service, and Heroku. And the advantages of platform as a service are as follows. It allows for development efficiency. So it streamlines the development process by providing tools and frameworks. It allows for scalability. You can easily scale applications as the user demand grows, and it offers time saving. So it reduces time spent on managing servers and other infrastructure components. So platform as a service is great for development teams who want to focus on building and deploying applications without worrying about managing servers or the environment. All right, next we have what is called infrastructure as a service, and this is the most flexible cloud model. It provides virtualized computing resources over the internet. So the key features of infrastructure as a service are as follows. The provider manages the underlying physical infrastructure, such as the servers, storage, and networking, but the customer manages everything else, including the operating system, applications, and data. And popular infrastructure as a service providers include Amazon Web Services, Microsoft Azure, and Google Cloud Platform. And the advantages are it offers flexibility and control. So users can configure their environment as needed. It's cost efficient, so you pay for resources as you use them. And it offers scalability. It's easy to scale up or down depending on your resource needs. So infrastructure as a service, this is ideal for organizations that need control over their infrastructure, but don't want to invest in physical hardware. Now that we've covered different cloud service models, let's discuss deployment models. And these describe how cloud services are deployed and accessed. And the three main models are as follows. You have what is called on-premises, which is also known as a private cloud. Next, you have simply the cloud or the public cloud. And then you have what is called a hybrid cloud. So on-premises, the infrastructure is hosted and managed within the organization's own data center. And this provides greater control over data, security, and compliance. However, it costs more money and requires ongoing management. Then we have the public cloud. So resources are hosted by third-party providers and are accessed over the internet. And examples include AWS, Azure, and Google Cloud. The pros, it has a low initial cost, highly scalable, and is managed by the cloud provider. The cons, you have less control over data security and compliance requirements. And then we have what is called a hybrid cloud. And this is a combination of both on-premises and public cloud solutions. And organizations can store sensitive data on-premise for security while utilizing public cloud services for other workloads. And this provides a balance of cost efficiency, flexibility, and control. So each deployment model has its own set of advantages and is chosen based on the organization's specific needs and requirements. It's important to understand how virtualization and cloud computing relate. Virtualization is the foundation that makes cloud computing possible. However, while virtualization is about creating virtual versions of hardware or software on a local system, cloud computing extends these capabilities by delivering them over the internet as a service. And the key differences are as follows. So virtualization focuses on resource optimization within a single physical system. Cloud computing uses virtualization to provide on-demand resources across distributed servers accessible via the internet. Now, organizations use virtualization to improve resource use within their own data centers, and they use cloud computing to access scalable, flexible resources provided by third-party vendors. So to quickly recap, virtualization allows for the creation of virtual machines through hypervisors and runs guest operating systems for resource optimization. Cloud technologies, they come in three main models. You have software as a service, platform as a service, and infrastructure as a service, each providing different levels of control and flexibility. And deployment models like on-premises, cloud, and hybrid describe how and where these services are accessed. So understanding the differences and use cases of virtualization and cloud technologies is essential for navigating today's IT landscape and is crucial for your CompTIA Tech Plus exam preparation. Now, with all of that being said, let's do this wonderful check on learning. So the first question is, which of the following best describes a hypervisor in virtualization? Would it be a software tool that controls hardware directly without an operating system? Would it be a type of cloud service that allows users to build and deploy applications without managing underlying infrastructure? Would it be a software layer that allows multiple guest operating systems to run on a single physical host? Or would it be a deployment model where resources are fully managed by a third-party cloud provider? And the correct answer would be C. It is a software layer that allows multiple guest operating systems to run on a single physical host. So a hypervisor is a virtualization technology that allows multiple VMs or guest operating systems to run on a single machine, sharing its resources. This helps improve hardware utilization and enables different operating systems to coexist on the same hardware. Next question, which cloud service model provides a fully developed platform that allows developers to build, test, and deploy applications without worrying about underlying infrastructure management? Would it be software as a service, infrastructure as a service, platform as a service, or a virtual private network? And the correct answer would be platform as a service. So platform as a service, this provides a platform that includes hardware, networking, storage, and development tools, enabling developers to focus on building and deploying their applications. Unlike infrastructure as a service, which provides basic infrastructure components, platform as a service abstracts away infrastructure concerns, offering a more managed environment. And the final question, what is the main characteristic of a hybrid cloud deployment model? Is it resources are hosted entirely on the user's premises? Is it resources are entirely hosted by a third-party cloud provider? Is it combines both on-premises and cloud resources to optimize performance, cost, or security? Or is it all services are run through a virtualized hypervisor environment only? The correct answer is C. It combines both on-premise and cloud resources to optimize performance, cost, or security. So a hybrid cloud model integrates both on-premise resources and cloud-based resources, allowing organizations to benefit from the flexibility, scalability, and cost savings of cloud computing while maintaining control over sensitive data and critical applications. In this video, you are going to learn about common internet service types such as fiber optics, cable, digital subscriber line, and the wireless options like radio frequency, satellite, and cellular. And you're going to learn how they work, their benefits and drawbacks, and where they are best used. All right, first, let's discuss fiber optic internet, which is one of the fastest and most advanced internet service types available today. So how does it work? Fiber optic internet transmits data as pulses of light through thin strands of glass or plastic, which are called fiber optic cables. And these light signals travel at extremely high speeds, which allows for fast data transfer over long distances without signal loss. And here are some of the benefits of fiber optics. You got speed and bandwidth. So fiber optic internet is capable of extremely high speeds, sometimes up to 1 gigabit per second or more, which is significantly faster than most other types of internet. And the high bandwidth also supports many users simultaneously without performance issues. Another benefit is reliability. So fiber optic connections are less prone to interference and signal degradation over distance compared to other internet types, making it more reliable for consistent high-speed connectivity. And another benefit it offers is low latency. So because data travels as light, latency is much lower compared to other types of internet, making it great for online gaming, video streaming, and voice over IP services. So one of the drawbacks is the cost and availability. So the main downside is the cost. Laying fiber optic cables is expensive and complex, which limits availability. And fiber optic internet is typically available in urban areas, but can be hard to find in rural regions. And finally, fiber optic is best for heavy internet users who need high speeds and reliability, such as gamers, streamers, or remote workers who use bandwidth intensive applications like video conferencing. Next, let's talk about cable internet, which is one of the most common types available today. So how does it work? Cable internet uses the same coaxial cables that deliver cable TV service to provide internet connectivity. And these cables consist of a central wire surrounded by shielding, which transmits data at relatively high speeds. And the cable modem connects to these coaxial lines to deliver internet access to homes and businesses. And here are some of the benefits. The first one is speed. So cable internet is quite fast and offers speeds up to several hundred megabits per second. While it's not as fast as fiber optic, it is significantly quicker than DSL or older connections like dial-up. Another benefit is it is widely available. So since cable TV infrastructure is widely available, cable internet can be found in many urban and suburban areas, and it offers good bandwidth for streaming and downloading. So cable internet is a popular choice for streaming video, gaming, and downloading large files due to its relatively high speed. So here are some of the drawbacks. It has shared bandwidth. So one limitation of cable internet is that it is shared among multiple users in a neighborhood. This means that during peak hours like evenings when everyone is streaming or online, the speeds can slow down. And another drawback is latency. So latency, which is the delay in data transmission, is typically higher than fiber, but lower than DSL. And the best use case is cable internet is suitable for average households with moderate to heavy internet usage, including streaming videos, playing online games, and working from home. All right, now let's dive into DSL internet or digital subscriber line internet. So how does it work? DSL internet uses existing telephone lines to deliver internet service. Unlike dial-up, which takes over the entire phone line, DSL uses a higher frequency band that allows for internet and phone service simultaneously. And a DSL modem is needed to decode the signals coming through the phone line. So let's talk about the benefits. And the first one is availability. So DSL is available in most places where there's a phone line, making it widely accessible, even in some rural areas. It also has a dedicated connection. So unlike cable, which shares bandwidth with neighbors, DSL provides a dedicated connection. This means that your speeds will generally remain consistent regardless of the time of day. So what are some of the drawbacks? Well, one is it offers slower speeds. So DSL is generally slower than both fiber optic and cable internet, typically ranging from a few megabits per second to around 100 megabits per second for higher end DSL services. And another drawback is distance sensitivity. So DSL speed and quality depend on the distance from the provider's central office. So basically, the further you are, the weaker and slower the signal will become. And what are the best use cases? So DSL is best suited for users with lighter internet needs, such as web browsing, checking email, and basic streaming, especially in areas where faster options like cable or fiber are not available. All right, now let's turn to wireless internet options, which include radio frequency, satellite, and cellular. And wireless internet doesn't rely on physical cables to connect users to the internet. So let's talk about radio frequency internet. So RF internet uses radio signals to transmit data between a local service provider's antenna and a receiver installed at the customer's location. And these signals travel over the air. So what are the benefits? First one is rural access. So RF internet is especially useful in rural or remote areas where physical cables for DSL or cable are not available, and it offers quick deployment. Because no cables need to be laid, wireless RF internet can be set up faster than wired services. And some of the drawbacks include line of sight requirements. So the RF signal often requires a clear line of sight between the receiver and the transmitter tower, meaning that trees, buildings, or other obstructions can disrupt the signal. And also, it is sensitive to weather, so signal quality can be affected by weather conditions like rain or storms. And the best use case for RF is for rural users who do not have access to fiber, cable, or DSL connections. Next, let's talk about satellite internet. So satellite internet uses geostationary satellites to beam data from an orbiting satellite down to a dish installed at a customer's location. And the main benefit is it offers global coverage. So since it relies on satellites in orbit, satellite internet can reach remote or rural areas that other service types cannot. And some of the drawbacks include high latency. So because the signal has to travel from the satellite in space to Earth, there is a noticeable delay or high latency in data transmission. And this can make activities like online gaming or voice over IP calls less smooth. And satellite internet is impacted by the weather. So satellite internet is susceptible to weather conditions like heavy rain or storms, which can interfere with the signal. And the best use case is typically used as a last resort option for users in extremely remote areas where no other form of internet is available. All right, next let's talk about cellular internet connections. So cellular internet uses cell towers to provide internet access via mobile networks. The user's device, such as a smartphone, a mobile hotspot, or 4 or 5G modem, connects to the nearest cell tower for internet access. And the benefits it offers is mobility and convenience. So cellular internet is highly mobile and available wherever there is a cellular signal. This makes it perfect for users who need internet access on the go. And another benefit is it offers increasing speeds. So with advancements from 3G to 4G and now to 5G, cellular internet speeds have greatly improved. And 5G in particular offers speeds comparable to fiber optic in some cases. Now, some of the drawbacks: it can offer limited data plans. So many cellular plans have data caps or limited high-speed data, making it less suitable for heavy users who consume large amounts of bandwidth. And it can have some coverage gaps. So while cellular coverage is widespread, there can still be gaps in service, particularly in rural or remote areas. And the best use case is for users who need mobile connectivity, such as those who travel frequently or live in areas where fixed line services are unavailable. So to summarize, each type of internet service has its unique advantages and drawbacks. So fiber optic, it's ultra fast and reliable, but limited by cost and availability. Cable, it's widely available with good speeds, but bandwidth can be shared among neighbors. DSL is reliable in terms of dedicated connections, but slower and affected by distance. RF wireless is good for rural areas, but requires a clear line of sight. Satellite internet can offer a global reach, but it is susceptible to high latency and weather. And then we have cellular internet is good for mobility, and it offers improving speeds, but it may have data caps and coverage limitations. Now, understanding these differences helps you select the best internet service for different scenarios, and this is key for the CompTIA Tech Plus certification exam. All right, so with all that being said, let's do this check on learning. So which of the following internet service types typically offers the highest potential download speeds and low latency, making it suitable for activities like HD video streaming and online gaming? Would it be cable? Would it be DSL, satellite, or fiber optic? And the correct answer would be fiber optic internet. So fiber optic internet uses light signals transmitted through glass fibers, providing extremely high download and upload speeds with low latency. This makes it ideal for demanding applications such as HD video streaming and online gaming. Cable and DSL are slower, and satellites generally have higher latency. Next question, which internet type is commonly shared among users in a neighborhood, potentially causing speed variations during peak usage times? Would it be wireless cellular? Would it be fiber optic? Would it be cable? Or would it be DSL? And the correct answer is cable internet. So cable internet operates over coaxial cables and is often shared among users within a local neighborhood. Because of this shared nature, speeds can vary depending on the time of day and the number of active users. DSL connections are generally more consistent as they are dedicated lines, while fiber optic and cellular connections are not typically subject to the same level of shared bandwidth issues. And the final question is, what is a major drawback of satellite internet compared to other common internet service types? Is it low availability in rural areas? Is it extremely low latency? Is it high susceptibility to weather conditions? Or is it limited data plans for wireless connections? And the correct answer is high susceptibility to weather conditions. So satellite internet is often used in rural areas where other types of connections are unavailable. However, it is highly susceptible to weather conditions, which can interrupt service. It also has higher latency compared to cable, DSL, and fiber optic, making it less suitable for activities that require real-time data transmission, like online gaming or video calls. And the limited data plans for wireless connections apply more to cellular internet. In this video, we're going to break down the basics of networking concepts. You're going to learn everything from how networks communicate to the devices and models that make networking possible. So let's go ahead and check all this information out. All right, to start, let's discuss the basics of network communication. So at its core, a network is a system of interconnected devices such as computers, printers, and servers that communicate with each other. And the purpose of a network is to share data and resources efficiently. And there are two fundamental types of communication in networking. You have wired communication. This uses physical cables like Ethernet to connect devices, providing reliable and fast data transfer. And then we have wireless communication. This utilizes radio waves to connect devices over a wireless network such as Wi-Fi. While convenient, it can be more prone to interference and slower than wired connections. When devices communicate, data is transferred in the form of packets, which are small chunks of information that travel from the source to the destination. A key concept to understand here is the protocol, which is a set of rules that governs how data is transmitted across the network. And the most common protocol is called TCP/IP, or Transmission Control Protocol / Internet Protocol, which ensures data is sent and received accurately. Now, think of network communication like sending a letter. The data packet is the letter itself, the protocol is the postal system rules, and the network is the road on which the letter travels. All right, now let's dive into network identifiers, which help devices find and communicate with each other on a network. And the two main types are called IP addresses and MAC addresses. So IP addresses, this stands for Internet Protocol Address. This is a unique identifier assigned to each device on a network. There are two versions of IP addresses. The first one is called IP version 4, and this is the most commonly used format, consisting of 4 numbers separated by periods. And then we have IP version 6. This is the newer format designed to replace IP version 4 and accommodate the growing number of devices. And it consists of 8 groups of 4 hexadecimal digits. And an IP address, essentially, this helps route data to the correct destination. Then we have what is called a MAC address, or the Media Access Control Address. And this is a hardware identifier that is unique to each network interface card. It's a 12-digit hexadecimal number that is typically burned into the hardware by the manufacturer. Now, unlike IP addresses, which can change, MAC addresses are static and serve as a permanent physical address for a device on a network. And next we have what are called ports. So a port, this is a logical endpoint used for network communication. Different services use different port numbers to identify themselves. So for example, HTTP uses port 80, HTTPS, which is secure web browsing, this uses port 443, and File Transfer Protocol, or FTP, this uses port 21. And then we have SMTP, or Simple Mail Transfer Protocol, which is used for sending emails. This uses port 25. So think of ports as doors that allow specific types of network traffic to enter or leave a device. All right, now let's explore some basic network services, which are functions and applications that use networks to provide specific features to users. So the first one we're going to talk about is secure web browsing. So secure web browsing is conducted using HTTPS, which stands for Hypertext Transfer Protocol Secure. And this encrypts the data transmitted between the web server and your browser, protecting it from eavesdropping. And it's critical for activities like online shopping, banking, or any web-based service that handles sensitive data. Then we have file transfer, and this service allows the movement of files across networks. And File Transfer Protocol and Secure File Transfer Protocol are commonly used protocols for transferring files between devices, with SFTP providing an encrypted channel for secure transfers. And then we have email services, and these rely on various protocols for sending, receiving, and storing messages. We have SMTP, or Simple Mail Transfer Protocol. This is used to send emails, while IMAP, which stands for Internet Message Access Protocol, and POP3, or Post Office Protocol version 3, those two protocols are used to retrieve emails from a server. All right, so let's move on to networking devices. And this is the hardware that makes network communication possible. So the first piece of hardware is the modem. And modem actually stands for modulator demodulator. And this converts digital data from a computer into analog signals suitable for a transmission medium like a phone line or a cable system, and vice versa. And essentially, a modem, it connects your home network to your ISP or your internet service provider. All right, next we have what is called a router. And a router, this directs data packets between networks, such as between your home network and the internet. It uses IP addresses to determine the best path for forwarding data to its destination. And routers, they also provide this thing called NAT, or network address translation, which allows multiple devices to share a single public IP address. Next device is called a switch. And a switch, this connects devices within a local area network, or a LAN, and it uses MAC addresses to forward data to the correct device, enabling efficient communication within a network. All right, next we have what is called an access point. So an access point, this is a device that allows wireless devices to connect to a wired network, and it often works in conjunction with a router to expand the reach of a wireless network. And then we have what is called a firewall. So a firewall, this is a security device that monitors and controls incoming and outgoing network traffic based on predefined security rules. And firewalls, they can be hardware-based or software-based and serve as a barrier between your internal network and the outside world to block malicious traffic. And then we have a concept called a SOHO router, and that stands for Small Office Home Office Router. And basically, this is the device that you probably have in your house right now that you call just the router. And what this device does, it combines the functionality of the router, the switch, the access point, and the firewall all into one device. And like I said earlier, if you're sitting in your house surfing the internet right now, you more than likely have one of these devices in your house somewhere. All right, next, let's discuss networking models, which are approaches to organizing devices and services on a network. So the first model is called the client-server model. So in a client-server model, one or more servers provide services or resources, and clients, they request access to those resources. And common services include file storage, web hosting, and email services. So for example, when you use a web browser, your computer is the client and the web server hosting the website is the server. And then we have what is called a peer-to-peer model. So in a peer-to-peer model, every device on the network can act as both a client and a server. This means any device can share resources such as files or printers with any other device. And peer-to-peer is often used for small networks like home networks and for file sharing applications like BitTorrent. All right, lastly, let's look at network types. And we're going to talk about local area networks and wide area networks. So a local area network, this is a network that connects devices within a limited geographic area, like an office building, a school, or a home. And local area networks are typically fast and use Ethernet cables or Wi-Fi to connect devices. So think of the network in your house right now. That is a local area network. And then we have what is called a wide area network. So a wide area network, this covers a much larger geographical area, such as a city, country, or even the world. And the most well-known example of a wide area network is the internet. And wide area networks, they often use leased telecommunication lines, satellites, or VPNs to connect multiple LANs over large distances. So in short, a LAN is like a local neighborhood network, while a wide area network is more like an interconnected network of many neighborhoods covering vast areas. So to wrap all of this up, in this video, we've talked about network communication basics and understanding how data is transmitted across wired and wireless networks. We talked about network identifiers, including IP addresses, MAC addresses, and ports that allow devices to communicate effectively. We talked about basic network services, such as secure web browsing, file transfer, and email. We talked about networking devices, from modems to routers, switches, access points, and firewalls. We talked about networking networking models, where we compared the client server and the peer-to-peer approaches. And we talked about network types, where we distinguished between local area networks and wide area networks. Now, understanding these concepts is foundational for the CompTIA Tech Plus exam and helps you grasp the essentials of how networks function. All right, now with all of that said, let's get into the check on learning. So the first question is, which of the following is the correct description of an IP address? Is it a unique identifier for a computer on a network that is assigned to the computer's network interface card? Is it a numerical label assigned to devices on a network that uses the internet protocol for communication? Is it a physical address burned into the network interface card that cannot be changed? Or is it a system that translates domain names into IP addresses? And the correct answer is, it is a numerical label assigned to devices on a network that uses the internet protocol for communication. So an IP address is a unique numerical label assigned to each device connected to a network that uses IP for communication. It helps in identifying the device and facilitates the routing of data. Next question, which device is responsible for directing network traffic between different networks by using IP addresses? Would it be a modem, a switch, a router, or a firewall? And the correct answer is a router. So a router is responsible for directing data between different networks by analyzing IP addresses. It ensures that packets of data reach their correct destinations across networks. And a modem, this connects a network to the internet, and a switch connects devices within a network, and a firewall is used to secure network traffic. And our final question, which of the following best describes a peer-to-peer network model? Is it a network where computers share resources directly with each other without a centralized server? Is it a network where a central server manages all resources and controls client devices? Is it a large network that spans multiple geographic areas, typically involving multiple LANs? Or is it a network that exclusively uses wired connections for communication between devices? And the correct answer is, it is a network where computers share resources directly with each other without a centralized server. So in a peer-to-peer network, each computer or peer can act as both a client and a server, allowing direct sharing of resources such as files and printers without a central authority managing the network. In this video, we're going to take an in-depth look at small wireless networks. We'll cover the most common wireless networking standards, such as 802.11n, 802.11ac, and 802.11ax, and explore factors like speed, interference, attenuation, and band options. We'll also compare older and newer standards and explain how different frequency bands, such as 2.4 gigahertz, 5 gigahertz, and 6 gigahertz, impact network performance. All right, first, let's talk about wireless networking standards. So the IEEE 802.11 standards are the set of protocols that define wireless networking. Each standard specifies how wireless devices communicate over a network and sets parameters like speed, frequency, and range. Now, over the years, these standards have evolved to meet increasing demands for faster speeds and better performance. And the most commonly used standards today are the 802.11n, which is also known as Wi-Fi 4. You got 802.11ac, which is known as Wi-Fi 5, and 802.11ax, which is known as Wi-Fi 6. So let's explore each of these standards in more detail. The 802.11n standard, or Wi-Fi 4, this was released in 2009 and is still widely used in many home and small business networks. It improved on earlier standards by offering dual band support, meaning it operates on both the 2.4 gigahertz and 5 gigahertz frequency bands, allowing users to select a frequency based on their needs. It also has speeds up to 600 megabits per second. So 802.11n introduced the ability to reach theoretical speeds of up to 600 megabits per second, significantly faster than its predecessors. And it also supports what's called MIMO, or multiple input, multiple output. And this technology uses multiple antennas for both transmitting and receiving, which improves the speed and range. However, while 802.11n provides a decent level of performance, it's been surpassed by more recent standards that deliver faster speeds and better handling of network congestion. Next is the 802.11ac or Wi-Fi 5, and this was introduced in 2014. And this standard further improved wireless speeds and performance. So 802.11ac can achieve speeds up to 3.5 gigabits per second under optimal conditions, making it over 5 times faster than 802.11n. And it also has support for the 5 gigahertz frequency band. It primarily operates in the 5 gigahertz band, which is less crowded than the 2.4 gigahertz band, reducing interference and enabling faster data transfer. And then it also supports multi-user MIMO. So while 802.11n introduced multiple input, multiple output, 802.11ac improved upon it with multi-user, multiple input, multiple output, allowing multiple devices to receive data simultaneously. This is great for environments with many connected devices like households or small offices. So 802.11ac provided significant speed and performance improvements over 802.11n, but as more devices began connecting to wireless networks, a new standard was needed to handle the increased demand. The latest standard, 802.11ax, which is also known as Wi-Fi 6, this was released in 2019. It focuses on improving not just speed, but also efficiency and capacity. So Wi-Fi 6 supports speeds up to 9.6 gigabits per second, which is a massive leap from 802.11ac. It also supports efficient multi-device management. So with OFDMA or orthogonal frequency division multiple access, Wi-Fi 6 can divide a wireless channel into smaller frequency allocations, allowing multiple devices to be served simultaneously without congestion. It supports TWT or target wait time. And this feature optimizes device power usage, allowing connected devices to wake up and transmit data only when needed, which is particularly useful for IoT devices. And it also operates on the 2.4 gigahertz, 5 gigahertz, and 6 gigahertz bands. So unlike 802.11ac, Wi-Fi 6 operates on both the 2.4 and 5 gigahertz bands, offering backwards compatibility and flexibility for different network environments. And Wi-Fi 6E, this also expands to the 6 gigahertz band, offering even more bandwidth and reduced interference. Now, Wi-Fi 6 is designed to meet the increasing demands of modern devices, providing better performance in crowded networks and delivering faster, more reliable connections. When comparing these standards, speed is a crucial factor. So 802.11n, this supports speeds up to 600 megabits per second, which is sufficient for most basic internet activities like web browsing, video streaming, and email. 802.11ac, this can reach speeds up to 3.5 gigabits per second, making it ideal for high-definition video streaming, online gaming, and multiple device connections. 802.11ax, also known as Wi-Fi 6, this reaches up to 9.6 gigabits per second and can handle high density environments with many connected devices, ensuring stable and high speed connections. Now keep in mind, these are theoretical maximum speeds. Actual speeds may vary due to factors like interference, distance, and network congestion. Now let's talk about interference and attenuation. So interference occurs when other devices operate on the same frequency band, causing the wireless signal to degrade. So for example, microwaves, baby monitors, and Bluetooth devices, they all operate on the 2.4 gigahertz band, and they can interfere with Wi-Fi signals. Attenuation, this refers to the weakening of a signal as it travels through the air or through objects like walls and furniture. Higher frequency bands like 5 gigahertz and 6 gigahertz, they have a shorter range and are susceptible to attenuation than the 2.4 gigahertz. So this is why it's important to choose the right frequency band based on the environment. The 2.4 gigahertz band has a longer range, but is more prone to interference, while the 5 gigahertz band offers faster speeds with less interference, but over a shorter distance. And the 6 gigahertz band and Wi-Fi 6E, this provides even faster speeds and lower latency, but also has a limited range. All right, next, let's break down the three main frequency bands used in wireless networks. So the first one is the 2.4 gigahertz band, and this has a longer range and lower speeds. So it has a greater reach and can penetrate walls better, but its maximum speed is slower than higher frequency bands. Also, it is a crowded band, so many household devices use this band, leading to potential interference. Then we have the 5 gigahertz band. and this has higher speeds but a shorter range. So this band provides faster data transfer rates than the 2.4 gigahertz, but with a reduced range. And since fewer devices use this band, there is generally less interference. And then we have the 6 gigahertz band, and this is the newest addition to Wi-Fi frequency options, offering even faster speeds and lower latency. And since fewer devices currently operate on this band, it provides a cleaner, more efficient experience. So choosing the right band depends on your network needs. For long-range connections or environments with many obstacles, the 2.4 gigahertz band may be preferable. For faster speeds with reduced interference in smaller areas, 5 gigahertz or 6 gigahertz bands are better options. Now let's discuss older versus newer standards. So older standards like 802.11a, 802.11b, and 802.11g, they were the predecessors of the standards we discussed earlier. They offered much slower speeds, with 802.11b capping at 11 megabits per second and 802.11g at 54 megabits per second. And they were also limited to either the 2.4 gigahertz or 5 gigahertz band without dual band capabilities. Now, as technology evolved, newer standards like 802.11n, 802.11ac, and 802.11ax provided faster speeds, better handling of multiple devices, and more efficient use of the frequency spectrum. When setting up a small wireless network, opting for modern standards like Wi-Fi 5 or Wi-Fi 6, this ensures optimal performance and future-proofs the network as technology continues to advance. So to recap, we've covered the key standards of wireless networking, such as 802.11n, 802.11ac, and 802.11ax, and we explored their speed capabilities, interference and attenuation factors, and frequency band options such as 2.4 gigahertz, 5 gigahertz, and 6 gigahertz. Understanding these fundamentals will help you design and manage a small wireless network effectively, and it's essential knowledge for the CompTIA Tech Plus certification exam. All right, now with all that said, let's get into this check on learning. So what is the primary advantage of 802.11ax or Wi-Fi 6 compared to 802.11ac or Wi-Fi 5? Is it higher data transfer speeds? Is it reduced network interference? Is it a greater range? Or is it better energy efficiency for connected devices? And the correct answer is it offers higher data transfer speeds. So 802.11ax or Wi-Fi 6, this offers improved data transfer speeds compared to 802.11ac due to more efficient data transmission techniques like OFDMA and multi-user, multiple input, multiple output. While Wi-Fi 6 also provides better energy efficiency, the primary advantage is its ability to handle more devices at faster speeds. Next question, which of the following wireless frequency bands is least prone to interference in a small wireless network? Would it be 2.4 gigahertz, 5 gigahertz, 6 gigahertz, or 900 megahertz? And the correct answer would be the 6 gigahertz band. And this was introduced with Wi-Fi 6E, and it is less crowded and less prone to interference compared to the 2.4 or the 5 gigahertz bands, which are commonly used and often congested. The 6 gigahertz band, this also supports higher speeds, but has a shorter range due to higher frequency. And our final question, which of the following factors is most likely to cause signal attenuation in a small wireless network? Would it be the number of connected devices, the distance between the router and the devices, frequency band using 2.4 versus 5 gigahertz, or encryption methods such as WPA2 versus WPA3? And the correct answer would be the distance between the router and the devices. So signal attenuation, this refers to the reduction in signal strength as it travels over a distance. The further a distance is from the wireless router, the weaker the signal becomes. Additionally, high frequency bands such as 5 gigahertz tend to attenuate faster than lower frequencies such as 2.4 gigahertz over the same distance. In this video, we're going to be talking about how the internet works in your house. Exactly how does all this stuff mesh together to make the internet possible? Well, I'm going to show you guys with my handy dandy Picasso skills in this video as to exactly how all of this actually works in the most simplified manner that I can think of without going into extreme grave detail. All right, so in your home, you more than likely have a smartphone, some type of tablet, or maybe even a laptop that you use for wireless internet connectivity so you can get out there and live your best life surfing these internet streets. Also in your house, you may have a laptop or a desktop computer that may be hardwired to your wireless router in your house. So this is typically what you will find in the average household. You will find mobile devices and you'll find desktop computers, right? So these devices, they are connected to a device called a switch. And this is a switch right here that is being represented by a little square with two arrows going in opposite directions. Also, if you're using mobile, you may have another device called an access point or a wireless access point. Also, there is another device called a router, which is represented by this circle right here that has arrows going up and down and left and right. And then there is another device called a modem, which is going to be represented by this device. We'll just put MD for modem. And then you have the internet, which is represented by this cloud looking thing over here. All right, so these are the basic components for how the internet works, which allows for you to press the enter key on your keyboard and go way over here to watch a YouTube video like Tech G. So how does all this work? So like I said, we got a mobile device, which is your wireless device. And what this does, your wireless device, it connects to this access point right here. This access point is then physically connected by way of a Cat5 cable to the switch. If you have a desktop computer with a wire hanging out of it, that's called a Cat5 cable, it is hardwired to the switch as well. And then you have your switch that is hardwired to the router. And then you have your router that is hardwired to your modem. And then you have your modem, we're just going to use this little squiggly line here to represent that it's going out there to the great internet so it can retrieve whatever content you're looking for. Okay. Now, how this directly relates to your house is you guys more than likely don't have a separate switch, you don't have a separate access point, and you don't have a separate router. These three devices right here are typically combined into what is called a SOHO router, small office, home office router, or your wireless router as you guys all know it. So you guys go look at your wireless router, you might see some antennas hanging off of it. You'll see a couple ports on there, and then you see another port that has some type of Cat5 cable or something hanging out of it. That is your wireless router. Basically in a SOHO environment, it combines all of those elements into one device to save you money and save you space. All right, so how this works is like this, ladies and gentlemen. So you're on your mobile phone, you're over here pressing buttons, you're on your laptop, you're over here pressing buttons, because you want to see Amazon.com over here, or you want to watch a YouTube video over here, right? That's what you're out here doing, trying to live your best life, right? So as you're pressing buttons, you're actually sending a bunch of ones and zeros across the ether or across the wire. Ones and zeros. They're physically moving across these mediums right here. If you're on mobile, your ones and zeros travel through the air and they hit this access point, which then converts the ones and zeros to put them on a physical wire and send them down into the switch. If you're on a hardwired connection like a PC and you're pressing buttons to get access to YouTube or Amazon or Google, it sends those ones and zeros directly into the switch. And what the switch actually does, the switch says, hey, I recognize both of these devices. They're allowed to be in this network. I'm going to let you communicate to try to get on out here to the wild, wild internet, right? Now, everything from the switch back to your mobile devices, this is called your LAN, your local area network. Your switch manages all the devices within your network that are trying to reach out and communicate with the internet. And how it recognizes this stuff is by it keeps essentially a record of the MAC addresses that are associated with these devices. Now, after it collects all the ones and zeros saying, hey, I want to go out there and reach the internet, it then passes it off to the router. The router then takes those ones and zeros and says, hey, you want to go to Amazon, you want to go to YouTube. Okay, let me slap a quote unquote destination label on top of these ones and zeros. So I guess the best way you could think of this like a package that you are dropping off at the post office that you're trying to mail to a friend. You box the package up. Inside the box are all your ones and zeros. At the post office, they go ahead and print a label out, slap a label on the box, and throw it in the back to prepare for it to be shipped. This is what the router essentially does. It takes your ones and zeros that have been handed off from the switch and prepares it to get a destination label slapped on it, so your ones and zeros can go to their appropriate destination so that you can interact with the internet. So after the router does that, the router then sends that information to the modem, and modem stands for modulate, demodulate. So what the modem actually does, depending upon the type of internet connection that you are paying for that's coming into your house, it's going to take those ones and zeros that have been packaged up by the router and put them in the digital equivalent of an Amazon Blue Truck. So you're like, wait a second, what do you mean? So when the Amazon guy goes to pick up your packages from the warehouse, they put the packages into the Amazon Blue Truck, and next thing you know, you see the Amazon Blue Trucks driving all around the city to deliver the packages. This is what the modem essentially does. Now, how this works is like this. So you may have a fiber connection, you may have cable internet, you may have DSL, you may have satellite, or you may have RF. Line of sight or radio frequency internet. Depending upon what type of internet connection that you have that you are paying for to go to your house is going to determine the speeds that your ones and zeros are going to travel back and forth across the internet. So you could think of it like this. Here we are at the Amazon warehouse or the post office, and we're getting ready to ship these packages out, our ones and zeros that are in the box with their shipping label on it, right? If we have satellite internet, just imagine that I'm taking my package of ones and zeros and I'm putting them inside of a garbage truck that can only travel 45 miles per hour. Well, the garbage truck signifies my internet connection, and the 45 miles per hour signifies as to how fast my connection can actually push the ones and zeros across the wire for me to establish connection with whatever website that I'm trying to interact with. And we all know garbage trucks are pretty slow, and the slowest internet connection up on here would be satellite. So think of satellite as your garbage truck. Now, let's just say you have a fiber connection. Well, just imagine you're going into the modem or you're going into your garage and you see a Ferrari sitting in the garage. Well, Ferraris are pretty fast vehicles. So just imagine that your fiber connection is the Ferrari, and you throw your packages into the Ferrari and you want to get your packages across town. Let's just imagine that there are no speed limits on the highway. Well, that Ferrari is going to be able to get up and get it at really fast speeds in comparison to that of a garbage truck, aka your satellite connection. So essentially, the modem is basically the means for how fast it's going to allow your ones and zeros to travel across the wire so that you can interact with whatever website that you're trying to interact with by the time you hit the enter button on your computer and you request to watch a YouTube video, and by the time that thing comes back to you so you can watch that video. Your modem and your internet connection are going to dictate how fast those speeds are actually moving, okay? And then finally, everything that's within this blue line right here, this represents your actual network right here. This is your actual network that you are trying to get to communicate with another network out here somewhere, whatever website that you're trying to visit and do whatever it is that you're trying to do on the internet. All right. So this is just a very simple explanation as to how the internet works. I'm not trying to go into super detail about how to program all this stuff up. I just want those of you who are new to IT just to understand what these components actually do. So we have our mobile device. We have our desktop computer. Our desktop computer has a hardwired connection to the switch. Our mobile device is connected to an access point. The access point is hardwired to a switch. The switch is then hardwired to a router, and the router is connected to the modem. The switch pretty much controls all the devices that are trying to connect to the internet. The router essentially takes the ones and zeros that these devices are transmitting and slaps destination labels on the ones and zeros so that your ones and zeros can reach their appropriate destination to whatever website that they're trying to go to. The modem is basically basically the means of transportation for how fast your ones and zeros are going to be traveling across the wire, depending upon what type of internet connection you have coming to your house. If you have fiber, you have the fastest internet connection possible. If you have satellite, you have probably the slowest internet connection possible. So that is essentially what the modem does. But like I said earlier, most of you guys don't have a separate access point. You don't have a separate switch. You don't have a separate router. Most of y'all probably just have a wireless router and a modem in your house, and the access point, the switch, and the router. These things are typically combined to form what is called a SOHO router, or a small office home office router. So in a nutshell, ladies and gentlemen, this is essentially how the internet works in a very super simplified explanation. In this video, we're going to explore key components of an operating system. Understanding these elements is critical for anyone studying for the CompTIA Tech Plus exam. And by the end of this video, you'll have a solid understanding of the file systems, file management, system applications, utilities, services, processes, drivers, interfaces, and file attributes. The file system is a crucial part of an operating system as it determines how data is stored and organized on storage devices. So let's explore some key characteristics of file systems. Let's talk about compression. So compression, this reduces the size of files and folders to save disk space. And there are two main types. First one is lossless compression, and this reduces file size without losing any data. So for example, think of a zip file, and then we have what is called lossy compression. And this reduces the file size, but may lose some data quality. And this is typically used for audio and video files. Compression can improve storage efficiency, but may affect performance when files are being accessed or modified. Another component is encryption. So encryption, this secures files by converting them into unreadable formats without a key. This helps protect sensitive information from unauthorized access, and common encryption standards include AES, or Advanced Encryption Standard, which is widely used for data security. Next, we have types and extensions. So the type of file system determines how files are named, stored, and accessed. And common file system types include NTFS, which stands for New Technology File System, and this is used by Windows and supports large file size, permissions, encryption, and compression. Then we have what is called FAT32, and that stands for File Allocation Table 32. And this is an older file system type that is compatible with many devices, but is limited to a maximum file size of 4 gigabytes. And then we have ext4, which stands for Fourth Extended File System. And this is a common Linux file system that supports journaling for data integrity, and file extensions like .txt and .exe or .jpeg. They indicate file types and determine how the operating system handles each file. Next, let's talk about file management. So file management within an operating system involves how files and folders are organized, named, and accessed. So let's break down some of the key concepts. First one is folders and directories. So folders, which are also known as directories, are containers used to organize files in a hierarchical structure. So think of folders like a file cabinet, where each cabinet contains folders and each folder contains documents. This helps users efficiently store and retrieve files. Then we have permissions. So permissions, they control access to files and directories. And the most common permission types include read, which allows viewing the contents of a file or directory. Then we have the write permission. This allows modifying or deleting a file or directory. And then we have the execute permission, and this allows running a file as a program. In most operating systems, users are granted different permission levels to maintain security. Then another aspect is naming restrictions. So each operating system has its own rules for naming files and directories. So in Windows, files can be up to 255 characters, but they cannot contain certain symbols like the ones listed on your screen right here. And then in Linux or Unix, file names are case sensitive and can contain almost any character except for the /. So proper file management, this is essential for ensuring organized data, preventing unauthorized access, and maintaining a clean system. Next, let's talk about system applications and utilities. So an operating system provides essential system applications and utilities that help users manage their computers. So let's explore some of these tools. So let's talk about the system applications. These are core applications provided by the operating system for common tasks. So we have things like File Explorer and Finder. So in Windows, this is known as the File Explorer, and in Mac, it's called the Finder. And these tools allow you to navigate, open, and manage files and control folders. Then we have the control panel and the settings. This is where users configure the system settings like display options, network connections, and device management. Then we have utilities. Utilities, these are specialized tools to perform maintenance tasks. So we have utilities like disk cleanup and storage management. This utility helps free up space on your drive by deleting unnecessary files. Then we have the task manager and the activity monitor. These allow you to view running applications and processes as well as system performance. And then we have antivirus, anti-malware software. This protects the system from malicious software. So system applications and utilities are essential for maintaining system health, configuring settings, and ensuring a smooth user experience. Another important component of the operating system is how it manages services and processes. So services, which are sometimes called background processes, are programs that run in the background to perform specific tasks. So for example, we have what is called the print spooler. This manages print jobs that are sent to a printer. And then we have what is called the web server service. This hosts websites and serves pages to users on the network, and services can start automatically with the operating system or be started manually as needed. Then we have what are called processes. So a process, this is any running instance of a program. So each program or application opened by the user starts one or more processes. And there are two main types of processes. The first one is called a foreground process. And this is visible to the user, like your web browser or text editor. And then we have what is called a background process. And these are hidden from the user. And these are often system services that support the foreground processes. So by managing services and processes effectively, an operating system can ensure that multiple tasks are performed simultaneously without disrupting the user experience. Next, let's talk about drivers. So drivers are specialized software that allows the operating system to communicate with hardware devices. So think of drivers as translators between hardware components and the operating system. So for example, when you connect a printer to your computer, a print driver is needed to send the correct print commands. And graphic card drivers, they allow the operating system to fully utilize the GPU's capabilities for rendering images and video. So drivers ensure that hardware devices function properly, and they often need to be updated to maintain compatibility with the operating system or to add new features. Next, let's talk about interfaces. So the interface is how users interact with the operating system. There are two main types. The first one is the console or the command line interface. So with CLI, this allows users to interact with the operating system by typing commands into a console or terminal. While it may seem complex, it's very powerful for executing tasks quickly and efficiently, particularly for system administrators or power users. And examples include the following. You have what is called Windows Command Prompt or PowerShell. And then for Mac or Linux, they use what is called Bash or other shells. And then we have what is called the graphical user interface. So a GUI, this provides a visual way for users to interact with the operating system through windows, icons, and menus. And it's more user-friendly than a CLI and is what most people use on a daily basis. And some examples include the Windows desktop environment, and this includes the start menu, the taskbar, and windows for different applications. In Mac, it provides what is called a dock, the file explorer, and a menu bar. And then in Linux desktop environments, they have what is called GNOME, KDE Plasma, or XFCE. Both interfaces have their use cases. The GUI is for ease of use and visual navigation, and the command line interface is for powerful and efficient command execution. Lastly, let's look at the file attributes and properties. So attributes and properties provide additional information about a file or directory and control how it behaves. And some common file attributes include the read-only attribute, and this prevents modification of the file. Then we have the hidden attribute. This makes a file invisible to standard directory listings unless special settings are enabled. And then we have the archive attribute, and this indicates that the file has changed and needs to be backed up. Now, file properties, they provide more detailed information such as the file size, and this indicates the amount of space the file occupies on the disk. Then we have the data created modified property, and this lists when the file was originally created or last modified. Then we have the file type property, and this is based on its extension such as the .txt for text files or the .exe for executable files. Understanding these attributes and properties helps users and administrators manage files efficiently, control access, and keep track of file modifications. So to summarize, we've covered key concepts of an operating system, including the file system characteristics, which offers compression, encryption, types, and extensions. We talked about file management. This is the organization of folders, permissions, and naming restrictions. We talked about system applications and utilities. These are tools for managing and maintaining your system. We talked about services and processes. These are background tasks that keep your system running smoothly. We talked about drivers. These are the links between hardware and the operating system. We talked about interfaces. These are the ways users interact with the operating system, either through the command line interface or the graphical user interface. And we talked about file attributes and properties. And these are additional details and behaviors of files and directories. So understanding these core concepts is vital for mastering how operating systems work and is key for passing the CompTIA Tech Plus certification exam. All right, now with all of that said, let's get into some of this check on learning. So which of the following file system types supports file encryption and compression in Windows? Would it be NTFS? Would it be FAT32? Would it be exFAT? Or would it be HFS Plus? And the correct answer is NTFS, or New Technology File System. And this supports file level encryption, compression, and advanced permissions. FAT32 and exFAT are simpler file systems that do not provide these features. And HFS Plus, this is used by Mac and is not native to Windows file system. Next question. Which of the following tools is used in most operating systems to manage system processes and services? Would it be Disk Cleanup? Would it be Task Manager? Would it be File Explorer? Or would it be Command Prompt? And the correct answer is the Task Manager. So the Task Manager is used to view and manage running processes, services, and system performance. Disk Cleanup is used to free up disk space. File Explorer is for managing files, and Command Prompt is a console interface for running commands. Final question. Which of the following is a naming restriction for files in most modern operating systems? Is it files cannot contain spaces in their names? Is it files cannot have more than 128 characters in the name? Is it files cannot contain special characters like the asterisk or the question mark? Or is it files cannot use numbers in their names? And the correct answer is files cannot contain special characters like the asterisk or the question mark. So most operating systems restrict the use of special characters in file names because they are reserved for specific system functions. In files, they can contain spaces and numbers, and the length limit varies depending on the file system. In this video, we're going to explore a key topic from the CompTIA Tech Plus exam, operating systems. We'll discuss what an operating system is, its key roles, and the different types of operating systems in the computing world. We'll cover everything from how the operating system acts as an interface between applications and hardware to its responsibilities in disk management, task management, device management, and more. First, let's talk about the interface between applications and hardware. So an operating system acts as a bridge between hardware like your CPU, memory, and disk drivers, and software applications like web browsers, word processors, and games. Think of it as a translator. It allows applications to use hardware resources effectively without needing to know the complexities of how the hardware works. So here's an example. When you open an application like a word processor, the application requests resources from the operating system. The operating system then uses its hardware drivers to access the CPU, memory, storage, and other necessary components to run the application smoothly. This interface ensures applications are hardware independent. Whether you use a laptop or desktop, the application can run effectively because the operating system handles all hardware-specific details. And the key takeaway is this: the operating system allows applications to communicate with and use the hardware resources efficiently, making the system user-friendly. Now let's talk about disk management. So disk management, this refers to how the operating system manages data storage, access, and organizations on the system's disk drives. And disk management includes the following. So we have what is called partitioning, and this divides a physical storage unit into multiple logic units called partitions, such as separating the operating system from personal files. Then we have formatting, and this prepares the partition space by creating a file system, such as NTFS for Windows, APFS for Mac, or ext4 for Linux, that organizes data. Then we have file organization. And this is for storing files in directories or folders and managing how they are accessed and retrieved. So the operating system also handles disk space monitoring to inform the user if storage is running low and provides tools like disk cleanup in Windows to help manage and remove unnecessary files. The disk management functionality is vital to keep the system organized and to ensure that users and applications can quickly and efficiently access stored data. Let's move on to task and process management. So every action on a computer is carried out as a process. When you open a program like a web browser, it is considered a process. The operating system is responsible for managing all these tasks and processes to ensure efficient use of the CPU and memory. And task and process management involves the following. We have multitasking. This is the ability to run multiple processes simultaneously. The operating system switches between tasks rapidly, giving the illusion that they are running concurrently. Then we have priority levels. The operating system assigns priority levels to processes, ensuring that critical system processes get more CPU time than background tasks. And then we have memory allocation. So the operating system assigns memory space to different applications and ensures they don't interfere with each other's data. It also ensures virtual memory to extend physical memory using disk space. So a tool like Task Manager in Windows, this allows you to view running processes, memory usage, CPU utilization, and terminate unresponsive applications. Now, the key takeaway is the operating system manages tasks efficiently, ensuring that the system runs smoothly and multitasking is possible without conflicts between processes. The next topic is application management. So operating systems provide a platform for installing, running, and managing software applications. And the operating system is responsible for software installation and removal. So installing applications by copying files to the system and configuring them properly. This allows for clean uninstallation, removing all associated files and settings. Then we have application updates. The operating system may provide a centralized update service for keeping software current, like Windows Update or the App Store on Mac OS. Then it also is responsible for application compatibility. So the operating system ensures applications run correctly by providing backward compatibility for older software versions. So in summary, the operating system ensures that applications are correctly installed, run without issues, and are kept up to date. Next, let's discuss device management. So device management, this refers to how the operating system manages hardware devices connected to the system, such as printers, scanners, external drivers, and network cards. The operating system uses drivers, which are software components that allow the operating system to communicate with hardware devices. And device management includes the following. We have driver installation and updates. And this ensures that hardware devices have the correct software drivers installed for optimal functionality. It also includes plug and play. So when a new device is connected to the computer, the operating system detects it and attempts to install the necessary drivers automatically. And it also includes resource allocation. So the operating system assigns resources like input and output ports and memory addresses to connected devices to prevent conflicts. So without proper device management, your computer would be unable to recognize or use hardware components effectively. Next, let's discuss access control. So access control in an operating system refers to the system's ability to control who can access files, folders, and system resources. It's a security measure that helps protect sensitive data and ensures that users have appropriate access to only what they need. And the key aspects of access control are as follows. First one is user accounts. So the operating system provides a way to create and manage user accounts with varying levels of access, such as an administrator account, a standard user, or a guest account. Another aspect is permissions. So permissions control what users can do with files or folders, such as read, write, or execute a file. And then another aspect is authentication. So processes like password protection, biometrics, and two-factor authentication ensure that only authorized users can access them. So the access control features of the operating system are crucial for security, ensuring that data is protected and only authorized users can access sensitive files or settings. All right, finally, let's talk about the different types of operating systems and their purposes. And the first one is a mobile device operating system. And this is designed for smartphones, tablets, and wearable devices. And examples include iOS from Apple and Android from Google. And mobile operating systems, they are optimized for touch input, they have power saving features, and they support application-based ecosystems. Then we have desktops and workstation operating systems. These are designed for personal computers used in homes, offices, and schools. Examples include Windows, Mac OS, and Linux. And these operating systems, they support a wide range of applications from productivity to entertainment and offer a user-friendly interface for multi-purpose computing. Then we have what is called a server operating system. And this is built for managing network resources, providing services to multiple users, and it runs 24/7. And examples include Windows Server, Linux with server distributions like Ubuntu Server, and Unix-based systems. And server operating systems, they are optimized for stability, security, and performance, supporting features like remote administration, virtualization, and advanced networking. And then we have what is called an embedded operating system. These are designed for specific devices or systems that require real-time or dedicated functionality. And examples include RTOS or real-time operating systems, Android for IoT devices, and Linux-based systems like Raspberry Pi operating system. And embedded operating systems, they are found in devices like smart home appliances, industrial machines, medical equipment, and car infotainment systems. So each type of operating system is optimized for its specific environment, ensuring that the hardware it runs on is used effectively and securely. So to wrap all of this up, we've explored the essential roles and functions of operating systems, where they serve as an interface between applications and hardware. They manage storage through disk management. They handle active processes with task and process management. They control software installation and updates through application management. They ensure hardware components function properly via device management. They protect data and system resources with access control. And lastly, we understand the different types of operating systems, from mobile to server to embedded systems. So operating systems are the backbone of all computing devices, enabling them to operate effectively and securely. Understanding these functions is a key part of the CompTIA Tech Plus exam, and I hope this breakdown has given you a solid understanding of the purpose of operating systems. All right, now with all of that being said, let's do some of this check on learning. So the first question is, which of the following best describes the role of an operating system as an interface between applications and hardware? Is it the operating system processes data and provides output to the user without interacting with the hardware? Is it the operating system serves as a bridge between applications and hardware, managing the communication between them? Is it the operating system directly controls hardware components without interacting with applications? Or is it the operating system only manages applications and ignores hardware management? And the correct answer is the operating system serves as a bridge between applications and hardware, managing the communications between them. So the operating system, it acts as an intermediary between applications and hardware, ensuring that applications can access hardware resources without needing to manage the complexities of the hardware directly. Next question. What is the primary function of disk management in an operating system? Is it for managing background processes and tasks in the system? Is it for managing installed applications and updates? Is it for organizing and controlling access to files and directories on storage devices? Or is it for configuring device drivers for connected hardware? And the correct answer is it is for organizing and controlling access to files and directories on storage devices. So disk management, this refers to how the operating system organizes, partitions, and manages storage devices like hard drives or SSDs, ensuring files and directories are stored and accessed efficiently. And the final question, which of the following operating system types is used for real-time dedicated tasks in devices like ATMs or medical equipment? Would it be a desktop operating system, a server operating system, a mobile operating system, or an embedded operating system? And the correct answer would be an embedded operating system. So embedded operating systems, they are used in specialized devices like ATMs, medical equipment, and other dedicated hardware. They are optimized for specific functions and operate in real-time environments. In this video, we're going to break down the different types of software used in today's workplace environments. We'll cover productivity software, collaboration software, instant messaging software, web browsing software, and remote support software. Now, understanding these tools and how they're used is essential for anyone preparing to enter or advance in the tech industry. So without further ado, let's get into it. Our first category is productivity software, and these tools help individuals and businesses perform tasks more efficiently. So let's take a closer look at the different types of productivity software. The first one we have is called word processing software. So word processing software is essential for creating, editing, and formatting text documents. And the most well-known example is Microsoft Word, but there were others like Google Docs and Apple Pages. And the purpose of word processing software is it's used to create documents like letters, reports, and essays, and it provides tools for formatting text, inserting images, tables, and other media, and checking spelling and grammar. In the proper use, word processing software should be used when you need to produce formal text documents. Be mindful of using templates for consistent formatting and styles of professional documents. And when collaborating, tools like Google Docs offer real-time editing features, allowing multiple users to work on the same document simultaneously. Next, we have what is called spreadsheet software. So spreadsheet software like Microsoft Excel or Google Sheets, this is designed to store, organize, and analyze data in a grid format or rows and columns. And the purpose is used for tasks like budgeting, data analysis, and tracking projects. And it allows users to perform calculations using formulas and functions, create charts, and analyze data trends. And its proper use is best used when dealing with numerical data or data that needs to be organized into tables, and it uses built-in formulas and pivot tables to analyze large data sets effectively. And charts and graphs, they can help visualize data trends for reports and presentations. Next, we have what is called presentation software, such as Microsoft PowerPoint or Google Slides. And it is used to create visual presentations for meetings, lectures, or reports. And the purpose is designed to convey information visually through slideshows that include text, images, and multimedia. And it's often used in professional settings for business meetings, educational seminars, and conferences. In its proper use, you would use the presentation software when you need to present information in a structured visual format, and it focuses on simplicity in slide design, ensuring each slide contains only key points and visuals that enhance your message. And it takes advantage of templates, animations, and transitions to make the presentation more engaging. And then we have what is called visual diagramming software. So visual diagramming software like Microsoft Visio and Lucid Chart, this allows users to create flow charts, network diagrams, and organizational charts. And its purpose is it is ideal for illustrating processes, workflows, system architecture, and organizational structures, and is often used by engineers, network administration, and project managers to visualize complex concepts. In its proper use, it uses visual diagramming tools to simplify and explain complicated ideas through visual representation, and it makes sure your diagrams are clear and easy to interpret by using proper symbols and labels. And it leverages these tools in brainstorming sessions, project planning, and technical documentation. All right, next let's talk about collaboration software. So collaboration software has become essential in modern workplaces, especially with the rise of remote and hybrid work. So let's explore different types of collaboration software. And the first type is called email client software. So email clients such as Microsoft Outlook, Gmail, or Mozilla Thunderbird are applications used to send, receive, and manage email communications. And the purpose is used for professional and personal communication, and it offers features like scheduling emails, organizing emails into folders, and managing contacts. In its proper use, email clients should be used to send formal communications, especially in business settings. And it uses features like folders and tags to organize your inbox and set up filters to automate certain tasks like categorizing emails. And also, email etiquette is critical, so ensure you are professional and concise and avoid using email for urgent or informal conversations. Next, we have what is called conferencing software. So video conferencing software such as Zoom, Microsoft Teams, or Cisco WebEx, they are used for virtual meetings. And the purpose, it facilitates face-to-face meetings and communications over the internet and is used for remote work, visual presentations, webinars, and online training sessions. In the proper use, you want to use conferencing software when you need to conduct meetings with participants in different locations. You want to make sure you test your audio and video settings before meetings, and use screen sharing features to present content during the meeting. And in professional environments, you want to ensure meetings are scheduled and that there's a clear agenda to avoid wasting time. Next, we have online workspace software. So online workspace software like Microsoft Teams, Slack, or Google Workspace, they provide a virtual hub where teams can collaborate on projects in real time. And the purpose, it helps teams stay organized by offering chat features, file sharing, task management, and integration with other productivity tools. And it allows tools to work on projects together, even when not in the same physical location. In the proper use, you use these platforms to centralize communication, especially for teams working on the same project. You organize your workspace by creating channels or folders dedicated to different topics or teams, and you take advantage of integrations with third-party apps such as calendars and task management tools to streamline workflows. And then we have what is called document sharing software. So document sharing software such as Google Drive, Dropbox, and OneDrive, they allow users to share and collaborate on documents in real time. And its purpose, it's used for file storage and sharing, enabling multiple users to access, edit, and collaborate on documents simultaneously. And it provides version control, ensuring users can see changes made by others and revert to previous versions if needed. In its proper use, use document sharing tools to collaborate on documents, especially when multiple stakeholders need to contribute. And it takes advantage of version history and commenting features to track changes and provide feedback. And it also ensures files are organized and appropriately named to avoid confusion. And you can set permissions carefully to control who has access to the information. All right, next let's talk about instant messaging software. So instant messaging software is designed for real-time text-based communication, and examples include Microsoft Teams Chat, Slack, and WhatsApp. And its purpose is used for quick, informal communication between colleagues or team members, and is often used in place of email for internal conversations, especially for questions and updates that require a fast response. In its proper use, you want to use instant messaging software for short, immediate communications rather than for formal discussions or detailed project updates. And you want to keep messages concise and make use of status indicators to communicate your availability to others. And you want to avoid using instant messaging for sensitive or confidential information unless you're using a secure platform. So instant messaging software is useful in both workplace and personal settings, enhancing communication speed and accessibility. All right, next let's talk about web browsing software. So web browsers, they are essential tools for accessing the internet, and examples include Google Chrome, Mozilla Firefox, Microsoft Edge, and Safari. And its purpose, it's used to navigate the web, allowing users to access websites, online services, and web applications. And it provides the platform for tasks ranging from research to online shopping, streaming, and much more. In its proper use, you want to use web browsers for accessing online content, whether it's research, web-based applications, or entertainment. And you want to be aware of privacy and security concerns when using web browsers. So use features like incognito mode or private browsing to prevent tracking. And you want to keep your browser and extensions up to date to protect against security vulnerabilities. So web browsers, they are fundamental to almost every computer-based activity and offering access to a wide range of resources and services. And lastly, we have remote support software. So remote support tools such as TeamViewer, AnyDesk, and Remote Desktop, these enable technicians to access and control computers remotely. And the purpose, they are used by IT support teams to troubleshoot and resolve issues without needing to be physically present at the affected machine, and allows remote access for software installation, configuration, and troubleshooting. In its proper use, you want to use remote support software to assist users in solving technical technical problems or performing maintenance tasks. Then you want to ensure that remote access is secure using encryption and strong authentication methods to protect sensitive information. And you always want to seek permission from the end user before accessing their system remotely. So remote support software, this is crucial for modern IT support teams, and it enables them to provide assistance efficiently regardless of the physical location of the device. So in conclusion, software tools, they play a critical role in the modern workplace, from boosting productivity to facilitating collaboration and communication. In each category of software, such as productivity, collaboration, instant messaging, web browsing, and remote support, they have their own purpose and proper use. So understanding these tools and how they fit into a professional environment is essential for passing the CompTIA Tech Plus exam and for succeeding in today's technology-driven world. Now, with all that being said, let's do some of this check on learning. So what is the primary use of spreadsheet software? Is it for creating and editing text documents? Is it for storing and managing files? Is it for analyzing and organizing numerical data? Or is it for conducting video conferences? And the correct answer is, it is for analyzing and organizing numerical data. So spreadsheet software is designed primarily for handling numerical data and performing calculations. It allows users to create tables, graphs, and formulas to analyze information efficiently. Next question. Which of the following is a key feature of collaboration software? Is it enabling real-time editing and sharing of documents? Is it sending messages via chat in real time? Is it allowing users to browse websites? Or is it creating visual diagrams for projects? And the correct answer would be, it enables real-time editing and sharing of documents. So collaboration software like online workspaces and document sharing tools allow multiple users to work together on documents in real time. And our final question, which software will be most appropriate for remotely troubleshooting and fixing a client's computer issues? Would it be instant messaging software, remote support software, presentation software, or spreadsheet software? And of course, the answer is remote support software. So remote support software is specifically designed to allow technicians to access and troubleshoot a user's computer from a different location. In this video, we're going to be talking about configuring and using web browser features. In this session, we'll be covering several browser functionalities that enhance both security and productivity, including private browsing, managing browser add-ons, clearing cache, pop-up blockers, browser compatibility, profile synchronization, and more. So let's start by diving into these important features one by one. First, let's discuss private browsing. So private browsing, sometimes referred to as incognito mode in browsers like Chrome, prevents your browsing history, cookies, and site data from being saved. This mode is useful for scenarios where you don't want others of the same computer to access your history, such as when shopping for a surprise gift or logging into accounts on a shared computer. So how do you activate it? In most browsers, you can open a private browsing window by going to the browser menu and selecting New Incognito Mode or New Private Window. In a scenario where you would use this, let's say you're using a shared computer in a public library and need to log into your email account. Instead of having the browser remember your login credentials, use private browsing to keep your information secure. So it's important to note that while private browsing doesn't save data on the local machine, your activity can still be seen by your internet service provider or websites that you visit. All right, next let's talk about browser add-ons or extensions. So browser extensions, these are small software programs that enhance the functionality of a browser. You might install an ad blocker to stop annoying ads or a grammar checker for writing assistance. So when it comes to adding extensions, extensions can be added from the browser's web store. So for instance, in Chrome, you would go to the Chrome web store, search for the desired extension, and then click Add to Chrome. When it comes to removing or disabling extensions, to manage those extensions, you want to navigate to the browser settings. From there, you can view the installed extensions and disable or remove them as needed. And a scenario to demonstrate this, let's say you've installed too many extensions and your browser is slowing down. You can disable unnecessary extensions to speed up the performance. Now, it's critical to manage these properly, as too many or poorly designed extensions can affect browser performance or introduce security risks. Now let's move on to browser caching. So caching, this is the process where browsers store copies of web pages, images, and other media to load websites faster the next time you visit. While this is convenient, it can sometimes lead to issues such as outdated content being displayed. So how do you clear the cache? In most browsers, you can clear the cache by going to the settings menu, finding the privacy or history section, and selecting clear browsing data. And from there, you can choose what to clear, including cache and cookies. And so a scenario will be if a website isn't loading correctly or isn't showing the most recent updates, you can clear the cache to resolve that issue. So regularly clearing cache, this is a good practice to free up storage and improve browser performance. Next, let's look at pop-up blockers. So pop-up ads can be intrusive and even lead to malicious websites. And most browsers include built-in pop-up blockers to prevent these ads from appearing. So how do you manage pop-up blockers? You can turn pop-up blockers on or off in your browser settings. So in Chrome, you can go to settings, privacy and security, site settings, pop-ups, and redirects to manage which sites are allowed or blocked from displaying pop-ups. In a scenario where you would use this, so while pop-up blockers are useful, they can sometimes interfere with legitimate actions, such as log into a banking site. In these cases, you may need to allow pop-ups from specific sites. So understanding how to configure pop-up blockers, this allows you to maintain a balance between security and functionality. Let's now talk about browser compatibility. So some web applications require specific browsers or browser versions to function correctly. So for instance, certain websites or web pages might only work well in Chrome, while others might be optimized for Firefox. So say you're accessing a corporate web application that doesn't display correctly in your current browser, checking the application's documentation might reveal that it works best in a different browser like Edge or Safari. So before using certain web-based applications, it is important to confirm which browsers are compatible, especially for business critical tools. Another useful feature is profile synchronization. So profile synchronization, this allows you to sync your browser settings, bookmarks, history, and passwords across multiple devices using a single account. This is especially useful if you use different devices throughout the day, like a desktop at work and a laptop at home. So how do you set up synchronization? In Chrome, you can sign in with your Google account to enable synchronization. And once signed in, any changes made, such as adding a bookmark, will be reflected across all devices where you logged in. And a scenario where you would do this is you would save an important web page on your work computer and you want to access it later on your phone. With profile synchronization, the bookmark will automatically appear on your mobile browser. And this feature makes transitioning between devices seamlessly, allowing for you to boost your productivity. All right, so let's talk about organizing features, especially bookmarks. So bookmarks, they allow you to save and quickly access your favorite websites. And you can organize them into folders, making it easier to find specific sites. So how do you add a bookmark? In most browsers, you simply click the star icon in the address bar to save a page as a bookmark. And when it comes to organizing bookmarks, you can create folders and drag bookmarks into them to keep things neat. So for example, you might create a folder for work-related sites and another for personal interests. In a typical scenario, if you frequently visit certain websites like news sources or tools for work, you can save them as bookmarks, and this will save time and keep you organized. So organizing bookmarks efficiently, this improves workflow and reduces time spent searching for important websites. Next, we have the default search engine settings. So each browser has a default search engine like Google and Chrome or Bing and Edge, but this can be changed based on your preferences. So how do you change the search engine? In your browser settings, you will look for the search engine section, and from there you can choose your predefined search engine like DuckDuckGo for privacy-focused searches or Yahoo for personal preference. In a typical scenario, if you prefer a different search engine for its features or privacy options, setting it as your default ensures all your searches are routed through that engine. So this customization lets users tailor their browsing experience according to their needs. Now let's discuss password management. So browsers can save passwords for websites to make logging in easier. However, it's crucial to manage them securely. So using password management tools, most browsers have built-in password managers that store encrypted passwords, and you can enable this in the settings under autofill or passwords. In a typical scenario, you frequently visit several websites that require login credentials. By saving these passwords securely in the browser, you don't have to type them in each time. time. Now, it's a good practice to use strong, unique passwords and consider integrating a dedicated password manager for added security. Now let's explore accessibility features. So modern browsers, they come with several accessibility options, including text resizing, screen readers, and high contrast modes to assist users with visual impairments. So accessing accessibility features in the settings, you can enable various accessibility features such as increased font size or enabling screen readers. In a typical scenario, a user with impaired vision may need to enlarge text to increase contrast on web pages. So adjusting these settings can make browsing more comfortable and inclusive. So understanding accessibility features, this ensures that all users, regardless of abilities, can have an optimal browsing experience. And finally, let's cover appearance settings. So most browsers allow users to customize the look and feel of the browser interface, such as changing themes, font sizes, and colors. So to customize the appearance, you can usually find these options in the browser settings under appearance. And some browsers offer downloadable themes or extensions that can change the look of tabs, the home page, and the toolbar. So a typical scenario, you prefer a dark theme to reduce eye strain when browsing at night. So switching to a dark mode or theme can make the browser more comfortable to use. So customizing the appearance of your browser, this can make it easier to use for long periods and allows for personalization. So that wraps up our overview of essential browser features. We've covered everything from private browsing and managing extensions to configuring pop-up blockers, clearing cache, and customizing appearance. Mastering these features not only improves your browsing experience, but also ensures you're ready for the CompTIA Tech Plus exam. So with all of that said, let's do some of this check on learning. So the first question is, you are using a web browser to visit multiple websites without saving your browsing history, cookies, or site data. Which feature are you likely using? Is it caching? Is it the pop-up blocker? Is it private browsing? Or is it a password manager? And the correct answer is you are using private browsing. So private browsing mode, this prevents the browser from saving browsing history, cookies, site data, and other personal information. And it is useful when you don't want your activities to be saved on that device. Next question. You notice that the browser is slowing down and suspect it's due to stored data. Which action should you take to resolve this issue? Should you enable private browsing? Should you clear the browser cache? Should you disable pop-up blockers, or should you change the default search engine? And the correct answer is you want to clear the browser cache. So clearing the browser cache, this removes temporary files that can accumulate and slow down the browser's performance. And this action improves speed and resolves other issues related to browsing. And the final question, a user wants to sync bookmarks, passwords, and browser settings across multiple devices. Which feature should they configure? Would it be profile synchronization, browser add-ons, private browsing, or caching? And of course, the answer is profile synchronization. So this allows users to sync bookmarks, passwords, and other browser settings across different devices, enabling a consistent experience across multiple platforms. In this video, we'll be discussing the common uses of artificial intelligence. AI is transforming multiple industries by automating tasks, enhancing productivity, and improving user experience. As part of the CompTIA Tech Plus exam, understanding the practical applications of AI is essential. In this video, we'll explore 4 key uses of AI, and that is AI chatbots, AI assistants, generative AI, and AI predictions and suggestions. So let's begin. Our first focus is on AI chatbots, which is one of the most widely used applications of artificial intelligence today. So what are AI chatbots? AI chatbots are programs designed to simulate human conversations. They use natural language processing to understand and respond to users, whether through text or voice. And chatbots can handle various tasks such as customer support, booking services, or answering FAQs. So how do they work? AI chatbots, they rely on a combination of machine learning and natural language processing. Machine learning algorithms algorithms help chatbots learn from data and improve over time, while natural language processing, this allows a chatbot to understand human language even when it's expressed in different ways. So here's a basic example of how a chatbot works. So you have the input. So the user types or speaks a query such as, what time does the store close? Then the chatbot processes the input, recognizing keywords like time and store close. And then the chatbot generates a response based on available data, such as the store closes at 7 p.m. And here are some common uses of AI chatbots. So you have customer service. Companies like Amazon or banking institutions use AI chatbots to answer basic questions, track packages, or process transactions without human intervention. It's used in e-commerce. So chatbots assist in recommending products based on user preferences and help in completing purchases. And it's also used in healthcare. So AI chatbots, they provide general medical advice, triage symptoms, or they can schedule appointments. And the key benefits of AI chatbots are as follows. They offer 24/7 availability. So AI chatbots don't need to rest, and they offer continuous services to users. They offer efficiency. They can handle multiple inquiries simultaneously, providing faster responses compared to human agents. And they offer cost savings, so they reduce the need for large customer support teams. Next, let's move on to AI assistants. So you're probably familiar with tools like Apple's Siri or Google's Assistant, Amazon Alexa, and Microsoft's Cortana. So what are AI assistants? Well, AI assistants are more advanced than chatbots, offering a wide range of functionalities such as controlling smart devices, setting reminders, sending messages, or retrieving information from the web. And they are integrated into smartphones, smart speakers, and even cars. So how do they work? So like chatbots, AI assistants rely on machine learning and natural language processing. However, they also use voice recognition and can perform more complex tasks by integrating with different apps, devices, and services. So here's an example of how an AI assistant works. You have voice activation. So the user says a wake word like, "Hey Siri" or "Okay Google." Then there's the request. So the user asks a question like, "What's the weather tomorrow?" And then there's a response. The AI assistant processes the query, retrieves weather data, and replies with the relevant forecast. So here are some common uses of AI assistants. They could be used for smart home control. So AI assistants can turn lights on or off, control thermostats, and lock doors through voice commands. They can set up scheduling and reminders. So users can ask assistants to schedule appointments, set reminders, or send calendar invites. And they can retrieve information. So AI assistants, they provide real-time information such as news updates, sports scores, or travel directions. And some of the key benefits of an AI assistant are convenience. So AI assistants can perform tasks hands-free, making them perfect for multitasking. They offer personalization. They can learn user preferences and tailor responses, such as suggesting routes based on daily commutes. And they offer interactivity. So with voice-based interaction, AI assistants are easy to use, even for individuals who may not be tech savvy. Now let's discuss the growing field of generative AI, which involves the creation of content, whether it's text, images, or even code by AI systems. So what is generative AI? Generative AI uses machine learning models, particularly generative adversarial networks and large language models, to create new original content based on patterns learned from large data sets. And one of the major uses of generative AI is in AI-generated code, where AI assists developers by automating parts of the coding process. So here's some examples. You got GitHub Copilot. This is an AI tool powered by OpenAI's Codex that suggests code snippets as developers write. It can handle repetitive tasks like writing boilerplate code, optimizing functions, or even completing entire functions based on simple instructions. Then you have AI code refactoring. So AI tools, they can analyze existing code bases and offer suggestions to refactor code for better performance or readability. And some of the benefits are increased productivity. So by automating tedious coding tasks, AI allows developers to focus on more complex aspects of software development. And then there's error reduction. AI can help catch bugs or suggest optimization that human developers might miss. All right, next let's talk about AI generated content. So, generative AI can also create content such as articles, blog posts, images, music, and videos. And some examples are OpenAI's GPT models that can generate text for blogs, emails, or even marketing copy. And then we have another one called DALL-E, and it is a similar AI tool that can create original images based on text descriptions. And some of the benefits, it offers content creation at scale. So, AI generated content can help businesses generate more content faster, from social media posts to marketing materials, and then it offers cost efficiency. So using AI to generate content can reduce the need for large teams of writers, designers, or coders. All right, and finally, let's cover how AI is used for predictions and suggestions. AI prediction systems analyze large data sets and use statistical models to predict future trends, outcomes, or behaviors. And some examples are you have what is called predictive analytics. So businesses use AI to analyze historical sales data to predict future demand, and this helps in inventory management, preventing overstock or stock shortages. It's used in healthcare, so AI models can predict the likelihood of a patient developing a disease based on medical history and genetic data, allowing for early intervention. It's also used in financial forecasting. So AI is used in the finance industry to predict market trends, stock prices, and even potential risks. And some of the benefits include improved decision making. So AI predictions provide data-driven insights that can guide businesses or healthcare providers in making better decisions, and it offers efficiency. So AI can process vast amounts of data more quickly than humans, offering real-time predictions. AI also powers recommendation systems, which are used to suggest products, services, or actions to users based on their preferences and behaviors. And some examples include things like e-commerce. So some sites like Amazon use AI to recommend products to users based on their browsing history, past purchases, and similar users' behavior. It's used in media platforms. Streaming services like Netflix and Spotify use AI to suggest shows, movies, or songs based on the user's viewing or listening habits. It's also used in search engines. So Google uses AI to provide search suggestions based on users' queries and trends, improving the search experience. And some of the benefits are personalization. So AI generated suggestions create a more personalized experience for users, increasing satisfaction and engagement. Another benefit is increased sales and engagement. So recommendation systems are proven to boost sales in e-commerce and keep users engaged in media platforms. All right, so in summary, artificial intelligence is transforming the way we interact with technology, and we've explored 4 common uses of AI. We talked about AI chatbots, and these automate conversations and enhance customer service experiences. We talked about AI assistants. They provide hands-free voice control functionality for smart homes, scheduling, and information retrieval. We talked about generative AI. This automates the creation of code and content, enabling greater productivity in various industries. And we talked about AI predictions and suggestions, and this helps businesses and consumers make data-driven decisions with predictive analytics and personalized recommendations. Now, understanding these AI applications is crucial for anyone pursuing a career in tech and also for preparing for the CompTIA Tech Plus exam. All right, now let's get into some of this check on learning. So, which of the following is an example of a generative AI application? Would it be an AI chatbot that assists with customer service? Would it be an AI assistant that schedules meetings? Would it be an AI tool that creates original artwork based on user prompts? Or would it be AI software that provides weather predictions? And the correct answer is it will be an AI tool that creates original artwork based on user prompts. So generative AI refers to AI systems capable of generating new content such as text, images, or code based on user inputs. And an AI tool that creates artwork falls under this category. Next question. What is the primary function of AI chatbots? Is it to generate code automatically for developers? Is it to simulate human conversation and provide automated responses? Is it to manage complex data analytics in real time? Or is it to predict future trends in business and finance? And the correct answer is it is to simulate human conversation and provide automated responses. So AI chatbots are designed to simulate human conversation and interact with users via text or voice, usually for customer support or information gathering purposes. And their main function is not to generate code, manage data analytics, or make predictions about trends, but rather to respond to user queries in real time. And the final question: which of the following tasks would most likely be performed by an AI assistant? Is it writing complex software code from scratch? Is it scheduling meetings and setting reminders for users? Is it generating original music compositions? Or is it analyzing large data sets for business intelligence? And the correct answer is it is used for scheduling meetings and setting reminders for users. So AI assistants like Siri or Google Assistant help with personal tasks such as scheduling meetings, setting reminders, and managing daily tasks. They are not designed for complex tasks like writing code, generating music, or analyzing data sets, which are examples of AI applications such as generative AI or AI-based analytics. In this video, you're going to learn about the different types of programming languages and how they function, and we'll compare and contrast the three main categories. They are interpreted languages, compiled programming languages, and query languages, including assembly languages. So let's break these down into their key types and functions. Now, before we dive into these specifics, it's important to understand what programming languages are. In simple terms, programming languages are a way for humans to communicate instructions to a computer. And these languages are either high level, meaning they are easy for humans to read, or they're low level and they're closer to the computer's machine code. And the three primary categories we'll focus on are interpreted languages, including scripting languages and markup languages. We'll talk about compiled programming languages, and we'll talk about query languages, including assembly languages. And each of these categories has its own purpose, benefits, and limitations. So let's start by discussing interpreted languages. Interpreted languages are programming languages in which the code is executed line by line by an interpreter at runtime rather than being compiled ahead of time. And there are two major types of interpreted languages. We have what is called scripting languages and markup languages. Scripting languages, they are used to write short programs or scripts that automate tasks. They are interpreted by an interpreter, meaning that the code is processed one line at a time during runtime. And some examples of scripting languages include the following. The first is called JavaScript, and this is primarily used for adding interactive elements to websites. JavaScript is interpreted by web browsers in real time, enabling dynamic behavior on websites. Then we have what is called Python, and this is a versatile and widely used scripting language known for its simplicity and readability. And Python is used in web development, automation, artificial intelligence, and much more. And then we have what is called Ruby. And this is often used for web applications. And Ruby is interpreted at runtime, making it easy to make changes to code without recompiling. And we also have what is called PHP. And this is a server-side scripting language used for web development, especially for dynamic websites and databases. And the advantages of scripting languages are as follows. The first one is ease of use. So scripting languages are typically easier to learn and use, making them great for beginners. It offers platform independence. So since interpreted languages don't need to be compiled, they can run on any system with an appropriate interpreter, and they offer flexibility. So these languages are highly flexible and allow for rapid development. Now, some of the disadvantages are slower performance. So because the code is interpreted line by line at runtime, scripting languages are generally slower than compiled languages, and then there's limited access to system resources. Interpreted languages often don't have the same level of access to system resources as compiled languages. Next, we have what are called markup languages. In markup languages, they are used to define the structure and presentation of text, especially in web development. And examples include HTML, which stands for Hypertext Markup Language. And this is the standard language used to create and structure web pages. HTML elements define headings, paragraphs, links, and more, making it essential for web development. Then we have what is called XML, and that stands for Extensible Markup Language. And this is used to store and and transport data. XML allows users to define custom tags and is commonly used in web services and configuration files. And then we have what is called CSS, or cascading style sheets. Though technically not a full programming language, CSS is a style sheet language used to describe the presentation of HTML documents. It controls the layout and appearance of web pages. And some of the advantages of markup languages are as follows. They offer structure and organization. So markup languages are great for structuring data or web content, and they offer separation of content and presentation. So especially in web development, markup languages like HTML and CSS separate content from its presentation, allowing for easier maintenance and updates. And the major disadvantage to markup languages is limited logic. So markup languages are not designed to perform complex computations or logic, and they are mainly for formatting and structuring content. So now that we've covered interpreted languages, let's move on to compiled programming languages. Compiled programming languages are languages where the source code is translated into machine code or binary through a compiler before execution. The compilation process translates the entire program in one go, creating an executable file that can run on its own without the need for an interpreter. And some examples of compiled languages are as follows. The first one is called C, and this is one of the oldest and most widely used programming languages. It's powerful and provides low-level access to the system resources. Then we have what is called C++. This is an extension of C, adding object-oriented programming features, and it's used in system software development, game development, and much more. Then we have what is called Java. Although Java runs in the Java virtual machine, it is considered both compiled and interpreted, and it is compiled into bytecode before being executed by the JVM. And then we have what is called Go, or Golang, and this is a statically typed compiled programming language developed by Google. It is known for its efficiency in system programming and networking. And some of the advantages of compiled languages are as follows. First one is speed. So once compiled, the code runs much faster than interpreted languages because it's translated directly into machine code. The next advantage is optimization. Compilers can optimize code during compilation, resulting in highly efficient programs. And the next advantage is full access to system resources. So compiled languages allow for low-level access to memory and hardware, making them ideal for system-level programming. And some of the disadvantages are development time. So the compilation process can slow down development since the code needs to be compiled before testing. And then another disadvantage is platform dependency. So compiled code is often platform specific, meaning you may need to recompile the code to run it on different operating systems. So compiled languages are best suited for applications where performance and efficiency are critical, such as operating systems, game development, and real-time systems. All right, next let's talk about query languages. So query languages are specialized languages designed to retrieve, manipulate, and manage data in databases. They are typically used in database management systems to interact with stored data. And some examples of query languages are as follows. The first one you have is called SQL, or SQL, and that stands for Structured Query Language. And this is the most commonly used query language. SQL is used for managing and querying relational databases, and SQL commands can select, insert, update, and delete data in database tables. Then we have what is called GraphQL, and this is a query language for APIs that allow clients to request specific data, unlike traditional REST APIs. GraphQL is flexible and allows for efficient data retrieval. And then we have what is called XPath, or XQuery, and this is used to query XML data. In these languages, they help retrieve and manipulate XML documents. And some of the advantages of query languages are as follows. The first one is it is specialized for data manipulation. So query languages like SQL are specifically designed to interact with large sets of data, making them extremely efficient for database management. And then they simplify complex queries. So query languages are optimized for retrieving data with complex filters and conditions, simplifying the process for developers and database administrators. And the major disadvantage of a query language is it has limited use. So query languages are highly specialized and they are not suitable for general purpose programming. All right, finally, let's talk about assembly languages. So assembly language, this is a low-level programming language that provides a way to write instructions in a format that is readable to humans, but closely aligned with machine code. And the characteristics of assembly languages are as follows. Assembly languages are specific to a particular computer architecture. They require the programmer to manage memory and processor registries directly, and assembly instructions are one step above machine code, making them very fast and efficient, though more difficult to write. And some examples are, you have x86 assembly, and this is used in Intel x86 processors. Then you have what is called ARM assembly, and this is used in ARM architecture, which powers many mobile devices and embedded systems. And then some of the advantages of assembly language are as follows. They offer high performance. So assembly language offers direct access to hardware. They can produce very efficient and optimized code, and they offer control over system resources. It allows the programmer to control processor registries and memory, making it ideal for hardware level programming. And some of the disadvantages are they are complex. So assembly is much harder to learn and use than high-level languages, and they offer limited portability. So assembly language is highly specific to hardware architectures, making it non-portable between different systems. So ultimately, assembly languages are typically used in situations where performance is critical, such as embedded systems, real-time applications, and low-level device drivers. So to wrap all this up, let's quickly summarize the key differences between these categories of programming languages. So interpreted languages such as scripting and markup languages are executed line by line at runtime and are ideal for dynamic and flexible applications, but they tend to be slower. Compiled programming languages translate source code into machine code before execution, offering high performance but requiring a compilation step. Query languages are specialized for interacting with databases, providing efficient ways to retrieve and manipulate large data sets. And assembly languages, they offer low-level control over hardware and high efficiency, but are more complex and less portable. So understanding the strength and limitations of each language category will help you select the right tool for the task at hand. And this information is essential for the CompTIA Tech Plus certification exam. Now, with all that being said, let's do some of this check on learning. So the first question is, which of the following is an example of an interpreted scripting language? Would it be C++? Would it be Python? Would it be assembly? Or would it be SQL? And the correct answer is Python. So Python, this is an interpreted scripting language, meaning that its code is executed line by an interpreter at runtime. Next question. What is a key characteristic of a compiled programming language? Is it the code is executed line by line during runtime? Is it the code is converted into machine code before execution? Is it is used for querying databases? Or it requires an interpreter to run? And the correct answer is the code is converted into machine code before execution. So compiled programming languages such as C and C++ are converted into machine code by a compiler before execution. This means the entire program is translated into executable code before it runs, unlike interpreted languages that run line by line. And the final question, which language category does SQL belong to? Would this be a markup language, a compiled programming language, a query language, or a scripting language? And the correct answer is it is a query language. So SQL, this is a query language primarily used to interact with databases. It allows users to retrieve and manipulate data. It is not compiled or interpreted as a general purpose programming language, nor is it used for structuring documents like markup languages. In this video, we're going to dive deep into fundamental data types and their characteristics. These data types are essential building blocks in computer programming, and understanding them is key for anyone preparing for the CompTIA Tech Plus exam. By the end of this video, you'll have a clear understanding of characters, strings, numbers, and Boolean values. And we'll explore what each of these data types represents, how they're used in different programming languages, and their importance in computing. So before we jump into specific data types, let's talk about what a data type actually is. In computing, A data type defines the kind of data a variable can hold. It's a classification that tells the computer how to interpret the information stored in memory. And different programming languages might implement data types in slightly different ways, but the core concepts remain consistent. So why do data types matter? Because they define the operations that can be performed on the data. They specify memory usage, as different data types require different amounts of memory, and they help with error checking by ensuring that operations are performed on compatible types of data. Now, let's dive into the different fundamental data types, starting with the char or character. The first fundamental data type we'll look at is char, and that stands for character. So a character, this is any single letter, number, punctuation mark, or symbol. In programming, the character data type stores exactly one character, and it can hold characters like alphabet letters, digits, and special characters like punctuation. And its characteristics are as follows. So the first one is size. So typically a character requires 1 byte of memory, but this can vary by language and encoding. Another characteristic is representation. Characters are often enclosed in single quotes. So for example, the letter A in single quotation marks, this is a character. And then they're also represented by ASCII and Unicode. So characters are stored using encoding standards like ASCII or Unicode. In ASCII, each character is represented by a number. So for example, the character A is represented by the number 65. And the use case for a character is text processing. So characters are widely used in text processing. So for example, in a word processor, each letter is stored as a character. Now let's talk about strings. So a string is essentially a sequence of characters. So where a character stores just one character, a string can store multiple characters in a sequence. So think of it as a word, a sentence, or even an entire document. So here are the characteristics of strings. So first characteristic is size. So the size of a string depends on the number of characters it holds. So for example, the string hello, this consists of 5 characters and requires at least 5 bytes of memory. Then we have representation. So strings are typically enclosed in double quotes. So for example, you have hello world, that is a string. Then we have null terminated strings. So in some languages like C, strings are null terminated, meaning they end with a special character that indicates the end of the string. And another characteristic is immutability. So in some programming languages like Python, strings are immutable, meaning once they are created, their content cannot be changed. Instead, operations on strings result in the creation of new strings. And the use cases for strings are the following. So they store text. So strings are used whenever we need to store text, such as user input, file content, or website data. And then there's string manipulation. So strings often come with built-in functions that allow us to manipulate them, like finding their length, concatenating them, or converting to upper and lower case. So strings can be much longer than just a few characters, and they are used in virtually every program to handle text data. Now let's move on to numbers. And first, we're going to talk about integers. So an integer, which is often abbreviated as int, this is the data type that represents whole numbers. And these numbers can be positive, negative, or 0, but they cannot contain any decimal points. And the characteristics of an integer are as follows. So the size of an integer can vary based on the system in the programming language. And typically, an integer takes up 4 bytes or 32 bits of memory. However, there are variations like short and long integers. They use less or more memory. Another characteristic is the range of integers depends on the size. So for example, in a 32-bit system, an integer can range from negative 2.1 billion all the way up to 2.1 billion. And then another characteristic is the operation. So integers, they support basic arithmetic operations like addition, subtraction, multiplication, and division. And some of the use cases of integers are as follows. So integers are often used in loops where we need to count iterations or keep track of an index in a list or an array. And integers are also used in mathematical calculations. So whenever whole numbers are involved in calculations, integers are used. All right, next let's discuss what is called a floating point number, or simply a float. So a float, this is the data type used to represent real numbers that contain decimal points. These numbers can be positive or negative, and they allow for fractions of a whole number. And the characteristics of a float are as follows. So a float typically uses 4 bytes of memory or 32 bits, and some languages also support a double data type, which uses 8 bytes or 64 bits for more precision. And then floats are less precise than integers due to the way they are stored in memory. And this can lead to rounding errors in very large or very small numbers. Also, floats support arithmetic operations similar to integers, but also handle decimal values. And some of the use cases for floats are as follows. So floats are used when precision with decimal points is necessary, such as in financial calculations or scientific simulations. And also in programs that need to handle measurements like height, weight, or speed, floats are commonly used. So understanding the difference between integers and floats is critical for ensuring the right data type is used when dealing with numbers. And finally, let's talk about the Boolean data type. So a Boolean, this represents a binary value, either true or false. And this data type is used primarily for logical operations and decision-making in programs. And the characteristics of Boolean are as follows. So a Boolean usually requires 1 bit of memory, as it only needs to represent 2 values, either the number 1, which stands for true, or the number 0, which stands for false. Also, Boolean values are used in logical operations like and, or, and not. And also, in many programming languages, Boolean values are used in conditional statements, such as if, while, or for loops. Now, some of the use cases for Boolean are as follows. So Booleans are most commonly used in decision-making processes. So for example, when you check whether a user is logged in, the result is either true or false. Also, in loops and conditionals, Booleans help control the flow of a program based on whether conditions are met or not. So essentially, Booleans are critical for writing programs that make decisions based on conditions. And on your screen right here is an example of Boolean used in the Google search algorithm. So if you went into Google and you typed up the following stating that you're looking for toys, you might get 244 results. If you typed into Google that you're looking for cars, you might get 300 results. However, if you typed into Google, you are looking for toys and cars, you might get 10 results. If you typed in you're looking for toys or cars, you might get 400 results. And if you typed in you're looking for toys, not cars, you might get 200 results. Then at the bottom here, we have Boolean that's expressed as an algebraic equation. So if x equals 1 and y equals 1, then x and y equals 1. Another expression, if x equals 1 or y equals 0, then x or y equals 1. And then we have x equals 0, and that's not equal to x equaling 1. So to recap, in this video, we've covered the fundamental data types. We talked about char, and that's used for storing single characters. We talked about strings, and that's used for storing sequences of characters. We talked about integers for whole numbers. We talked about floats for decimal numbers. And we talked about Booleans for logical true and false values. So each of these data types has a specific role in computing and is crucial to understand when writing and debugging programs. Mastering these concepts will help you succeed not only in the CompTIA Tech Plus exam, but also in your overall understanding of programming and computer systems. All right, now with all of that said, let's do some check on learning. So which of the following data types is best used to store a single character? Would it be integer? Would it be string? Would it be a char? Or would it be a float? And of course, the correct answer is char. So the char data type is used to store a single character, such as the letter A or the number 5, and it is typically 1 byte in size. Next question, which data type would be most appropriate for storing a value of 3.14? Would it be an integer, a char, Boolean, or a float? And the correct answer is float. So the float data type is used to store decimal numbers such as 3.14. And our final question, what is the primary purpose of a Boolean data type? Is it to store numeric values, to store textual data, to store true or false values, or to store a single character? And of course, the correct answer is it is to store true or false values. So the Boolean data type is used to represent 2 states, typically true or false. It is often used in conditions and control structures in programming. In this video, we'll cover some fundamental ideas that are essential to programming, such as identifiers, including variables and constants, arrays, functions, and objects, which encompass properties, attributes, and methods. So understanding these core concepts will give you a strong foundation as you prepare for the exam. So let's dive into these details. All right, so let's begin with identifiers. So an identifier is essentially the name we give to different elements in our programs. Identifiers can represent variables, constants, functions, or other programming entities, and they help us track and manipulate data within a program. So let's talk about variables. So a variable, this is a storage location in programming that holds data which can be changed or modified during program execution. And the purpose of variables is to store temporary data that a program may need to refer to and manipulate as it runs. So here's an example. If you were creating a program to calculate the area of a rectangle, you would use variables to store the values of the rectangle's length and width. Now, in this example, length, width, and area are all variables. The values stored in length and width can change, and the program can calculate a new area each time. Also, in most programming languages, variables must follow certain rules. They should start with a letter or underscore in some languages. They cannot contain spaces or special characters, and they should be descriptive so the purpose of the variable is very clear. All right, next let's talk about a constant. So a constant, as the name suggests, this is a value that does not change during the execution of a program. Once it's set, it remains the same. And constants, they are used when you need to store data that shouldn't be altered. So for example, mathematical values like pi or fixed configuration settings should be constants. In any example on your screen where pi equals 3.14, pi is a constant because the value of pi does not change. By using a constant, you prevent accidental changes to important data and you improve code readability. Now, many programming languages such as Python and JavaScript don't have built-in support for constants, but developers use conventions like all uppercase letters to signify that a variable should not change. All right, next let's talk about arrays. So an array is a data structure that allows you to store multiple values in a single variable. These values are usually of the same data type, such as integers or strings, and they are stored in contiguous memory locations. Also, arrays make it easier to handle multiple pieces of data efficiently. So arrays are used when you need to store collections of data, such as lists of numbers, a set of names, or any series of related items. Instead of creating individual variables for each item, you can use one array to store them all. And in this screenshot right here, the array fruits contains 4 elements, and you can access individual items in the array by referencing their index like this. So in this picture right here, the array index starts at 0. So fruits with the bracket 0 returns the string apple. And if fruits had the bracket 1, it would return the string banana, and so on and so forth. Now, arrays are especially useful in loops, and you can iterate through an array to perform operations on each element. And as you look at this image right here, this program will print fruit in the list one by one. Now let's move on to functions. So a function, this is a block of organized, reusable code that performs a single, well-defined task. And functions are a key building block in programming, and they help make code modular and easier to manage. So functions allow us to group related lines of code into a single entity, making our code more readable, reusable, and maintainable. In functions, they can take input data, perform operations on it, and return a result. So in this example right here on your screen, we define a function called calculate_area with 2 parentheses. And basically this takes 2 inputs, length and width, and returns the product of the 2 values. And then you can call this function wherever you need to calculate an area. So let's talk about the benefits of functions. So once a function is defined, it can be called any number of times without needing to rewrite the code. Also, another function is it allows for you to break a program into small manageable functions that improves the organization and clarity of the code. And if you need to make changes to how something works, you only need to update the function, and every place that calls the function will automatically use the updated code. Another benefit, functions, they can accept parameters, which allows you to pass data into them when you call them. So in this example right here, here, length and width are the parameters. And also functions, they can return values, providing the results of their operations to the calling code. All right, finally, let's talk about objects. So this concept is central to object-oriented programming, which is a common paradigm in programming. So an object, this is a collection of data and methods that operate on that data. Objects are instances of classes which define the structure and behavior of the objects. In simpler terms, classes act as blueprints, and objects are the actual things you create from those blueprints. And the purpose is objects allow programmers to model real-world entities and organize code in a way that's easier to manage, especially in large programs. And properties or attributes, they are the data stored within an object, and they represent the characteristics or traits of the object. So example, if we had an object representing a car, the car's properties could include its color, make, model, and year. And here in this image right here, you can see the make, model, color, and year are the attributes of the car class. And when you create an object from this class, you can assign these attribute values down here. So the object, my car, now has properties that describe the specific car. Also, let's talk about methods. So methods are functions defined inside a class that describes the behaviors or actions an object can perform. So methods allow objects to perform actions, often using or modifying the object's properties. And just like regular functions, methods can accept parameters and return values. So in this picture right here, we see the start engine method, and this is a method that belongs to the car class. So ultimately, by using methods, we can define the actions our objects can take, and each object created from a class has access to the methods defined in that class. All right, so let's go ahead and try to wrap all of this up real quick. So we're going to summarize the key programming concepts that we've covered. So we talked about identifiers. These are names used for variables, constants, functions, and objects in programs. Variables store data that can change, while constants hold fixed values. We talked about arrays. Arrays are data structures used to store collections of related data accessed by an index. Then we talked about functions. Functions are blocks of reusable code that perform specific tasks, and they improve modularity and reusability in programs. And we also talked about objects. So objects are instances of classes that contain properties or attributes and methods, which are also known as functions, that allow them to perform certain actions. Now, understanding these core concepts is essential for programming and helps make code efficient, organized, and easy to maintain. And these concepts are foundational for the CompTIA Tech Plus exam and will aid in your exam preparation. Now, with all of that said, let's do some of this wonderful check on learning. So the first question is, what is the primary difference between a variable and a constant in programming? Is it variables can hold more than one value while constants can hold only one? Is it variables can change their value during program execution while constants cannot? Is it variables are defined globally while constants are defined locally? Or is it variables store data in arrays while constants store data in objects? And the correct answer is variables can change their value during program execution while constants cannot. So a variable is a named storage location in memory that can hold different values during the program's execution. A constant, this has a fixed value that does not change once assigned. And this distinction is key in programming, as constants are often used for values that remain the same throughout a program, like mathematical constants. Next question. Which of the following best describes an array? Is it a single value assigned to a variable? Is it a collection of key value pairs? Is it a data structure that holds multiple values of the same data type? Or is it a function that takes in arguments and returns a value? And the correct answer is it is a data structure that holds multiple values of the same data type. So an array is a data structure used to store a collection of elements, typically of the same data type. Each element in the array is indexed, making it easier to access and modify values using their index positions. And the final question is, what is a method in object-oriented programming? Is it a variable inside an object? Is it a function associated with an object that performs an action? Is it a collection of objects? Or is it a type of constant that belongs to an object? And the correct answer is, it is a function associated with an object that performs an action. So a method is a function that is defined inside an object and is used to perform operations on the object's data or provide functionality related to the object. And methods typically operate on the properties or attributes of the object that they belong to. In this video, we're going to dive into some essential programming concepts, including organizational techniques and logical concepts. This material is critical for anyone studying for the CompTIA Tech Plus exam, and it's valuable for anyone starting out in programming. So we're going to talk about organizational techniques, such as pseudocode concepts, object-oriented methods, comments and documentation, flowchart concepts, and sequence. Then we're going to talk about logical concepts, such as branching and looping. So by the end of this session, you'll have a solid grasp of how to structure and plan code, as well as how programs make decisions and repeat tasks. So let's get started. All right, so programming isn't just about writing lines of code. Effective programming requires planning and organization. This ensures that code is easy to understand, maintain, and debug. So let's begin by looking at several key organizational techniques. First, we're going to talk about pseudocode. So pseudocode, this is a method for planning out algorithms and logic before writing actual code in a programming language. It's written in plain language, making it easy to understand without requiring knowledge or a specific language's syntax. So why do we use pseudocode? Well, it's easy to understand for anyone, even non-programmers. It helps programmers focus on the logic rather than the syntax of a specific language. And when working in teams, pseudocode is a great way to communicate algorithms. Next, let's discuss object-oriented programming, which is one of the most popular programming paradigms. So in object-oriented programming, programs are organized around objects rather than actions. And an object is an instance of a class, which can have both data and functions associated with it. And some of the key concepts in object-oriented programming are as follows. So a class, this is a blueprint for creating objects. So for example, you could have a car class with attributes like color and make, and methods like start or stop. Also, another key concept is encapsulation, and this refers to keeping the data or the attributes in the code or the methods safe within an object and not exposing it unnecessarily. Another concept is inheritance. This allows a class to inherit properties and methods from another class, promoting code reuse. And then we have a concept called polymorphism. So objects can take on different forms, meaning methods in different classes can share the same name but behave differently. So object-oriented methods, it helps organize programs into small, manageable, and reusable pieces of code, making development more efficient and easier to maintain. Now let's look at comments and documentation. So writing code is only part of the job. It's equally important to make sure that anyone else, including your future self, can understand what your code is doing. And this is where comments and documentation come into play. So let's talk about the types of comments. The first one we have is called inline comments. And these are brief comments placed next to lines of code to explain their purpose. And if you look at this picture right here, you can see the inline comment right here that states calculate the sum of two numbers. The next type of comment we have is called a block comment. And these are larger comments that might explain an entire section of code or provide detailed information. So in this picture right here, we have a block comment where it states this function takes two numbers as input and returns their sum. That is a block comment. So why are comments important? Well, comments help make code more understandable, especially for others who might be reading it later. Comments also offer maintainability, so well-documented code is easier to update and debug in the future. And it's essentially a best practice to comment. So good comments help explain why certain decisions were made, not just what the code is doing. In addition to comments, documentation provides a more comprehensive explanation of how to use code or software and is often written in external documents or in a structured format within the code itself, like doc strings in Python. All right, so let's move on to flow charts, which is a visual method for organizing the flow of a program. So flow charts use diagrams to represent the sequence of steps in a process, making them an essential tool in the planning phase of development. And we have various flow chart symbols. So we got the oval. This represents the start and end points. We have a rectangle. This represents a process or an action. We have the diamond. This represents a decision point. And we have an arrow. This indicates the flow or direction of the process. And the most basic flowchart concept is sequence, which is an ordered series of steps that the program follows one after the other. There are no decisions or loops in the sequence. Each action is executed only once. So essentially, flowcharts are useful for visualizing the structure of programs, helping programmers to ensure they follow the correct logic flow. All right, so let's shift focus to logic concepts in programming. These concepts help dictate the flow of programs and define how decisions and repetitions are handled. And the first one we're going to talk about is called branching or decision making. And this allows a program to execute different blocks of code based on certain conditions. And these are the most common branching concepts. We have what is called an if-else statement. So these check on the condition and execute one block of code if the condition is true and another block if the condition is false. Then we have what is called a nested if statement. So sometimes multiple conditions need to be checked and nested if statements allow for this. Then we have what is called a switch case statement. So another branching structure that's used to test multiple conditions is commonly found in languages like C, C++, or Java. So branching is crucial because it allows programs to make decisions based on input, user interactions, and other data. Next, we're going to talk about looping or repetition. So looping, this allows a program to repeat a set of instructions multiple times until a certain condition is met. And there are several types of loops. The first one we have is called a while loop. So a while loop repeats as long as a specified condition is true. Then we have what is called a for loop. So a for loop is used when you know how many times you want to repeat a set of instructions. Then we have what is called a do while loop. And this is similar to a while loop, but it generates the code inside the loop and will run at least once, even if the condition is false. So loops are essential for tasks that require repetition, such as iterating through a list of items or continuously checking for user input. All right, so in this video, we covered essential programming organizational techniques and logic concepts that will help you better understand how programs are structured and how they operate. So we talked about pseudocode, and this is good for planning and structuring code. We talked about object-oriented methods, and this is used to help organize programs into reusable objects. We talked about comments and documentation. This is to ensure code is readable and maintainable. We talked about flowchart concepts. This is for visualizing the flow of a program and focusing on sequences. We talked about branching. This is for making decisions in a program. And we talked about looping, and this is for repeating actions in a program. So these are the fundamental concepts that you'll need to grasp for the CompTIA Tech Plus exam. And more importantly, they'll make you a more effective programmer. So with all of that said, let's do some of this wonderful check on learning. So the first question is, what is the primary purpose of pseudocode in programming? Is it to execute a simplified version of a program? Is it to create a human readable outline of program logic? Is it to automate code generation? Or is it to debug a program at runtime? And the correct answer is, it is to create a human readable outline of program logic. So pseudocode is used to outline the structure and logic of a program in a simplified human readable format. It allows developers to conceptualize the flow of a program without worrying about the specific syntax of a programming language. Next question. Which of the following is an example of a logic concept involving repetition in programming? Is it branching, looping, flowcharting, or object-oriented methods? And the correct answer is looping. So looping, this refers to the repetition of a block of code as long as a specific condition is met. It is a fundamental logic concept used in repeat actions, such as iterating over a list of items. And our final question, which organizational technique is commonly used to visualize the step-by-step flow of program logic? Is it object-oriented programming, Is it flowcharts? Is it a variable? Or is it arrays? And the correct answer is it is a flow chart. So flow charts, they are graphical representations used to illustrate the sequence of operations in a process or program. Each step is depicted as a box or shape connected by arrows, showing the flow from one action to the next. And this helps in visualizing the logical sequence of a program. In this video, we're going to explore the value of data and information in modern businesses and technology environments. Data is one of the most valuable assets a company can possess, influencing everything from decision-making to strategic direction. In this video, we'll cover the concept of data as an asset, including the differences between critical and non-critical data. We'll talk about how data-driven business decisions are made by capturing, correlating, and reporting on data. We'll talk about the growing phenomena of data monetization. We'll talk about the role of data analytics, and we'll talk about the implications of big data. So let's dive right in. Let's start by talking about data and information as an asset. So in today's digital world, data is often considered more valuable than traditional physical assets like equipment or buildings. Companies collect vast amounts of data, from customer preferences to internal operations, and use it to improve processes, develop new products, and enhance the customer experience. But not all data is equally important. So let's talk about critical versus non-critical data. So critical data, this is data that's essential to the functioning and success of a business. Loss of critical data can lead to significant disruptions, financial loss, or reputational damage. And some examples include customer data, such as personal information like names, emails, and addresses. We have financial data. These could be company financial records, transactions, and payroll details. And we have operational data. This is data necessary for running the core operations of a business, such as supply chain information or inventory levels. And then we also have what is called non-critical data. So while useful, non-critical data is not essential to daily operations or the company's survival. Loss or corruption of this data might cause inconvenience, but it won't necessarily halt business operations. So some examples include marketing preferences, and this could be historical data about promotional campaigns that might not affect current operations. And then we have archive emails. This could be older communication that may no longer be relevant to current business activities. So it's important to classify data based on its criticality, because this classification impacts how it's protected, stored, and managed. Businesses often use data classification systems to categorize data according to its level of importance. Next, let's explore data-driven business decisions. So in the modern business world, data plays a crucial role in shaping strategies and making informed decisions. But how does this happen? So let's break it down into three key stages. First stage is called data capture and collection. So companies collect data from a variety of sources, including customer interactions, social media, transaction records, and sensor data. This data is often stored in databases or data warehouses, ready for analysis. And the key challenge here is ensuring the accuracy and integrity of the data being captured. So garbage in and garbage out. If your data collection processes are flawed, your decisions will be flawed as well. Then we have what is called data correlation. So once collected, data must be correlated to find meaningful patterns or relationships. So for example, a business might correlate sales with customer demographics to understand which segments are purchasing certain products. And this is where business intelligence tools come into play, which help organizations identify trends and correlations between data sets. And then we have what is called meaningful reporting. So after correlating data, the next step is to present it in a way that decision makers can understand. This is often done through dashboards, charts, or reports. And reports, they should focus on key performance indicators relevant to the business's goals. So for example, a retail company might focus on sales trends, inventory levels, and customer satisfaction scores. Reporting is most effective when it enables actionable insights. The goal is not just to understand what happened, but to inform decisions on how to improve outcomes. So data-driven decision-making, this reduces reliance on gut feeling and intuition, offering a more objective, evidence-based approach to business strategy. Now let's talk about data monetization, which is a growing trend in the business world. So data monetization, this is the process of turning data into revenue. Businesses collect and analyze data, not just to improve internal operations, but also to create new revenue streams. There are two primary ways companies monetize their data. The first is called direct data monetization. This involves selling raw data to third parties. So for example, social media platforms may sell user data to advertisers looking to target specific demographics. Companies in industries like marketing, insurance, and healthcare often purchase data to gain insights into customer behavior, risk factors, or market trends. Then we have what is called indirect data monetization. In this approach, companies don't sell the data itself, but instead use it to optimize internal processes or create new products and services. So for example, a ride-sharing app like Uber uses real-time data to improve driver routing and reduce wait times, which improves customer satisfaction and reduces operational costs. In e-commerce sites, they analyze customer purchase data to recommend products which drive additional sales. So by leveraging data effectively, businesses can open up new revenue opportunities and gain a competitive edge in their market. Let's move on to data analytics, which is the practice of examining data to draw meaningful insights from it. So data analytics comes in different forms. We have what is called descriptive analytics. And this type of analytics helps answer the question of what happened. It involves summarizing historical data to identify trends or patterns. So for example, a business might use descriptive analytics to understand past sales performance or customer behavior. Then we have what is called diagnostic analytics. So diagnostic analytics goes a step further by asking, why did it happen? This type of analysis explores the causes behind trends. So for example, a company might use diagnostic analytics to determine why sales dropped during a specific period. And then we have what is called predictive analytics. So as the name suggests, predictive analytics focuses on forecasting future outcomes based on historical data. So for example, an online retailer might use predictive analytics to forecast future sales based on seasonal trends and past performance. And then we have what is called prescriptive analytics. And this is the most advanced form of analytics, which answers the question such as, what should we do? It provides actionable recommendations based on data. So for example, if a business identifies a dip in sales, prescriptive analytics might suggest a specific marketing strategy to reverse the trend. So data analytics empowers businesses to make better decisions, increase efficiency, and uncover opportunities for growth. All right. And finally, we need to talk about big data. So big data, this refers to data sets that are so large or complex that traditional data processing tools cannot handle them. And big data is often described in terms of the 3 V's. And the first V stands for volume. And this is the sheer amount of data being generated, often measured in petabytes or exabytes. So for example, social media platforms like Facebook generate enormous volumes of data every second as users post, comment, and share content. The second V is called velocity. And this is the speed at which data is generated and processed. Big data is often generated in real time, such as the data produced by sensors on self-driving cars or financial market transactions. And the third V is called variety. So big data comes in many forms, from structured data like databases to unstructured data like emails, videos, and social media posts. The challenge with big data isn't just its size, it's also how to store, process, and analyze it effectively. Traditional database management tools may struggle with big data, so companies often use specialized technologies like Hadoop or cloud-based solutions to handle it. And big data is valuable because it can offer insights that will be impossible to uncover with smaller data sets. So for example, healthcare organizations can use big data to analyze patient records and improve treatment plans, while marketers can use big data to understand consumer behavior on a massive scale. So in conclusion, data and information are incredible, valuable assets in the modern business world. Understanding the differences between critical and non-critical data helps businesses protect what matters most, while data-driven decision-making allows companies to operate more effectively. Data monetization creates new revenue opportunities. Data analytics offers deeper insights into business performance, and big data opens up new frontiers for analysis at an unprecedented scale. So this knowledge is key for anyone preparing for the CompTIA Tech Plus exam, and it will help you understand the real world importance of data. So with all of that being said, let's do some of this check on learning. So the first question is, which of the following best describes critical data in the context of data as an asset? Is it data that is only used for internal reports and does not affect business operations? Is it data that, if lost or compromised, would cause minimal disruption to the organization? Is it data that is essential to the organization's operations and could cause severe impacts if lost or compromised? Or is it data that is no longer needed and can be archived? And the correct answer is it is data that is essential to the organization's operations and could cause severe impacts if lost or compromised. So critical data is information that is essential to the organization's core functions. If such data is lost or compromised, it can lead to severe operational, financial, or reputational damage. Non-critical data, on the other hand, this may cause some inconvenience, but not a major disruption. Next question. Which of the following is a key advantage of data-driven business decisions? Is it they eliminate the need for human decision makers? Is it they are based on intuition and experience rather than data? Is it they rely on data capture, analysis, and meaningful reporting to improve decision accuracy? Or is it they are quicker to make since they ignore data and focus on subjective opinions? And the correct answer is they rely on data capture, analysis, and meaningful reporting to improve decision accuracy. So data-driven business decisions leverage data capture, collection, and analysis to inform decision-making processes. This approach leads to more accurate, measurable, and objective decisions that can positively impact business outcomes as opposed to relying on subjective opinions or intuition. And the final question, how can data monetization benefit an organization? Is it by using data to directly generate revenue through sales or exchange? Is it by storing data indefinitely for future use, even if it has no current value? Is it by preventing competitors from accessing the data? Or is it by using non-critical data to make strategic decisions? And the answer is it is by using data to directly generate revenue through sales or exchange. So data monetization, this refers to the process of using data to generate revenue, either by selling the data to third parties or using it internally to create new products, services, or improve efficiency. And data that is valuable can be leveraged to create financial gains for the organization. In this video, we're going to dive into a critical topic for any tech professional. We're going to talk about databases. So databases are at the heart of most modern computing systems, storing the data that powers applications, websites, and businesses. So we're going to discuss what databases are used for, the difference between flat files and databases, database records and how they are stored, and data persistence and availability. So let's get started. First, let's explore the uses of a database. So a database is essentially a structured collection of data that allows users to efficiently store, retrieve, and manage information. And some of the most common tasks performed with a database include the following. So the first one would be creating a database. So this involves defining the structure of the database, including tables, fields, and relationships between the data elements. So for example, in a company's customer management system, you might create a database with tables for customers, orders, and products. And each table will have defined fields like customer name, order date, or the product price. Also, another task is importing or inputting data. So once the database is created, data must be input or imported. And this can be done manually or automatically by connecting the database to external sources like spreadsheets or other databases. So imagine a scenario where customer data is imported from a CRM or customer relationship management system into a central database, ensuring all departments have access to the same information. Another task would be querying a database. So a query, this is a way to request specific information from a database. Queries are written in SQL or structured query language or other database languages. So for instance, you might write a query to find all customers who made purchases last month or to list the top selling products in a specific region. And this process of retrieving data is key to making databases useful in decision making and reporting. And then speaking of reporting, we have the ability to generate reports. So once the data is queried, the next step is often to generate reports. So reports allow you to analyze data in a structured format, summarizing the results in an easy to read way. So for example, a sales report could show a breakdown of revenue by month, helping management track business performance over time. So in short, databases are used to create, input, query, and report on data, making them invaluable for storing and using structured information. Now let's compare a flat file to a database. So while both are used to store data, they differ significantly in structure, capabilities, and use cases. So let's talk about a flat file. A flat file, this is a simple file that stores data in plain text, usually separated by delimiters like commas or tabs. And they are often stored as CSV or comma separated value files. In flat files, they are ideal for small data sets or single user applications, but are limited in functionality. Then we have the database. So a database, on the other hand, this is a more complex system that allows for multiple tables with relationships, indexes for faster searching, and advanced data management features. Databases are typically managed by database management systems such as MySQL, PostgreSQL, or Microsoft SQL Server. So let's break this down further by comparing a few key features. And the first one we're going to talk about is called multiple concurrent users. So flat files can generally only be accessed by one user at a time. If multiple users try to open or edit the file simultaneously, it can cause data corruption. Databases, however, they are designed for multiple concurrent users. A database management system handles conflicts and ensures data integrity by using techniques like locking and transactions. The next feature is scalability. So flat files don't scale well as the amount of data grows. Searching or updating a large file can become slow and cumbersome. Databases, in contrast, they are built to handle large data sets and complex queries efficiently, and they offer built-in mechanisms like indexes to quickly locate data, even in massive databases. Another factor is speed. So flat files are relatively slow when it comes to searching or sorting data, as there is no indexing or optimization. Databases are optimized for speed with advanced indexing, caching, and query optimization techniques that make them much faster than flat files. And then we have the variety of data. So flat files are limited to simple structured data, and there's no built-in way to handle complex data types or relationships between records. Databases allow you to share a variety of data types, from text and numbers to binary data like images or documents, and they also support relationships between different tables, making them far more versatile than flat files. So in summary, flat files are suitable for simple use cases with limited data, while databases are the preferred choice for large multi-user systems requiring fast access and scalability. All right, next, let's talk about database records. So a record, this is a single entry in a database table representing an individual item or object. And each record consists of fields, which are attributes or properties of that object. So for example, in a customer database, each record would represent a customer, and fields might include the customer's name, email address, phone number, and purchase history. And records in a database are stored in rows, with each row containing a unique set of values for the defined fields. And the collection of records in a table can then be queried, updated, or deleted as necessary. And managing records efficiently is key to making databases useful for large-scale operations. With proper indexing and optimization, databases can quickly retrieve and manipulate records, even when dealing with millions of entries. Now, one of the critical aspects of databases is how they store data and ensure data persistence. So data persistence, this refers to the ability to store data in a way that ensures it remains available even after a system restarts or powers off. And this is critical for databases, which often store valuable business information. Most modern databases store data on hard drives or solid state drives, which provide persistent storage. When you create or modify a record in a database, the change is saved to the disk, ensuring that the data remains accessible even after a power outage or a system reboot. In addition to physical storage, many databases also use backups and replication to ensure data integrity. And these systems allow databases to recover quickly in the event of failure, protecting against data loss. And the last important concept we'll cover is data availability. So we're going to talk about cloud versus local storage first. So Local databases are hosted on physical servers that reside within an organization's infrastructure. And these systems offer full control over the hardware and data, but come with higher maintenance costs and limited scalability. Cloud databases, on the other hand, they are hosted on remote servers managed by a cloud provider like Amazon Web Service or Microsoft Azure. And cloud databases are highly scalable and accessible from anywhere, making them a popular choice for modern applications. Then we have online versus offline access. So online databases are designed to be accessed over a network or the internet, meaning they require a constant internet connection. And these databases provide real-time access to data from anywhere, but the downside is the dependence on the network connectivity. Offline databases allow users to access and manipulate data without an internet connection. They sync data when the connection is restored, which is useful for mobile apps or remote locations where internet access may be intermittent. So data availability is a critical factor in database management, ensuring that users can access and interact with their data wherever and whenever they need it. All right, so to wrap this up, databases are an essential part of modern computing, providing structured ways to store, manage, and retrieve data. So we've covered the core uses of a database, where we talked about creation, input, querying, and reporting. We talked about the differences between flat files and databases, including scalability, speed, and concurrent access. We talked about how database records are structured and stored. We talked about the importance of data persistence and ensuring long-term storage. And we talked about the impact of data availability, both in terms of cloud versus local storage and online versus offline access. So these concepts are key to understanding how databases work and why they're so important in today's IT environments. Now, with all of that said, let's do some of this check on learning. So the first question is, which of the following is not a common use of a database? Is it creating and storing data? Is it importing and querying data? Is it generating reports? Or is it printing documents directly from the database? And the correct answer is it doesn't print documents directly from the database. So while a database can store data used in generating reports or documents, printing is not typically done directly from the database itself. Databases are more focused on storing, querying, and organizing data. Printing is often handled by separate software using data retrieved from the database. Next question. What is a key advantage of using a database over a flat file for data management? Is it databases are slower but easier to set up than flat files? Is it databases allow multiple concurrent users and provide scalability? Is it flat files support more complex data structures than databases? Or is it databases are limited to a single user in small data sets? And the correct answer is databases allow multiple concurrent users and provide scalability. So databases are designed to handle multiple users accessing and manipulating data simultaneously, and they scale better as data volume grows. Flat files are simpler, but do not support these features, making them less ideal for complex large-scale data management. And our final question, which of the following best describes data persistence in the context of a database? Is it the ability to perform queries quickly? Is it the durability of data stored in the database even after the system is powered off? Is it the ability to share data across multiple users in real time? Or is it the use of cloud storage to ensure remote access? And the correct answer is it is the durability of data stored in the database even after the system is powered off. So data persistence refers to the continued storage of data, ensuring it remains intact and accessible even after the system is turned off or restarted. And this is a fundamental feature of databases, distinguishing them from temporary storage mechanisms. In this video, we're going to explore the world of databases and discuss the differences between structured, semi-structured, and non-structured databases. We'll also compare relational and non-relational databases, delving into the details of schema, tables, keys, and constraints for relational databases, as well as key value stores and document databases for non-relational databases. Now, understanding how different types of databases work is essential for managing, storing, and retrieving data efficiently in various computing environments. So with all that said, let's go ahead and get into the details. So to begin, let's define and compare the three main types of database structures. We're going to talk about structured, semi-structured, and non-structured databases. So let's begin with structured data. So structured data, this is the most organized form of data. and it fits into predefined models, often with rows and columns like a spreadsheet or a relational database. And structured data follows a strict schema, meaning every data point fits a specific format, making it easy to query, manipulate, and analyze. And some examples will be customer records, sales data, financial data. All of these can be stored in tables with predefined fields like name, age, and address. And also, structured data is often stored in relational databases such as MySQL, PostgreSQL, or Microsoft SQL Server. So in structured data, because every piece of data has a clear predefined model, tasks like querying or joining tables becomes highly efficient. Next, let's talk about semi-structured data. Semi-structured data falls between structured and non-structured data. It doesn't adhere to a strict table format, but it still has some organizational properties that make it easier to analyze than non-structured data. So semi-structured data may have tags or keys that define certain data elements, but the structure isn't rigid. So for example, some fields might exist in one record, but not in another. And some examples of semi-structured data are JSON and XML documents. In these formats, data can have varying attributes, but still maintain a certain level of organization. And this type of data is often stored in document databases like MongoDB or Couchbase. So semi-structured data is particularly useful for applications that require flexibility, such as web applications that handle dynamic content. All right, next let's talk about non-structured data. So non-structured data, on the other hand, doesn't have any predefined structure. This type of data is more challenging to analyze and store in a traditional relational database. So non-structured databases have no fixed schemas. So non-structured data is unorganized and can take any form, and it doesn't fit neatly into rows or columns. And some examples include multimedia files like images, video, and audio, social media posts, and sensor data. And non-structured data is typically stored in specialized databases or file storage systems like NoSQL databases, Hadoop, or even cloud-based systems like Amazon Web Services S3. So non-structured data has become increasingly important as businesses deal with vast amounts of multimedia, user-generated content, and data from sensors or IoT devices. All right, now that we understand the different types of data, let's move on to relational databases, which are a popular choice for storing structured data. So what is a relational database? So a relational database, this is the type of database that stores data in a structured format using rows and columns. And data is organized into tables, and the relationships between the tables are defined using keys. And the most common relational database management systems include MySQL, PostgreSQL, Oracle Database, and Microsoft SQL Server. So relational databases excel in situations where data consistency and relationships between data points are critical. So let's explore some key concepts that define relational databases. All right, first we're going to talk about what is called a schema. So a schema defines the structure of a relational database, specifying how data is organized into tables, fields, and relationships. It acts as a blueprint for the database, determining what data can be stored and how it can be accessed. So we have what is called a table, and this is the core of a relational database. Each table contains records or rows and fields or columns. And we have what are called constraints. These are rules that ensure the integrity of the data. So for example, a constraint may enforce that a particular field cannot be left blank or that a field must contain unique values. And schemas, they are important for maintaining data consistency and ensuring that all entries conform to the same rules. Next, we have tables, rows, and columns. So relational databases organize data into tables, which consist of rows, which are also known as records, and columns, which are also known as fields. And when it comes to rows, each row in a table represents a single record or entry. So for example, in a customer table, each row would represent a different customer. And then it also has columns. So each column represents a specific attribute of the data, such as a customer's name, address, or phone number. So this structure makes it easy to run complex queries and retrieve specific data efficiently. Next, we're going to talk about what is called the primary key and a foreign key. So two important types of keys in relational databases are the primary key and the foreign key. And the primary key, this is a unique identifier for each record in a table. It ensures that no two records in the table are identical. So for example, a customer ID might be the primary key in a customer table. Then we have what is called the foreign key. So a foreign key is a field in one table that links to the primary key in another table. It creates a relationship between the two tables. So for instance, an order table might have a foreign key linking it to the customer table to identify who placed each order. So by linking tables through foreign keys, relational databases can efficiently manage relationships between data. Then we have what are called constraints. And constraints in relational databases help ensure data integrity by imposing rules on the data. And common constraints include the following. You have what is called a not null. And this ensures that a column cannot have a null value. We have a constraint called unique. This ensures that all values in a column are unique. We have a check constraint. This ensures that all values in a column meet a specified condition. And then we have the foreign key. This enforces the link between tables. So constraints, they play a critical role in maintaining the accuracy and reliability of data in relational databases. All right, now let's switch gears and discuss non-relational databases, often referred to as NoSQL databases. And these databases are designed to handle different types of data, especially semi-structured or non-structured data. So what is a non-relational database? So unlike relational databases, non-relational databases do not rely on tables, rows, and columns. Instead, they use more flexible data models. And this flexibility makes them ideal for storing large volumes of unstructured or semi-structured data. And common non-relational database types include the following. You have what is called a key value database, and you have what is called a document database. So non-relational databases, they are highly scalable and they perform well in distributed systems. All right, so let's talk about the key value database. So a key value database is the simplest type of NoSQL database where data is stored as a collection of key value pairs. And a key, this is a unique identifier for the data. And the value, this is the data associated with the key that can be any type of information such as text, numbers, or binary objects. So key value databases are often used for storing session data, configuration settings, or user profiles. And popular key value databases include Redis and DynamoDB. Next, we have what is called a document database. So a document database, this stores data in the form of documents, typically in JSON or BSON, which stands for binary JSON format. And they offer flexible schemas. So unlike relational databases, document databases don't require a fixed schema, which makes them ideal for handling semi-structured data. They also offer nested documents. So documents can contain nested fields and arrays, allowing for more complex and hierarchical data structure. And they offer query flexibility. So document databases allow for rich querying, making them powerful for applications that need to search and filter based on various fields. And two popular document databases include MongoDB and CouchDB. All right, so let's quickly compare relational and non-relational databases. So when it comes to relational databases, we're talking about structured data. So relational databases are ideal for storing structured data with predefined relationships. They are also what is called ACID compliance. And these databases are known for their ACID properties, and that stands for atomicity, consistency, isolation, durability, and all of that ensures data integrity. They're known for a fixed schema. So a strict schema is used, which may require careful planning and upfront design. And a typical use case, relational databases are used in situations where data consistency is critical, such as in financial systems or inventory management. Then we have what is called the non-relational database, and they offer flexible data models. So non-relational databases are better suited for handling semi-structured or non-structured data. They are schema-less, so they have no predefined schema, which allows for them to be more flexible in handling evolving data. They are very scalable. So non-relational databases are highly scalable, making them ideal for applications with large amounts of data or high traffic, such as social media platforms or content management systems. In a typical use case, non-relational databases, they excel in environments where the data structure is constantly changing or large-scale horizontal scalability is required. So in conclusion, we've explored the differences between structured, semi-structured, and non-structured data, as well as compared relational and non-relational databases. So once again, relational databases, they offer structured data with a fixed schema, keys, and constraints, making them ideal for applications that require data integrity and relationships between records. And then we have non-relational databases, and they offer more flexibility for handling semi-structured and non-structured data, making them perfect for modern applications that require scalability and flexibility. Now, understanding these database structures is essential for the CompTIA Tech Plus exam and for working effectively with different types of data in the real world. Now, with all of that being said, let's do this check on learning. So, which of the following best describes a structured database? Is it a database with loosely defined data and flexible schemas? Is it a database that organizes data into tables with rows and columns following a fixed schema? Is it a database that stores data in key value pairs? Or is it a database that focuses on storing unstructured data like images and videos? And the correct answer is it is a database that organizes data into tables with rows and columns following a fixed schema. So structured databases, such as relational databases, they organize data into predefined tables consisting of rows and columns. And each column has a defined data type, and a fixed schema determines how the data is organized. This contrasts with semi-structured and non-structured databases, which allow for more flexibility in data organization. Next question. In a relational database, what is the purpose of a foreign key? Is it to uniquely identify each record within a table? Is it to reference data in another table, creating a relationship between the two? Is it to restrict data from being duplicated in the same table? Or is it to store unstructured data such as images and documents? And the correct answer is it is to reference data in another table, creating a relationship between the two. So a foreign key in a relational database creates a link between two tables by referencing the primary key of another table. This allows relational databases to maintain relationships between tables, ensuring data integrity across related tables. And our final question, which type of database is most appropriate for storing large amounts of unstructured data, such as videos or logs? Would it be a relational database, a document database, a flat file database, or a key value database? And the correct answer would be this would be a document database. So document databases, which are a type of non-relational database, are well suited for handling unstructured or semi-structured data, such as videos, logs, and documents. They store data in formats like JSON and BSON, allowing for flexible schemas that can accommodate a variety of data types without the rigid structure required by relational databases. In this video, we'll be discussing one of the most critical aspects of data management, and that is data backups. Data is the lifeblood of any digital environment, and having reliable backups is key to ensuring that data can be restored if something goes wrong. Whether it's accidental deletion, hardware failure, or a cyber attack, the ability to restore important data is essential for businesses and individuals alike. So in this video, we'll cover what data backups are and why they're important, different types of data backups, including file backups, system backups, and restoring data. And we'll talk about backup locations, such as storage locations like flash drives, external hard drives, SD cards, and we'll also talk about cloud storage solutions. So let's begin with the basics of data backups. So at its core, a data backup is a copy of your data stored separately from the original, allowing you to recover information in case it's lost, corrupted, or damaged. And backups, they can be created automatically or manually, depending on the system and needs of the user. And they are essential for protecting your data from loss due to hardware failure, because hard drives can fail unexpectedly, and this can lead to data loss. Also, there's accidental deletion, so sometimes files are deleted by mistake. You have cyber attacks, so ransomware and malware can corrupt or encrypt your data, leaving you without access. And then we have natural disasters. So things like floods, fires, or other disasters can damage your physical devices. So without a backup in place, recovering lost data can be expensive or impossible. Now that we understand the importance of data backups, let's move on to the types of backups. When it comes to backups, there are two primary types to understand. We have file backups and system backups. So let's talk about file backups. So a file backup, this is a copy of specific files or folders that are important to you. It allows you to recover individual pieces of data like documents, photos, or project files without restoring the entire system. There are several approaches to file backups. We have what is called a full backup. So every file in a designated folder or drive is copied regardless of whether it has been changed since the last backup. And this method is the most comprehensive but can take up significant storage space and time. Then we have what is called an incremental backup. And this is when only the files that have changed since the last backup, whether full or incremental, are copied. And this method saves time and storage but requires multiple backup points to fully restore data. Then we have what is called a differential backup. And this is similar to incremental backups, but it backs up all files that have changed since the last full backup. It uses more storage than incremental backups, but requires fewer backup points to restore. So for example, if you have critical documents you want to safeguard, you can set up a regular file backup to ensure you always have the most recent versions. Next, let's talk about system backups. So a system backup, on the other hand, this is a complete snapshot of your computer's operating system, settings, installed programs, and files. And this type of backup is useful if you want to restore your entire system to a previous state after a major failure or corruption. And the key points about system backups are as follows. So they offer a full system image, and this creates an exact copy of your entire system, allowing you to recover not just files, but also installed programs and system configurations. Then we have what is called a bare metal backup. This type of system backup allows you to restore your entire system from scratch, including the operating system, without the need to reinstall anything manually. So system backups are especially useful in business environments or for personal users who want to avoid the hassle of reinstalling software and reconfiguring their system. All right, now let's talk about the process of restoring data from a backup. So whether you lost an important file or your entire system has failed, the ability to restore from a backup is crucial. And there are different methods of restoring data depending on what type of backup you have. So the first one is called the file restoration. So if you have a file-based backup solution, restoring a file or folder is generally straightforward. Most backup software will allow you to browse your backups and select the file or version that you want to restore. In cloud backup solutions, you can log into your account and find the files you need and restore them to your local device. Then we have what is called system restoration. So restoring from a system backup is a bit more complex, as it often involves booting the computer into a recovery mode or using a dedicated system restore tool. In the case of a full system image, the backup software will overwrite your current operating system and files with the saved backup, bringing your computer back to the exact state it was in at the time of the backup. And many systems have built-in restoration options, such as Windows System Restore feature, and this allows you to revert the operating system to a previous configuration without affecting personal files. In either case, regular backups and a clear understanding of your restore options are critical for a smooth recovery in case of a data loss. Now that we've covered the types of backups and how to restore data, let's move on to where you can store your backups. So choosing the right backup location is essential, as it determines how accessible, secure, and safe your backups will be. So let's first look at local storage options. And these are physical devices where you can store your backups close at hand. And we have what are called flash drives. So flash drives, these are portable storage devices, often referred to as USB drives or thumb drives. They're small, lightweight, and easy to use, and flash drives are great for small file backups or quick data transfers. However, they have limited storage capacity and are prone to loss or damage, making them better for temporary backups rather than long-term storage. And then we have external hard drives, which are a popular choice for local backups. These devices offer significantly more storage than flash drives, often ranging from 500 gigabytes to several terabytes, and they are ideal for both file and system backups, as they can store large amounts of data and entire system images. And one key benefit of external hard drives is their portability, allowing you to store the drive in a safe location away from your primary computer. However, just like any hardware, they are vulnerable to physical damage, theft, or failure over time. And then we have what are called secure digital cards or SD cards, and they are small portable devices commonly used in smartphones, cameras, and some computers. While their storage capacity is smaller compared to external hard drives, they are useful for file backups like photos, videos, or documents. Now, due to their size and ease of use, SD cards are often used for temporary storage or removing data between devices. However, like flash drives, they are also prone to loss and have limited storage capacity. All right, next, let's discuss cloud storage as a backup option. So cloud storage refers to storing your data on remote servers accessed via the internet. This method has grown in popularity due to its accessibility, scalability, and convenience. So here are some of the advantages of cloud storage. The first one is remote access. So cloud storage allows you to access your backups from anywhere in the world as long as you have an internet connection. And this makes it ideal for users who need constant access to their data. Cloud storage also offers automatic backups. So many cloud providers such as Google Drive, Dropbox, and iCloud offer automated backups. This means you don't have to worry about manually backing up your files. The system does it for you on a regular schedule. Another advantage is scalability. So unlike physical storage options, cloud storage is easily scalable. So if you need more space, you can simply upgrade your plan. And then there's data redundancy. So cloud providers, they typically store your data in multiple locations, which helps protect against data loss due to server failure or disaster. Now, here are some considerations when it comes to cloud storage. The first one is security. So while cloud providers use encryption to protect your data, there's always a risk of unauthorized access or data breaches. So you want to make sure to choose a reputable provider and use strong passwords and two-factor authentication. The next consideration is cost. So cloud storage often comes with a subscription fee, especially for large amounts of data. While some providers offer free tiers, the space is usually limited. And then there's the need for internet access. So restoring large amounts of data from the cloud can be time-consuming if you have slow internet connections. Now that we've covered both local and cloud storage options, let's finish by discussing some best practices for data backups. So the first practice is called the 3-2-1 rule. So this rule suggests that you should have 3 different copies of your data, 1 primary copy and 2 backups. And you want to store the backups on 2 different types of media and keep at least 1 off-site, such as in the cloud or at a remote location. And this ensures redundancy and protects against data loss from local disasters. Then we have automated backups. So you want to set your system of software to perform automatic backups at regular intervals. This reduces the risk of forgetting to manually back up your data. Also, you want to test your backups. So a backup is only useful if it works when you need it. So you want to periodically test your backup and restoration process to ensure that your files can be successfully recovered. Then you want to use encryption. So for sensitive data, you want to use encryption to protect your backups, especially if you're using cloud storage. This ensures that your data is secure, even if the backup media or account is compromised. So to summarize, backups are a vital part of any data protection strategy. Whether you're backing up important files or your entire system, it's essential to understand the types of backups, where to store them, and how to restore your data if disaster strikes. So in this video, we talked about data types such as file backups, system backups, and how to restore your data. And we also talked about storage options such as local options with flash drives, external hard drives, SD cards, and we talked about cloud storage. Now, by following best practices such as the 3-2-1 rule, automating backups, and testing your restore processes, you can ensure your data will always be protected. Now, with all of that said, let's do some of this check on learning. So the first question is, which type of backup includes a complete copy of all files on the system? Is it an incremental backup, a differential backup, a system backup, or a file backup? And of course, the correct answer is it is a system backup. So a system backup creates a full copy of the entire system, including the operating system files, applications, and user data. This ensures that the system can be fully restored in case of a failure. File backups, on the other hand, only back up selected files and not the entire system. Next question. Which of the following is not an example of local storage for backups? Would it be a flash drive, an external hard drive, an SD card, or cloud storage? And of course, the answer is cloud storage. So, local storage includes physical storage devices like flash drives, external hard drives, and SD cards, which are connected directly to a computer. Cloud storage, this is an online option where data is stored on remote servers and accessed via the internet. So, it is not considered local storage. And the final question, what is the primary purpose of restoring data from a backup? Is it to free up storage space? Is it to update software? Is it to recover lost, deleted, or corrupted data? Or is it to remove malware? And of course, the correct answer is it is to recover lost, deleted, or corrupted data. So the main purpose of restoring data from a backup is to recover files or systems that have been lost, deleted, or corrupted due to hardware failures, software issues, or security breaches. Restoring brings the data back to its original state. In this video, we'll cover the essential principles of security, including confidentiality, integrity, and availability, privacy considerations, and key concepts like authentication, authorization, accounting, and non-repudiation. So by the end of this video, you'll have a clear understanding of how these elements form the foundation of modern cybersecurity practices. All right, so let's start with the CIA triad, which forms the backbone of security principles. In CIA, this stands for confidentiality, integrity, and availability. So let's talk about confidentiality. So this refers to protecting information from unauthorized access or disclosure. In practice, this means ensuring that only those who have permission can view or use the data. And examples include encrypting sensitive data, using passwords, and employing access control measures. And a common analogy is locking a diary with a key to prevent others from reading it. And then we have what is called integrity, and this involves ensuring that data remains accurate, complete, and unaltered. Any unauthorized changes to the data should be detectable, and examples include file checksums or hashing algorithms, which verify that data hasn't been tampered with. So think of integrity as keeping your bank statement correct and ensuring no one can change the amounts or the dates. And then we have availability, and this ensures that data and systems are accessible to authorized users when needed. This means maintaining system uptime and avoiding disruptions caused by hardware failure, cyber attacks, or natural disasters. And examples include redundancy systems, data backups, and denial of service protection measures. So consider availability like ensuring the power is always on in a critical hospital system to where it must be operational 24/7. All right, next, let's move on to privacy. So privacy in the digital age is a growing concern, especially with the proliferation of social media, file sharing, and online communication tools. So let's break it down into its key areas. And the first one is social networking sites. So social platforms like Facebook, Instagram, and X, they collect vast amounts of user data, and users should be aware of privacy settings and understand how their personal data is shared or sold to third parties. Then we have email and instant messaging. So emails and instant messaging, they often contain sensitive information. So use encryption technologies like PGP are pretty good privacy for emails and end-to-end encryption for messaging apps to ensure that communications remain private. Then we have file sharing. So services like Google Drive or Dropbox are used to share files, but proper access controls are crucial. So encrypt sensitive files before sharing and ensure only authorized individuals can access them. Next, we have personally identifiable information, or PII. And this includes data like your name, address, phone number, and social security number. So protecting PII is critical because it can be used for identity theft. Always ensure that organizations handle PII with proper encryption and strict access control. And then we have government regulations. So the General Data Protection Regulation is a European law that governs how personal data should be protected. GDPR, this mandates that organizations need explicit consent from users to collect their data, and that users have the right to know how their data is used. Users also have the right to request the deletion of their data. And then we have what is called cookie consent, and this is a common requirement of GDPR, where websites must get user consent before tracking their online behavior with cookies. All right, now let's look at the AAA framework, which stands for authentication, authorization, and accounting. And these concepts help control access to resources and monitor activity. So the first A is authentication, and this is the process of verifying the identity of a user or system. There are different types of authentication. You have single factor authentication, where this involves just one method, like entering a password. You have multi-factor authentication, where this adds more security by requiring two or more verification methods, such as entering a password and providing a fingerprint. Then we have what is called single sign-on, and this allows users to log in once and gain access to multiple related systems or services without needing to re-enter credentials for each one. So for example, multi-factor authentication is common in banking apps where you need a password and a one-time code sent to your phone in order to access your information. Next, we have what is called authorization, and this determines what resources a user or system can access and what actions they are allowed to perform. And then up under authorization, we have permissions. So administrator accounts, they tend to have high-level permissions that allow them to change settings, install software, or access all files. And user accounts, they tend to have limited permissions to reduce the risk of accidental or malicious system changes. And then we have a concept called least privilege model. So this security concept means that users should have the minimum permissions necessary to perform their job. By limiting access, organizations can reduce the risk of insider threats or accidental damage. So for instance, a marketing team member should not have access to confidential financial reports if it's not a part of their job function. And then we have our final A, which is accounting. This refers to tracking and logging user actions. This includes maintaining logs of login attempts, location tracking, and web browser history to ensure all activities can be monitored and reviewed later if necessary. Logs, they help in auditing and can be crucial in tracking down suspicious behavior. So for example, an organization might track login attempts to detect unusual patterns, such as failed login attempts from different countries, which might indicate a hacking attempt. All right, and the last concept in this framework is non-repudiation, which ensures that a person cannot deny their actions or communications after the fact. Non-repudiation is closely tied to authentication by verifying someone's identity with secure methods, such as digital signatures. It becomes harder for that person to claim that they didn't perform the action. And digital signatures and encryption, they are key tools used to guarantee non-repudiation. Also, by strictly controlling and logging access to systems and files, authorization policies also support non-repudiation. If only authorized users can access a file, it is easier to prove who did what and when. And then proper logging and tracking, this also helps with non-repudiation. So logs provide detailed records of actions performed by users, and since they are time-stamped and immutable, they serve as evidence in case of disputes. So for example, in financial transactions, non-repudiation mechanisms are critical to ensure that users cannot deny authorizing a transaction. All right, so let's summarize the key points we've covered in this lesson. So confidentiality, integrity, and availability. These are the pillars of the CIA triad, ensuring data is protected, accurate, and accessible. Privacy, this involves understanding the risks posed by social networking, email, file sharing, and the handling of personally identifiable information, with laws like GDPR setting clear standards. Then we have the AAA framework, authentication, authorization, and accounting. This plays a central role in controlling access to resources, tracking user actions, and ensuring non-repudiation. Authentication, this verifies who a user is through methods like passwords, multi-factor authentication, and single sign-on. Authorization, this ensures users can only access what they need based on permission levels. And accounting, this monitors and logs user activity for security auditing. And then we have non-repudiation. This ensures that individuals cannot deny actions or communications that they have initiated, supporting accountability and trust in digital systems. Now, understanding these security concepts is vital for the CompTIA Tech Plus exam and real-world cybersecurity. By mastering these fundamentals, you will be prepared to protect systems, data, and users from evolving threats. All right, so with all of that being said, let's do some check on learning. So the first question is, which of the following best defines the confidentiality aspect of the CIA triad? Is it ensuring data is accurate and unaltered? Is it ensuring data is accessible to authorized users? Is it ensuring only authorized users can access the data? Or is it ensuring all data is available at all times? And the correct answer is it ensures only authorized users can access the data. So confidentiality is one of the key principles of the CIA triad, which ensures that sensitive information is only accessible to those who are authorized to view it. Protecting confidentiality typically involves encryption, access controls, and other security measures. Next question. Which of the following is an example of personally identifiable information? Is it the color of a user's favorite shirt? Is it a user's IP address during web browsing? Is it a user's social security number? Or is it the operating system on a user's computer? And of course, the answer is it is a user's social security number. So personally identifiable information, this refers to any information that can be used to identify an individual uniquely. Examples include social security numbers, full names, and birth dates. So protecting personally identifiable information is essential for maintaining privacy and adhering to regulations like GDPR. And our final question, which of the following describes non-repudiation in a security context? Is it preventing unauthorized changes to data? Is it ensuring that data is accessible to authorized users? Is it verifying that a user cannot deny their actions? Or is it preventing unauthorized access to data? And the correct answer is it is verifying that a user cannot deny their actions. So non-repudiation, this ensures that once an action is taken, such as sending an email or making a transaction, the user cannot deny that they performed that action. This is commonly enforced through digital signatures and logging mechanisms. In this video, we'll explore methods to secure devices and essential security best practices. With the increasing reliance on digital devices, it's critical to protect them from threats, both physical and digital. In this video, we'll cover key areas such as security awareness, securing devices, best practices for device use, safe browsing, and privacy considerations. So let's get started by first understanding the importance of security awareness. All right, so security awareness, this is the foundation of protecting devices and data. Many attacks succeed because of human error rather than technical vulnerabilities. The most common threats involve social engineering tactics. Some of those tactics are as follows. First one is social engineering, also known as phishing. This is a common social engineering attack where an attacker tricks a user into providing sensitive information like login credentials through fraudulent emails, websites, or messages. So for example, an email that looks like it's from a trusted source may ask you to reset your password, but the link takes you to a fake website that steals your credentials. And here are some of the signs of phishing. So you want to look out for poor grammar, unusual sender addresses, and suspicious attachments or links. And you always want to verify before clicking or responding to unexpected emails. Next, we have what is called malicious or compromised content. So malicious content, this refers to harmful software such as viruses, worms, or ransomware hidden within files, downloads, or links. These can affect your device and steal data or compromise systems. And compromised content may come from legitimate websites or applications that have been hacked. So always ensure content is downloaded from secure and trusted sources, which we will discuss later in this video. So security awareness, including recognizing phishing and malicious content, this is crucial for avoiding many types of cyber attacks. Next, let's now move on to securing devices such as mobile phones and workstations. This involves multiple layers of protection to ensure devices and data are safe from their attackers. So the first thing we'll talk about is authentication. And this is the process of verifying a user's identity before granting access to a device or system. And strong authentication methods include the following. We have passwords, so you want to ensure that they are complex and unique. We also have what is called multi-factor authentication, and this combines something you know, such as a password, with something you have, such as a smartphone, or something you are, such as your fingerprint. So using strong authentication, this helps protect devices from unauthorized access. Then we have what is called anti-malware, and this is software that is designed to detect and remove harmful programs like viruses, worms, or spyware. So you always want to keep your anti-malware software up to date to ensure new threats are detected. Also, another aspect of securing your device is implementing firewalls. So, a firewall, this monitors and controls incoming and outgoing network traffic. It acts as a barrier between your device and the internet, blocking unauthorized access while allowing legitimate communications. And both hardware and software firewalls can protect workstations and mobile devices. Then we have patching and updating. So, patching and updating software and operating systems are critical to closing security loopholes, and vendors they release patches to address vulnerabilities, so make sure automatic updates are enabled to stay protected. And then we have physical device security. So physical security is as important as digital security. And some key practices include implementing devices like cable locks. And these can secure laptops and workstations physically, especially in public places like libraries or offices. And then we also have USB locks, and these prevent unauthorized access via USB ports by locking or disabling them, ensuring that malware cannot be introduced through physical media. So securing devices with authentication, anti-malware, firewalls, patching, and physical measures are essential steps in defending against both cyber and physical threats. Let's now discuss best practices for using devices securely, including managing software licenses and validating software sources. So the first thing we're going to talk about is licensing. So software licensing is crucial for ensuring you use applications legally and securely. And there are several types of licenses. The first one is called an open license. And this is software that is free to use, modify, and distribute. While convenient, you want to ensure the source is trustworthy and not altered by malicious actors. Then we have what is called a proprietary license. And this is a closed source software requiring a license like Microsoft Windows or Adobe products. And these often come with support and security updates. And then we have subscriptions, one-time purchases, and perpetual licenses. So a subscription license, they are paid regularly, providing ongoing access and updates. A one-time purchase, this grants access without future payments, but may lack updates. And then we have a perpetual license. This allows for permanent usage, but may include upgrades. So always verify licensing information, use legitimate product keys or serial numbers, and avoid using pirated software, which can introduce security risks. All right, next let's talk about software sources. So it is essential to download software from legitimate sources to avoid malicious or compromised software. So you want to research and validate your sources. So before downloading any software, research its legitimacy, ensure it comes from a trusted website or application store. And then you want to go to OEM websites or the original equipment manufacturer. So for device drivers or system software, always download from the official manufacturer's website to avoid compatibility issues or malware. And then we have third-party websites. You want to be cautious with third-party websites. You want to ensure that they are reputable by checking reviews and using virus scanners. And then we have removing software. So it is important to periodically review and remove software that is no longer needed, because unwanted software can take up system resources, which can slow down your device. It can pose a security risk if it is outdated and hasn't been patched. And in the worst case, malicious software can be installed without your knowledge. So properly uninstall unused programs and always scan for malicious software regularly. And then this brings us to software piracy. So be aware of the risk of software piracy. Using pirated software is illegal and also dangerous, as it often includes malware and other security threats. So it's important to ensure that all software installed is legally obtained and correctly licensed. All right, so let's move on to safe browsing practices. So as the internet is a major vector for malware and attacks, securing your browsing habits is critical. So let's talk about certificates. So when browsing websites, it's important to verify the security of a site through its certificate. So when it comes to validating certificates, websites with valid certificates, they display a padlock icon in the address bar, showing that they use secure HTTPS connections. And this ensures that any data you enter is encrypted. Then we have invalid or expired certificates. So if a website shows a warning about an invalid certificate, you want to proceed with caution. This could indicate a potential security risk, and you should avoid entering sensitive information on these types of sites. And then that brings us to privacy considerations. So, when using the web for communications or file sharing, you want to be mindful of your privacy. So, when you're on social networking sites, you want to be careful about the personal information you share. You want to avoid oversharing details like your address, phone number, or work schedule, which could be used by attackers for social engineering. When it comes to email, you always want to be cautious with unsolicited emails or attachments. Phishing attacks often come through email with the goal of stealing personal information. When it comes to file sharing, only share files through secure, trusted platforms. Avoid downloading files from untrusted sources as they may contain malware. And then when it comes to instant messaging, you want to use end-to-end encrypted messaging platforms to ensure your communications are private and secure. Now, artificial intelligence powered systems also bring new privacy concerns. AI systems such as chatbots or AI assistants, they collect and analyze large amounts of data. So you want to ensure that privacy settings are properly configured to minimize unnecessary data collection. All right, to wrap all of this up, securing devices and following security best practices is essential for protecting your data and devices from cyber threats. So let's quickly recap. You want to be aware of social engineering attacks like phishing and malicious content. You want to secure your devices using strong authentication methods, anti-malware, firewalls, and regular updates. You want to practice physical security for workstations and laptops. You want to follow best practices when using software by ensuring proper licensing, downloading from trusted sources, and regularly removing unnecessary software. And you want to practice safe browsing by paying attention to certificates and being mindful of privacy concerns. By following these methods and best practices, you'll be well on your way to securing your devices and passing the CompTIA Tech Plus certification exam. All right, now with all of that said, let's do some of this wonderful check on learning. So the first question is, which of the following is not a recommended practice for securing a workstation? Is it regularly updating the operating system and software with patches? Is it installing and maintaining anti-malware software? Is it using simple, easy to remember passwords for convenience? Or is it enabling the firewall on the workstation? And the correct answer is using simple, easy to remember passwords for convenience. So simple passwords are easier to guess or crack, making them a poor choice for securing a workstation. Strong, complex passwords or using multi-factor authentication are recommended for better security. And regular updates, anti-malware, and firewalls, they help protect against these threats. Next question. When installing software, which of the following is the best practice to ensure it comes with a legitimate and safe source? Is it downloading from third-party websites that offer free versions or paid software? Is it checking the software availability on the original equipment manufacturer's website or the official application store? Is it using any software that appears highly rated on public forums? Or is it downloading software from peer-to-peer networks for convenience? And the correct answer would be checking for software availability on the OEM website or the official application store. So to ensure that software is legitimate and safe, it should be downloaded from trusted sources such as the OEM's website or an official app store. Third-party sites, peer-to-peer networks, and random software from public forums can often contain malicious or compromised content. And our final question, what is the purpose of device physical security measures like cable locks and USB locks? Is it to prevent unauthorized software installations? Is it to prevent physical theft of the device or unauthorized access to its ports? Is it to ensure the device is kept up to date with security patches? Or is it to block phishing attempts and other social engineering attacks? And of course, the correct answer is it is to prevent physical theft of the device or unauthorized access to its ports. So physical security measures like cable locks and USB locks are designed to prevent the physical theft of devices or the misuse of ports by unauthorized individuals. These measures are critical for protecting devices in public or shared environments. And other measures like anti-malware and software updates, they handle the virtual threats. In this video, we'll be discussing password best practices. Passwords are the front line of defense in protecting personal and organizational data. Weak or compromised passwords are one of the most common ways cyber criminals gain unauthorized access to systems. So understanding how to manage and create strong passwords is critical. So in this video, we'll break down several best practices you need to know, including password length, complexity, expiration, password reuse across sites, password managers, and much more. So let's go ahead and dive in. All right, first let's talk about password length. So password length, this is one of the most important factors in password security. The longer a password, the harder it is for an attacker to crack it using brute force attacks where all possible combinations of characters are tested. And the best practice recommendations for password length are as follows. It needs to be at least 12 characters for general use, but many security experts recommend even longer passwords, anywhere between 15 to 20 characters for critical accounts like administrative or financial systems. And a longer password creates exponentially more combinations, making brute force attacks far less effective. So for example, a 6-character password may take minutes to crack, but a 12-character password could take centuries using the same techniques. So the longer the better when it comes to security. All right, next is password complexity. So password complexity, this involves using a mix of character types to make the password harder to guess. A complex password should include the following. There should be uppercase letters, lowercase letters, numbers, and special characters. So for example, a password like capital P @ lowercase SSW0RD123 exclamation point that is way more secure than simply using lowercase password 123. However, complexity alone isn't enough if the password is short. A strong password combines both length and complexity, so avoid using easily guessed patterns such as password 123 exclamation point or admin 2024 exclamation point. Now let's talk about password history and password reuse. So password history, this refers to a system policy that prevents users from reusing old passwords within a certain number of changes. So for example, if a system has a history requirement of 5, users won't be able to reuse their last 5 passwords. Now, why is this important? Well, it prevents users from changing their passwords to something weak or previously compromised, and it encourages users to think of a new unique password each time. Also, password reuse. This is when someone uses the same password across multiple accounts or websites. And this is a significant security risk because if one website is compromised, attackers can use the same password to access other accounts, especially for email or financial systems. So a key best practice is to never reuse passwords across different sites. Each account should have a unique password to ensure that a breach of one account doesn't compromise others. All right, next up is password expiration. So password expiration, this is a policy that forces users to change their passwords after a certain period, typically every 60 to 90 days. And this practice helps reduce the chance of a password being used indefinitely, especially if it has been compromised but remains undetected. And it also ensures that even if a password leaks or is stolen, it will only be useful for a limited time. However, modern research has shown that forcing frequent password changes can lead to poor practices, such as users creating predictable passwords or just incrementing numbers at the end of their passwords. To balance this, organizations might now require password changes less frequently, but enforce stronger complexity and longer length. All right, so let's move on to password managers. So a password manager, this is a software application that helps users generate, store, and manage complex passwords for different accounts. And here are the key advantages. So password managers, they store all of your passwords in an encrypted vault. You only need to remember one strong master password to access the vault. They also allow you to create unique, strong passwords for every account, ensuring you don't reuse passwords across multiple websites. Also, password managers often include autofill functionality, which automatically fills in login information, reducing the risk of mistyping passwords or falling for phishing attacks. So some popular password managers include tools like LastPass, 1Password, and Bitwarden. So using a password manager, this reduces the likelihood of weak or reused passwords across different accounts. Next, let's talk about password privacy. So, the first rule of password privacy is never share your password with anyone. Even within trusted environments, sharing passwords can compromise security. So, here are a few tips for maintaining password privacy. So, once again, you want to never write down your password, whether on sticky notes or in an unencrypted digital file. Writing down passwords can easily lead to unauthorized access. You also want to be aware of phishing. So, phishing attacks are a common method used to steal passwords. You want to always verify the authenticity of a website or email requesting your credentials, and you want to use two-factor authentication. So where possible, use two-factor authentication to add an additional layer of security. So even if someone obtains your password, two-factor authentication requires a second form of authentication, like a code sent to your phone to gain access. So essentially, maintaining password privacy is about being vigilant and cautious with where and how you use your passwords. All right, now let's discuss the password reset process. So when a user forgets their password, they typically need to go through a password reset process. And the best practices for resetting passwords include the following. You want to verify the user's identity. So before resetting a password, the system should ensure the person requesting the reset is the account owner. And this is usually done by sending a verification code to an email or phone number associated with the account. Also, we have temporary links or codes. So password reset links should expire after a short period, usually within an hour or less, to prevent unauthorized use. Do you want to prompt for a strong password? So when resetting, you want to ensure that users are required to choose a password that meets length and complexity requirements, and you do not want people to use the same password. So it's essential that users create a new unique password instead of reusing a previous one. So essentially, secure password reset processes, they are critical to prevent unauthorized individuals from gaining access to an account. Now let's talk about changing default usernames and passwords. So devices like routers, smart devices, and other connected systems often come with default username and passwords, and these are well known and easily accessible to hackers through simple online searches. And some best practices include you want to always change default credentials immediately after setting up a new device. Failure to do so leaves devices vulnerable to attack. And you want to use unique username and passwords, so choose something that's not easily guessable and follows the standard rules of password length and complexity. So hackers, they will often target default credentials because they are easy to exploit. So changing them, this is a critical step in securing your devices. And then finally, let's cover enabling passwords. So some devices or systems, they come with password protection disabled by default, especially in home networks or personal devices. And so the best practices for enabling passwords includes the following. You want to enable passwords for all accounts. So whether it's an operating system, network device, or online account, you want to ensure that password protection is enabled. You want to secure the BIOS UEFI settings. On computers, securing access to the BIOS or UEFI with a password. This can prevent unauthorized users from changing hardware level settings. And you want to restrict access to important systems. So always ensure sensitive systems require a password for access, especially administrative accounts. So by enabling passwords, you will add an additional layer of protection to prevent unauthorized access to critical systems. So to summarize, securing passwords is vital for both personal and organizational security. And the key best practices for passwords are as follows. You want to use long and complex passwords. You want to avoid reusing passwords across sites. You want to regularly change passwords, especially for critical accounts. You want to utilize password managers for secure storage and management. You want to keep passwords private and never share them. You want to follow secure password reset processes. You want to change default credentials on new devices, and you always want to enable password protection on all systems. So these practices are essential for keeping your data and systems from unauthorized access and will help you succeed in understanding password management for the CompTIA Tech Plus certification exam. All right, now with all of that being said, let's do some check on learning. So the first question is, which of the following is the most important reason for requiring a minimum password length? Is it to make the password easier to remember? Is it to improve compatibility with legacy systems? Is it to enhance security by increasing the number of possible combinations? Or is it to reduce the need for password expiration policies? And the correct answer is it is to enhance security by increasing the number of possible combinations. So a longer password increases the number of possible combinations an attacker would need to try to crack the password, thus making it more difficult to guess or brute force. And this is why password length is a critical aspect of password security. Next question. What is the primary purpose of using a password manager? Is it to store passwords in plain text for easy access? Is it to generate and securely store complex, unique passwords for each account? Is it to remind users to change their passwords regularly? Or is it to ensure that passwords are reused across multiple sites? And the correct answer is it is to generate and securely store complex, unique passwords for each account. So password managers, they help users create and store strong, complex passwords for each account, eliminating the need to remember multiple passwords and reducing the likelihood of password reuse across sites, which can increase security risks. And our final question, why is changing default username and passwords on devices important? Is it because default credentials are often weak and widely known? Is it because it allows users to remember their credentials more easily? Is it because it improves device performance? Or is it prevents the need for future password changes? And the correct answer is default credentials are often weak and widely known. So default username and passwords are commonly known to attackers, making devices vulnerable if the default credentials are not changed. Changing them, this enhances security by making it harder for unauthorized users to gain access. So welcome to this in-depth exploration of encryption use cases. Now, encryption, this is a key element in protecting sensitive data in today's digital world. And in this video, we're going to cover the following. We're going to talk about plain text versus ciphertext. We're going to talk about data at rest encryption. And we're going to talk about data in transit encryption. So by the end of this video, you'll have a solid understanding of how encryption is applied in various real-world scenarios. So with that being said, let's get started. To understand encryption, we need to start with the basics, and that is plain text versus ciphertext. So plain text, this is data that is readable by humans and computers without any special decryption or decoding. And examples include emails, Word documents, and messages before they are encrypted. In plain text, this is vulnerable because anyone who intercepts the data can easily read it. Next, we have what is called ciphertext, and this is the result of encrypting plain text. It appears as a jumble of seemingly random characters, and to convert plain text into ciphertext, an encryption algorithm or a cipher and a key are used, and only someone with the appropriate decryption key can revert ciphertext back into its original plain text form. So here's a real world example. So imagine sending an unencrypted email over the internet. The email is in plain text, meaning anyone who intercepts it can read its contents. If you encrypt the email, however, the email contents become ciphertext, and only the intended recipient who has the decryption key can read the email. So transitioning from plain text to ciphertext, this is the foundation of securing sensitive information. With that being said, let's now look at where this encrypted data resides. All right, so data at rest. This refers to data that is stored on a device or medium and is not actively moving from one location to another. Encrypting data at rest, this ensures that it remains secure even when the device is off or if the physical storage is compromised. And there are different levels of encryption for data at rest that we're going to get into right now. The first one is called file level encryption. In file level encryption, this protects individual files by encrypting them independently. Each file is encrypted with its own key, ensuring that even if one key is compromised, it does not grant access to the other files. And the use cases for this are protecting sensitive documents like contracts, reports, or spreadsheets on a personal computer, and ensuring that specific files on shared network storage are only accessible to authorized users. And a real world example is as follows. Financial department encrypting spreadsheets that contain payroll data. Even if someone gets unauthorized access to the file system, the encrypted files will remain protected. Next, we have what is called disk level encryption, and this is also known as full disk encryption, and this encrypts the entire storage device, including the operating system, applications, and files. And the use case for this is protecting entire hard drives on laptops or desktops in case of theft or loss, and also for ensuring all data on backup storage devices like external hard drives are encrypted. And a real-world example is as follows. So many modern laptops, they use technologies like BitLocker for from Windows or File Vault from Mac OS to provide disk level encryption. If a laptop is stolen, the thief cannot access the data on the encrypted hard drive without the decryption key or the password. And then we have what is called mobile device encryption. So mobile devices such as smartphones and tablets are often vulnerable to theft or loss, making encryption absolutely crucial. So the use cases for this are as follows. It encrypts sensitive data on mobile devices such as contracts, emails, or banking apps. And it ensures that mobile devices used for business such as bring your own device or BYOD are secure. And a real world example is as follows. So most smartphones today, they come with built-in encryption options. So for instance, Android and iOS, they encrypt the entire device by default, ensuring that sensitive data like financial apps or work-related files cannot be accessed without a proper passcode or fingerprint. So encrypting data at rest, whether at the file, disk, or mobile device level, is essential to securing information from unauthorized access. And with that being said, we're going to look at how encryption works when data is being transmitted. All right, so let's talk about data in transit encryption. So data in transit, which is also called data in motion, this refers to data actively moving from one location to another, whether across the internet, a private network, or even between devices. Encrypting data in transit ensures that no one can intercept and read the data while it's being transmitted. And the first type we're going to talk about is called email encryption. So emails are one of the most common forms of communication, but sending emails without encryption is like sending a postcard in the mail. Anyone who intercepts it can read its contents. And the use cases for email encryption are as follows. So it's for encrypting sensitive emails between business partners or clients, and it's used for preventing email interception in transit over public or untrusted networks. In a real world example, protocols like secure multi-purpose internet mail extensions are pretty good privacy. They encrypt email contents, making them unreadable to unauthorized parties, and only the intended recipient who has the decryption key can access the email content. Next, we have what is called HTTPS, or Hypertext Transfer Protocol Secure. And this is the secure version of HTTP, which is used to encrypt data transmitted between a web browser and a server. And its use cases are as follows. So it is for securing sensitive web transactions like online banking or shopping. And it's also used for ensuring the confidentiality of login credentials, form submissions, and any sensitive data transmitted over a website. In a real world example, when you see the padlock icon in your browser's address bar, it indicates that the website is using HTTPS, and this ensures that any information you submit, like your credit card number during an online purchase, is encrypted, preventing eavesdropping. Next, we have what is called a VPN, or a virtual private network, and this creates a secure tunnel for data to pass through, encrypting all information traveling between the user's device and the internet. And its use cases are as follows. So it is used for encrypting data when accessing the internet over public Wi-Fi networks, and it's used for ensuring secure communication between remote employees and their company's network. So a real world example, a remote worker accessing corporate resources while on a public coffee shop Wi-Fi, they will use a VPN to secure their connection. The VPN encrypts all their traffic, ensuring that no one in the public network can intercept sensitive information like work emails or project data. And then we have what is called mobile application encryption. So mobile applications, especially those that deal with sensitive data, often encrypt data in transit to ensure that information like login credentials or personal data is protected. And its use cases are as follows. So it is used for protecting personal information like login credentials and credit card numbers when using mobile apps. And it also ensures secure transactions and communications between mobile apps and servers. In a real world example is as follows. So most mobile banking apps use encryption to protect customer information while it is transmitted between the app and the bank servers. This ensures that sensitive data such as account numbers or transaction details cannot be intercepted by malicious actors. So to wrap all of this up, encryption plays a crucial role in protecting sensitive data, both when it's stored and when it's transmitted. So here's a quick breakdown. So plain text is human readable, but is vulnerable to interception. Ciphertext is what we get after encrypting plain text, rendering it unreadable without the right decryption key. For data at rest, email encryption secures sensitive email content. HTTPS, this ensures safe communication between browsers and websites. VPNs encrypt all traffic between the device and the internet, protecting users on untrusted networks. And mobile application security, this secures the data transmitted between mobile applications and their servers. Now, understanding these common encryption use cases is essential to safeguarding sensitive information, and this is a key component of the CompTIA Tech Plus certification exam. Now, with all that being said, let's do some check on learning. So the first question is, which of the following best describes the difference between plain text and ciphertext? Is it plain text is encrypted while ciphertext is unencrypted? Is it plain text is readable by humans while ciphertext is unreadable until decrypted? Is it plain text can only be used in mobile applications while ciphertext is used for emails? Or is it plain text is used for data at rest while ciphertext is used for data in transit? And the correct answer is plain text is readable by humans while ciphertext is unreadable until decrypted. So plain text, this refers to data that is in a readable format without encryption, whereas ciphertext is the result of encryption, making it unreadable without the proper decryption key. And the purpose of encryption is to convert plain text into ciphertext to protect data from unauthorized access. Next question. Which encryption method is commonly used to protect data in transit, such as when browsing a website? Is it disk level encryption, file level encryption, HTTPS, or AES 256? And of course, the correct answer would be Hypertext Transfer Protocol Secure, or HTTPS. So this is the encryption protocol used to secure data in transit between a user's web browser and a web server. It ensures that the information exchanged during browsing sessions is encrypted and protected from interception. And our final question, what is a common use case for file level encryption? Is it protecting emails sent over the internet? Is it for securing data stored on a mobile device? Is it for encrypting data as it moves through a VPN tunnel? Or is it for ensuring disk level encryption on hard drives? And the correct answer is it is for securing data stored on a mobile device. So file level encryption is typically used to protect specific files or data stored on devices such as mobile phones or computers. This ensures that sensitive data is encrypted and cannot be accessed if the device is lost or stolen. Disk level encryption, on the other hand, this encrypts the entire storage medium. In this video, we're going to walk through how to configure security settings for a small wireless network. For the CompTIA Tech Plus exam, understanding how to secure a wireless network is essential. So by the end of this video, you'll know how to configure key settings like changing the service set identifier, changing the default password, and understanding the difference between encrypted and unencrypted networks, including open networks, pre-shared key networks, and the different wireless security standards such as WPA, WPA2, and WPA3. So let's go ahead and get started. All right, so one of the first things you should do when configuring a wireless network is to change the SSID. So what is an SSID? Well, that stands for Service Set Identifier. And this is simply the name of your wireless network. It's what users see when they search for available Wi-Fi networks on their devices. And the SSID is used to differentiate your network from others in the area. So why should you change the SSID? So by default, most wireless routers come with a standard SSID like Netgear or Linksys, and keeping the default SSID is a security risk because attackers can easily identify the brand of router you're using, which may give them information about possible vulnerabilities. So changing the SSID, this adds a layer of obscurity. Now, while it won't stop a determined hacker, it prevents your network from becoming an easy target. So this is how you go about changing the SSID. So first, you want to log into your router's web-based configuration page. And this is usually done by typing the router's IP address like 192.168.1.1 into a web browser. Then you want to enter the admin credentials, and these are often found on the router itself or in its user manual. Then you want to navigate to the wireless settings section, and this is where you'll see the option to change the SSID. And then you want to choose a unique SSID that doesn't give away personal information or the router's make and model. And then you want to save your settings and reconnect devices using the new network name. So by changing the SSID, you essentially reduce your network's visibility to potential attackers. Another critical step in securing your wireless network is to change the default password. So why is changing the default password important? Well, most routers, they come with a default admin username and password like admin or admin password. And these default credentials are widely known and are often listed in online databases, making it easy for attackers to gain access. And once an attacker has access to your router's admin page, they can change your settings, monitor network traffic, and even lock you out of your own network. So how do you actually go about changing the default password? Well, after you log into your router's admin page, you want to go to the administration or security section. You want to change both the admin username and password to something more secure. You want to create a strong password that should include a mix of uppercase and lowercase letters, numbers, and special characters, and it should be at least 12 characters long. And then you want to save your settings. So changing the default password, this will ensure that your router's configuration settings are protected against unauthorized access. Next, let's discuss the difference between encrypted and unencrypted networks. So let's talk about an unencrypted network, which is also known as an open network. So an open network, this does not require a password to connect, and anyone within range can connect to your Wi-Fi. While open networks are convenient, they are insecure because the data transmitted between the user's device and the router is not encrypted. This means that anyone within range can potentially intercept and view your data, including sensitive information like passwords and personal details. And then we have what is called an encrypted network. So encrypted networks, they require a password, and data transmitted over the network is protected using encryption protocols, which scramble the data so that it cannot be easily read by attackers. And there are several types of encryption protocols you should be familiar with. First one is called WPA, the other one's called WPA2, and then you have what's called WPA3. And we're going to break down each of these encryption methods in a second. But before we do, let's talk about a pre-shared key. The pre-shared key, or the PSK model, this is used in home or small business networks, and it is very simple to configure. But what exactly is a PSK? So in a PSK model, the network uses a shared password to authenticate devices. This means all users must know the same password to connect to the network. Now, how you go about setting up PSK encryption? Well, in your router's wireless settings, you'll see options for encryption types such as WPA, WPA2, or WPA3. You want to select the option for PSK, which is also referred to as WPA-PSK or WPA2-PSK. Then you want to enter a strong, unique password that users will need to connect to the network, and then you save your settings. So PSK encryption, this is easy to set up, but keep in mind that all users, they share the same password, which can be a security risk if the password is leaked or shared with unauthorized users. Now let's talk about the different wireless encryption standards, which are WPA, WPA2, and WPA3. So WPA, this stands for Wi-Fi Protected Access. And WPA, this was introduced as a temporary fix for weaknesses in what is called WEP or WEP, which stands for Wired Equivalent Privacy. And it uses what is called TKIP or Temporal Key Integrity Protocol to improve security. However, WPA is now considered insecure by modern standards and is not recommended for use in most cases. Then we have what is called WPA2 or Wi-Fi Protected Access 2. And this became the standard for wireless security in 2004 and is still widely used today. It uses AES or Advanced Encryption Standard, which provides encryption that is highly secure. And WPA2-PSK, this is the most common setup in home networks and offers a good balance of security and usability. So if your router supports WPA2, this will be the most recommended setting for your users. And then we have WPA3 or Wi-Fi Protected Access 3. And this is the newest and most secure wireless encryption standard that was introduced in 2018. It offers a stronger encryption with individualized data encryption, meaning even if a password is compromised, it's much harder for an attacker to intercept data. Also, WPA3 improves security for public open networks by using what is called opportunistic wireless encryption, which encrypts connections even without a password. So if your router and devices support WPA3, then that will be the best choice for your enhanced security. And now let's walk through the process of configuring your wireless network for maximum security. So you want to access your router's admin page. So open a web browser and enter your router's IP address. And typically it's going to be something like 192.168.0.1 or 192.168.1.1. You want to log in using the admin credentials and then change those immediately if they are still set to the default. Next, you want to change the SSID. So navigate to the wireless settings section and change the SSID to a unique name and avoid using personal information in the SSID. Then you want to set up your encryption. So you want to go to the wireless security section. You want to select either WPA2-PSK or WPA3-PSK for encryption. Then you want to create a strong, complex password for your network. And if your devices support WPA3, you want to select this for better protection. If not, then roll with WPA2 because it is still secure for most small networks. Then after that, you want to change the admin password. So in the administration or security section, change the router's default admin password to something strong and unique. And then you want to save and reboot the router. So after making these changes, save your settings and reboot the router if necessary. And then ensure that all devices reconnect using the new SSID and password. All right, so securing a small wireless network requires a few essential steps. So changing the SSID, updating the password, and configuring strong encryption like WPA2 or WPA3. By taking these steps, you protect your network from unauthorized access and ensure that your data remains private and secure. Also remember, open networks or older encryption protocols like WPA are not recommended due to their vulnerabilities. Now, I want to thank you for watching this video, and you should feel confident configuring security settings for a small wireless network. And this knowledge will not only help you on the CompTIA Tech Plus exam, but it'll also help you out in real world scenarios when setting up your home or business Wi-Fi. Now, with all of that being said, let's do some check on learning. So the first question is, what is the primary reason for changing the default SSID on a wireless network? Is it to increase the signal strength on the network? Is it to prevent unauthorized users from connecting? Is it to avoid revealing the router brand and model? Or is it to enable faster connection speeds? And the correct answer is it is to avoid revealing the router brand and model. So changing the default SSID, this helps prevent giving away information about the router, such as its brand or model, which could be exploited by attackers looking for known vulnerabilities. It is a basic step to enhance network security, but does not by itself prevent unauthorized access. Next question, which encryption protocol offers the highest level of security for a wireless network? Is it WEP, WPA, WPA2, or WPA3? And of course, the answer is going to be WPA3. So this is the latest and most secure encryption protocol for wireless networks. It offers enhanced protection over WPA2, particularly on public networks, and provides better encryption methods to safeguard data in transit. WPA and WEP, they are older protocols with a bunch of vulnerabilities. And our final question, what is the recommended action after setting up a new wireless router for the first time? Is it enabling WEP encryption? Is it changing the default admin username and password? Is it disabling the SSID broadcast for better performance? Or is it setting the SSID to default for easier identification? And the correct answer is changing the default admin username and password. So it is critical to change the default admin username and password immediately after setting up a new router to prevent unauthorized access. Many default credentials are publicly known, making the network vulnerable to attacks if left unchanged.